Why is it black? Oh, there we go. So I will do a quick intro and then I will point at you. So all we do is play that in the. You've got another mic. Okay. Good afternoon, everyone, and welcome to FOSSASIA 2021. This is the first time we've run the summit entirely online. There are a handful of us here at the Lifelong Learning Institute, but everything else is happening online through Eventia and Big Blue. Most of the work on site is being done by myself, Dan Blumen, and Ambrose, who's coming out with all the YouTube streams and recordings and things occur. But we are about ready to start. For the keynote, we'll shortly introduce Hong Fook and Mario, but immediately prior to doing that, I have an introductory video for you.
All right.
Hello everyone, welcome to the FOSSASIA Summit 2021. My name is Hong Fook Dang. I founded FOSSASIA together with Mario Bailing. I am very glad that you are joining us here today. The FOSSASIA Summit will spread out over the entire week, from Saturday, March 13 to Sunday, March 21. Sessions go from 10 in the morning until 10 in the evening. We have a fantastic lineup of 190 speakers from 42 countries. Together, they conduct more than 180 sessions, workshops, panels, covering hot tech topics such as AI, machine learning, open robotics, CAD software, open source hardware development and production, blockchain, search, databases, COVID-19 and open health, technological independence, digital privacy, microservices, cloud, Kubernetes, kernel development, licensing, quantum computing, and many more. Before I share more program details with you, I would like to thank our sponsors and partners for their support. Lifelong Learning Institute, our venue partner. Microsoft, Oracle MySQL, OpenTab Keysight, Elasticsearch, Linux Professional Institute, Cloud Native Computing Foundation, UNESCO, UI Lizos and FreeBSD, and our organizing partner, OpenTech. Last but not least, I would like to thank our team members, contributors in the community, and organizations which help to make this event possible, as well as the hubs joining us from across Asia. Thank you. We run the summit in Singapore time zone, but on the schedule, you can change to your local time. Generally, we start in the morning with workshops, panels, and keynotes take place in the early afternoon, followed by talks and presentations. In the evening, we conclude the event days with more hands-on workshops. This is a general roster, so expect some diversion here and there. Now let me give you a quick summary of the week. Day 1, Saturday, 13th of March, is our opening day. The main topics of the first day are robotics, open hardware, Pocket Science Lab, Python and web development for Eventia platform with FOSSASIA's Head of Engineering, Arif Chamar. Day 2, Sunday, 14th of March, we cover the topic of open hardware, in an extensive track with speakers giving insights on different stages of open hardware creation, from the idea stage to production and sales. Our team members from the Pocket Science Lab will share the latest developments of the next version of the board, as well as the BS Lab Python project. Furthermore, we have related sessions on open science, lightning talks, and a second Python web and development workshop. Day 3, Monday, 15th of March. Topics are blockchain, hyperledger, hardware, design, and you can learn how to solder. Day 4, Tuesday, 16th of March. We are getting into deep tech topics with sessions about DevOps, cloud, containers, kernel and platform, quantum computers, and Kubernetes. Day 5, Wednesday, 17th of March. With the help of our long-term supporter, MySQL, we are running the database track, of course with sessions about MySQL as well as NoSQL, databases and AI, monitoring, and PostgreSQL. Day 6, Thursday, 18th of March. Digital sovereignty and technological independence are of an increasing concern around the world. We'll cover this topic from different angles with sessions about cloud technologies, security, privacy, IoT, blockchain, and open source voice assistants like our Sushi AI, developed by the FOSSASIA team. Day 7, Friday, 19th of March. Artificial intelligence has been a big topic for the FOSSASIA community and for our team over a number of years. 2021 has been a particularly big year for us in regards to AI, as we onboarded the Wisdom projects to FOSSASIA from Facebook at the beginning of the year. Over 3,000 projects use Wisdom on GitHub and many in conjunction with PyTorch. We are excited to welcome the PyTorch product development lead in this track. Other sessions cover the future of search, scikit-learn, and natural language processing for Indian languages using Python. Day 8, Saturday, 20th of March. Join us on this day for more sessions on DevOps, Python bot programming, container registries, open source licenses versus available source licenses, the FOSS community in Asia, OpenStreetMap, and another workshop on Python and web development. The last day of the event, Sunday, 21st of March, we start with more lightning talks from the Asian community. After that, we have a number of sessions on open health and COVID-19 apps, where we learn about the experience with developing tracing apps around the world. Today's world problems, from the pandemic to climate change and poverty, are considered by more and more people as existential. This causes more and more people to reflect, reconsider the way we work and live. Free and open global collaborations are a way to solve the problems of our times together. How can we use the way we collaborate in the FOSS community as an example for global collaboration on all levels of society? Instead of a top-down approach where a small number of people in the governments and a few big companies decide the future of humanity, which means today the survival of humanity. The pandemic has shown that we need a better and faster decentralized approach to solving global problems. At the closing, we will discuss the topic on solving world problems with open technologies. Sunday afternoon, 21st of March, the final day of the event. So please join us. That sounds a lot, right? Yes, I think so too. We have an amazing program. There is so much to learn, and we appreciate everyone's contribution to make the summit a success. I had the chance to meet most of our speakers already in our test calls. And I have to say, even though we are far apart, I feel very connected to the speakers who have been so supportive and understanding while we are facing challenges in our daily lives, and of course, while preparing for the event. I wish we will continue to develop our connection in the summit with all of you and support each other by sharing our knowledge and experience. Thanks to all our speakers. You are wonderful. And thank you in advance to all participants who will join the exchange in the upcoming days. Do you know that the FOSSASIA Summit is run entirely on our own open source solution, EventYay? EventYay is an event management system built by FOSSASIA with various integrations such as Jitsi, Big Blue Button, and Rocket Chat. We have been using it for physical events for a few years, but this is the first time that we use the system to run a larger online event. In the preparation for the summit, we were looking into different options. Our goal with the FOSSASIA Summit has always been to connect people. We do not want to increase or create a gap between the audience and the speaker. We want to see interaction. We want to see Q&As and discussions. We want to bring people together to start talking about their ideas, projects, common goals, and in the best case, to start to collaborate. Therefore, we decided to integrate EventYay with platforms that allow interaction between speakers and participants. As we all know, this could result in technical challenges, as interactive video solution can't be scaled up so easily. Our team in Singapore tested many different scenarios. We hope that you like our setup and enjoy the event. Please report any issue to our project checker. If you want to chat with another participant, please use the event chat. In the next few minutes, I will share with you some tips how you can take full advantage of the virtual event experience on EventYay. So sit back and enjoy. Where are we? If you look at the side panel on your left, under video rooms, you can see that we are now in the welcome room. I'm here on the screen the entire time throughout the event. Feel free to drop by if you want to see me or watch this video again. Below the welcome room is a list of all conference video rooms. Most sessions will take place in the main hall. Some workshops will be held in the workshops room. Discussion is of course for discussion, continued conversations with speakers and other participants. Support rooms is for technical support and testing. Livestream is our YouTube channel. In case the room is full, you can just follow the event from YouTube and check back in a few minutes later. In the Lifelong Learning Institute room, there are workshops conducted by computer science students in Singapore. They are giving the workshops from a physical room at the Lifelong Learning Institute. Above the video rooms, there is a chat channel where you can chat with other participants or speakers. So this side panel is actually everything you need. From here, you can go to other pages like schedule, exhibition, or the speaker page. Now let's take a quick look at some basic viewer features to make you feel a bit more comfortable with the system.
Use public chat to communicate with other participants. Please be nice and respect one another. All advertisements and spam messages will be removed. Moderators have the right to remove bad actors at any time to keep a friendly environment for everyone. Please use shared notes to ask questions to the speakers. Moderators will take questions from the shared notes, not the public chat. You can set a status for yourself like raising hand, happy, or applaud, etc. by clicking on your name. Click on the small person icon on the top to hide the public chat and the sidebar. Click Minimize to hide the presentation. This is especially useful when you only want to see the speakers, for instance, in a panel discussion. At the bottom right corner, there is a Maximize option to make presentation full screen. Next, let's learn how to update your profile and change your public name. Under your profile name, select the Account option. Here you can update your name, email or upload a picture. Your profile is private by default. To have your name and picture visible to other event attendees, you need to make your profile public. Here you can see the difference between a private and public profile when you join a session.
So, did you manage to change your profile name? I changed mine to HB Dang. There is also my Twitter handle, in case you need to find me on the internet. What do we do now? Let's take a look at the very colorful, beautiful, and super interesting schedule of the event.
How to view event schedule and program details on Eventia. From the sidebar, select Schedule. There are various filters that help you explore the schedule, such as date, time, popularity,
Go to vote for your favorite sessions. We will give out a popularity award at the end of the event for the most attended session. So don't forget to vote. Please go to the schedule, stick as many sessions as possible. And now, let's visit the virtual exhibition together.
Let us show you the Summit's virtual exhibition. From the sidebar, select Exhibition. Here you see a list of exhibitors. Click on the one you want to explore. For example, click on the FOSSASIA virtual booth. It will direct you to the FOSSASIA exhibitor page. Here you can see the description, their social media channels and contact form. You can also view all related sessions of the exhibitor. Scroll down a bit further, you see their tweet updates, a featured video that can be played directly, and also a slide deck with more information. Now go back to the top where you find a button to join exhibitor video room. Click on that button to enter a Jitsi room where you can video chat with the exhibitors. Due to different time zones, some exhibitors have indicated their office hours in the description when they will be around to answer your questions. On the side panel you can navigate back to the schedule, exhibition page, or the main video conference room. There is also a new feature that allows you to view one exhibitor after another by clicking the previous or next button like this. Now, have fun exploring the virtual exhibition.
I invite you to visit the virtual exhibition. Here you can meet our sponsors, partners, and many open source projects, communities, makerspaces, universities, and IT student clubs in the FOSSASIA network. Let us now talk about the development activities of FOSSASIA, our software and hardware projects, some of the highlights of the year, and our coding programs of the last 12 months. I would like to invite Mario to this review and future outlook. Mario, please join me.
Yes, thank you very much, Hanfok. So, a lot of things have happened, and last year, the FOSSASIA Summit, it was a big bucket of many different things. Well, it was inspiring, depressing, it was amazing, saddening, and at the same time, it was making us very happy. So in March 2020, the news were just overwhelming. And within a week, most of our speakers canceled their in-person appearance. Despite all the challenges, we were able to pull off the event with an exhibition, physical sessions, and last-minute online talks. So it was amazing what this community and our team was able to achieve in no time. Due to new regulations from one day to the other, we as organizers weren't even able to enter the venue ourselves because of the new restrictions for arrivals who were abroad less than 2 weeks before an event. But with the help of the FOSSASIA team and our partners, we were able to run the event and receive praise for many people for making it possible to share knowledge and experience. But other news then again were depressing. We received reports that the pandemic was spreading, and despite people dying in parts of the world, for some companies, personal gains were more important than helping others. We learned about schemes where masks were being bought around the world and then sold back from Chinese businesses. And we learned about companies preventing people from replicating ventilator spare parts using copyright and patent laws. It really made me sad.
But a year later, things are turning to the better, and the FOSS community is playing an essential part. Today, we have open source tracing apps in many countries, and we have open validator projects around the world. One of the projects we'll be presenting here from Brazil. It is a pleasure that our friend and former FOSSASIA speaker, Ulrich Neuwirth, is engaged in this project.
Yeah, I think it's always challenging with all the international names. We have Ulrich Neuwirth, or in German we say Ulrich. Looking forward to Ulrich or Ulrich to your talk here in the upcoming days. And we see a drive towards open hardware everywhere. Producing more open source products is a topic. Local production facilities. So all these things we have as like topics at the event. And our friend Kiwi Deng will be sharing his work with the Lions Forge laser cutter that is produced in Singapore at the virtual exhibition which we have organized here. We also welcome the FreeCAD project, and we have one of the core developers again here from Singapore giving a talk about it. Then another developer here, Bunny Huang, he will present his idea about the precursor project in the past, but now it has become a reality, and Bunny will give a keynote about how he developed the project from idea to reality and he ran a hugely successful crowdfunding campaign this year. Before the lockdown last year, also the FOSSASIA team was present at different industry events. We were in Nuremberg, and I met Eric Pan there, the CEO of Seed Studio. We discussed some ideas for cooperation in regards to open source voice assistant, and here we have the Suzy AI project at the FOSSASIA community, in the FOSSASIA community. And this year, Eric will share his views on how the open ecosystem empowers developers to digitalize entire industries.
Last year, also before the lockdown in Delhi, we joined the Open Tech Summit India with the support of the International Organization of Software Developers, IOSD. And we had inspiring exchanges with FOSSASIA contributors and many students. A big shout out to our friends from IOSD, who are also a hub network partner of the FOSSASIA Summit. Thank you.
Then we organized the Open Tech Business Day Thailand, where one of the top real estate companies hosted us in one of the highest buildings in Bangkok. Our friends and our inner source manager expert, Mishari Mukbil, organized the event, and we had a wonderful social activity with live music and Thai food. And not to forget, with Mishari's help, we were also able to find the best mangoes in the city.
And we joined up with the community in Myanmar, where we were welcomed at the university and connected with the faculty members and students at several sessions at Bar Camp Yangon, co-organized by FOSSASIA's long-term mentor Coco Ye. We had a chance to exchange ideas and knowledge with the participants. The enthusiasm in Myanmar was just overwhelming. Unfortunately, they can't be here with us today due to the current political situation in the country. We will be thinking of them.
At our event table in Myanmar last year, many students joined us, and they immediately started to work on translations of FOSSASIA projects. I really love this hands-on approach of people in Myanmar, and today we hope that all our friends and lovely people in the country are okay and will overcome the situation to achieve the freedom they and all the people in the world deserve.
We had big plans for 2020 in Asia, but the rest of the year, the world was shut down. We did not expect March was the last time we saw our team members in person. Until today, I haven't got to see my sister, Eden Dang, since then. She was one of the most important managers of the FOSSASIA Summit. She is currently living in Vietnam. All the team members are in Singapore, India, China, Japan, Australia, Myanmar, and also in Europe, in Germany, France, and Sweden. It is amazing that we are able to work together on the summit despite the geographic barriers.
While we had to overcome a lot of challenges and adapt our plans, these challenges also made us stronger in the FOSSASIA team and community. FOSSASIA is resilient, and with a focus on continuously developing solutions, with a strong community engagement, we are sustainable. Despite operating on a tight budget, despite old-time partners that stopped their support in the crisis, and despite event sponsorships and project partnerships of 2020 that were cancelled, we continue to build strong relationships with new partners, and we are also establishing new cooperation projects.
To facilitate new cross-border partnerships, we had already established an entity in Germany a while ago, the OpenTech GmbH. The goal of OpenTech is to develop FOSS community projects into full consumer products and support partners with open source consultants to make the transition to engaging in the FOSS ecosystem. One of the customers of OpenTech has been Daimler, and we are excited to welcome Jonas Maslowski from Daimler again this year at the summit to learn about the open source journey of the company.
OpenTech also joined OpenNext, which is supported by the Horizon 2020 program of the European Union. In cooperation with 19 partners across Europe, we are developing a consumer version of FOSSAsia's Pocket Science Lab. The goal of OpenNext is nothing less than changing the future of product creation under the tagline, "The future is open and community-based." Robert Mies, the project coordinator from the Technische Universität Berlin, the Technical University, he will share more about OpenNext at the event as well.
FOSSASIA's goal has always been to foster global collaboration and to overcome cultural barriers and borders. I want to connect Asian community to grow the FOSS ecosystem. In 2020, I was honored to get elected to the board of the Open Source Business Alliance. The industry association represents more than 170 member companies that employ approximately 10,000 people and generate more than 1.7 billion euros annually. Connecting our teams with the open source companies will benefit everyone. But let's talk a bit about our projects.
So let's start with the Pocket Science Lab. This year, the code base of the Pocket Science Lab, the PS Lab Python component, improved a lot. We had a new member joining, Alex Basman, and he did major improvements. The component was also added to PyPy, and many people are downloading it since from there. We have a new hardware version, nearly finished. This is continued to be developed under the leadership of Padma M. Padma, you always abbreviate your name with M because Sri Lankan surnames are very long. Yeah, definitely share your entire name in chat. People want to know. And another thing that we have a fruitful exchange established with OpenTap, which is a project of Keysight Technologies, a big hardware company here that's also supporting the FOSSASIA Summit. Furthermore, OpenTap will share here at the event some insights into their project and conduct a workshop with the Pocket Science Lab. And other connections we made are with open hardware developers around the globe. So we have regular open hardware meetings every Saturday, and we welcomed people from different projects. For example, Ron Minich, the original author of Coreboot, and he will also be joining us at the FOSSASIA Summit here in a panel about the future of open hardware.
The next project is SUSE AI. The goal of SUSE AI is to provide an alternative to Google Home, Alexa, and Siri that track user continuously. In the middle of the pandemic last year, we got invited to Ars Electronica, Europe's biggest arts and electronics festival in Austria, where we conducted a workshop on how to set up SUSE AI. Many participants managed to get SUSE AI running with the help of Norbert, who is originally from Austria. He supported the session remotely from his home in Japan, and also Wang, another FOSSASIA mentor from Vietnam. The most important work I have seen in the SUSE AI project last year was the simplified installation process. We are now able to install SUSE on different Linux systems and have it run within a short amount of time on Linux desktops.
And another project, Wisdom. We onboarded the Wisdom project just a few months ago after working with Facebook on changing the license to an OSI approved open source license. And that just happened a very short time ago. Maybe you saw the news. The contact with the Wisdom developers came through friends in the community who shared the info that the Wisdom project was potentially looking for a new home after it was developed several years at Facebook. Wisdom is a widely used data visualization project, and we are very happy to welcome the project core developer, Jack Urbanek, at the event. So, what about other projects, Hongfuk?
We have many small projects that are used by a number of people for specific purposes. For example, our Storm Helper, it used to create daily Storm emails, and there was a major update of the project last year. It can also happen that projects which once had many followers kind of lost momentum, and we see a decreased level of contribution, such as the project Fimi, image sharing app.
Yeah, so it's not always like that everything is going up and getting better. There are waves, and sometimes projects become less active, then they become more active again. We've also seen that. But like, we have a variety of projects, and we also tried to onboard another project which is called Voice Republic, and it used to be a startup, but the Voice Republic founders, they were friends of us, and so we had an idea. We had the goal to open source Voice Republic and continue the service which shares audio recording, so people can log in, record and stream files. And it was particularly interesting for events. It took us months to open source it, as some privacy questions and potential security issues had to be addressed first. The original Voice Republic team supported us a lot. But after running the service for some time, new security issues arose, and it was very difficult to update some of the dependencies.
Unfortunately, the website is down at the moment, even though there have been a lot of efforts. It seems like it is much easier to develop a project completely in the open from the beginning than opening it up at a later time.
So let's talk about a project that is open since the beginning.
Yes.
Open event.
And this is also the project that I am most excited about.
So we are using it here at the FOSSASIA Summit. It's hosted on the eventjay.com domain. And let me talk a bit about the project. We run the repositories of the project under the name Open Event, and the project has seen several iterations and technology updates. In the last year, we focused a lot of our efforts on the project, as we didn't see that any other system was providing a virtual event experience that was using entirely free and open source software. While a lot needs to be solved, the feature set and improved system stability is there. With our team, we achieved it, but we had over 1,000 contributions from the community at large. And I think that deserves an applause, and it is very impressive. So congratulations and applause for everyone. And EventJay aims to support event organizers. This is a real focus. So we're not just trying to have a ticketing system where people sell like tickets or something like that. We really try to provide all the features from ticketing, from ticketing and registrations to the call for speakers, scheduling, and the complete virtual event experience with video rooms and chat. We are now providing the project as a service for partners such as OSI, where Hongfuk is on the board. We organized here the State of the Source event. We have Nextcloud events running on the system. The Open Source Business Alliance is there. Skipper, Zalando, Kixcloud, Fostival, Inner Source Commons, and more are already using the system and providing feedback. And I also want to name our friends from Les Rencontres Régionales du Logiciel Libre a French organization that also provided translations and helped us to solve some bugs. So there are more to come, and the FOSSASIA Summit is a huge improvement like that we have seen here. Like we've seen a lot of improvements, and we're doing a lot here around the event to improve the system as well. Of course, that means we need more manpower, and so we are continuously looking for new talents who are interested to join the team under the lead of Arif Jamal. So there are several job openings. If you want to join, please check it out and join one of the workshops here.
And finally, I would like to talk about our programs. This year, we changed our coding program to run over a period of 6 months. In the program, top contributors to our projects can receive a prize. I would like to thank our mentors, contributors for their hard work and dedication. Please check out the program on codeheap.org. Then we had a new cooperation with our long-term partner, UNESCO. At the beginning of this year, we ran the Tech Cool program in partnership with the UNESCO Bangkok, where we invited participants to share ideas to create products to support the creative industry. We distributed prizes of more than 50,000 USD in the program.
That's impressive. So, and now, Hongfuk, what do we have at the FOSSASIA Summit 2021?
Yes, 2021. I still can't believe it. You know that we did not expect so many people for this event. In the beginning, we thought something like 30 to 40 submissions. Instead, we got hundreds of session proposals. We had to make some very hard choices when we put together the program. We have over 190 speakers and really amazing profiles among them. I am particularly excited to welcome Greg Kaha. What is his last name, Mario?
His last name is Kro Hartmann. I think it's also a German origin, like a name originally from the German region.
Yeah. So Greg is the maintainer of the Linux kernel, which is one of the most important positions in the world, in my opinion. I can't wait to learn what he will share at his session about kernel development.
We have so many interesting sessions and outstanding speakers, but another example of how open source changed the world is clearly blockchain. Many people know it today because of rising Bitcoin currency rates, but many years ago, blockchain enthusiasts were often regarded as strange geeks. Brian Behlendorf symbolizes the success of blockchain. He is a person with a strong community background and today the head of Hyperledger at the Linux Foundation. On Monday, Brian will be on a panel together with me and many different other blockchain industry experts, and he will also give a keynote on that day.
So, what is the future outlook and the opportunities with free and open source solutions? Of course, there are more things to share, more projects we started, more projects we want to do, events we participated, people we met, and inspiring experience we had in the community. The question is, what do we learn from them? How can this help to solve problems of our time? At the summit, we want to learn about your ideas, your solutions. We need open exchange and open collaboration more than ever. We want to set an example here at the FOSSASIA Summit. So let's do it. Have a wonderful event, everyone. Thank you.
Thank you.
Thank you, Hongfuk and Mario. Oh, yeah, I'm We're not hearing you, Humphrey. Am I still muted? All right, we can. Actually, why can't I hear myself? Hello, everyone. We can't hear my own Hongfuk. This is not going to work very well. Oh dear.
Okay, sorry. Can you hear?
Can you hear us now?
Okay, let me switch to my computer. Switch this off. Switch all of it off. Just entirely off the screen.
We've lost him again.
Okay, so we switched the laptop. We always have a lot of backups.
Okay.
And so thank you very much for the question, guys. And I think we tried to explain a lot, but you haven't heard us. So, thank you for your patience. So always have to check out things like we're still at the beginning of the event and experience some glitches here and there. So thank you for bearing with us. And yeah, I think we can start with the first question. And if that's okay with you, Roland. Yeah. Okay. So Hongfuk, could you share a bit like how can I contribute to FOSSASIA? How can I become a contributor?
Yeah, so we have a lot of projects hosted on GitHub. We have a GitHub channel when you can go in and talk to people. So basically, if you want to contribute in terms of like coding, you can search for the projects of the language of your choice. There are many issues from beginners to advanced, and we also running the Code Hit program. I put the link in the channels. That you can also check out if you want to. The whole idea of the Code Hit program is to guide young developer people in their early journey to contribute to open source.
Yeah, and like I want to recommend also to you the workshop that's happening tonight with Arib. There is like a step-by-step explanation, for example, how to contribute to Open Event, the project here that we used to run the eventday.com website. And yeah, you can learn about Python, web technologies. Maybe that could be a good starter if you want to contribute. Another way to contribute is through events. And I think like people here at the event will also be able to share more information with you. Roland just went away. But I think like Roland, maybe you could also share something when you are back about your experience of joining the event team here. How is that as a contributor? If I'm interested to join teams for running events.
Okay, so I think the workshop that you mentioned also answer to question number 7. Will there be workshop explaining about FOSSASIA projects? The answer is yes. So there is event Yay workshop tonight. There also a workshop on Pocket Science Lab, and there also a workshop on SUSI. So there are several workshops related to the FOSSASIA projects. Please check out the schedule and join us. Let's continue with other questions. Can we order T-shirt, Mario? I think there are people related.
Can we order shirts? Yeah, +3. So definitely, like regards to shirts, it's always the challenge in Asia. It's to send shirts around, unfortunately. So what we want to share with you is like, yeah, maybe some more artwork here at the event, so you can print out your own shirt. We know people in the US, you can send your shirt from one place to the other, or in Europe from one country to the other. You know, like for example, when we send something from Vietnam to India, there is there could be a lot of difficulties, taxes and so on. So unfortunately, we can't send shirts around Asia, but we will be distributing some shirts to the community in India, Vietnam, and Singapore. This is what we're able to do.
So this is also related. Will speakers get any swags related to the shirt, I assume?
Well, speakers, yeah, would love to give them swag, but it's the same problem that I just mentioned. Speakers and participants who are active in the sessions will get something more. They will get knowledge, they will get experience, and they will get eternal fame. So yeah, what is a T-shirt compared to eternal fame on the internet and around the world?
Yes, and additionally, speakers can also pick up the T-shirt next year if you visit us in Singapore.
Definitely.
Okay, so what's next? So can we have good documentation to explain more about FOSSASIA projects, because the current documentation are hard to understand.
Hard to understand. And I read here something like documentation marathon. This is an awesome idea. I don't know who asked that question. I would love if you guys could, like, in brackets, add your name behind your question so we can follow up with you. Definitely we should do a documentation marathon. We have like, I think, quite good documentation in the open event projects, but like different components, right? They have like in the README, you can follow up how to deploy it and so on. But, you know, documentation, they can never be enough, and they can never be good things. Roland is directing us that we are at the end of this opening session, but there will be more opportunities to connect with us, and I think we will answer the remaining questions here in the shared notes. So I hope you got some impression of our work. I see a lot of questions, and I think there's never enough time.
Yes, never enough time, but the event running the entire week. So check back in at any time. We will be here. We can answer your question on the chat as well. So there is a chat room outside Big Blue Button. Feel free to join us there.
Check out the join button, and thank you very much for getting started and joining here the event. We saw over 100 people joining. Back to Roland. Thank you very much, everyone.
Thank you, Hong Fook, for the most technically complicated conference we've ever held. We're going to take a break now for about 4 minutes. Please come back at the turn for Kush about the building blocks of the Kushal, if you're in the room, please let me know. See you all soon. Kushal, can I ask you to turn your camera on, please, so we can check you before the... in about 2 minutes.
Can you hear me?
And yes, yes, beautiful. Okay. And you can work out how to upload your presentation and that sort of... Okay to upload your presentation?
Yes, your audio is dropping actually a little bit for me.
Really? Shouldn't be.
Can you see?
Not sure why that is. Right.
Also,
Okay, please stand.
I have 2 minutes, so
I'll
quick
take you-
question. Can you, Ronald, can you make my video full screen for the live stream?
Yes, when I turn my camera off and you turn your camera on.
Okay, so not now, because at the last part I have screenshots, but I would prefer to do a live demo.
But it's in your control. You can turn your camera on and off as you wish. There's a button down near the bottom.
Okay, now so my camera will be on, and I can actually do. I have a full OBS setup this side, so. And there are other people also saying that, Ronald, your audio is dropping. Okay, camera working.
Hello again, everyone, and welcome back after that extremely short break. I understand my audio might have a problem, so hear me. Our speaker is Kushal Das, Public Interest Technology and Privacy Advocate, Python core developer and such things. He's going to talk to us about an open source system for Kushal, you have 25 minutes, including Q&A. Please take it away.
Thank you. So as I begin, just a quick note. I wonder if you all will be able to full screen my video instead of me changing the slides. If that is okay. So.
Sorry, what was the question?
So I was saying, like, if people can just full screen my video, because then I can control the slides in one place.
Yes, so just stop your camera.
Yeah, the camera is now like.
On the bottom, turn your camera off.
Sorry, Ronald, you're very badly broken.
The bottom on big blue button, underneath your presentation, at the right for turning your camera off.
Yeah, no, I'm asking everyone.
No. Underneath the presentation, there are 3 or 4 buttons. The one at the right will let you turn your camera off.
Okay, sorry guys, just to drop in. Kushal, I think I understood your question. You just go ahead, no need to check with us. Do as you like.
Okay, perfect. So welcome everyone. My talk is software in the public interest. A little bit about myself. I'm a C Python code developer, also a director at Python Software Foundation, and I'm part of the Tor project code team. You can find me on Twitter, and if you have any questions later on, you can pass them across over there. And you can also find the URL of my blog here. To begin with, what is SecureDrop? SecureDrop is an open source whistleblowing platform. It was originally created by the late Aaron Swartz and the late James Dolan, along with Kevin Paulson. It was first time announced back in 2014 at Hackers on Planet Earth conference. SecureDrop allows anyone to simply submit documents or messages to the selected news organizations by themselves. There are more than 70 organizations around the world who are using this particular software. Few of those names and logos you can see here. The full list of organizations are actually maintained in the securedrop.org website. So for the rest of the talk, I'm going to talk about how SecureDrop works and the different building blocks of the different open source projects we are depending on. To begin with, SecureDrop application is actually split across two different servers. The application server, or in the image AppServe, is actually a Python web application written using Flask framework. This runs on top of Apache HTTPD, the daemon, and it creates two different interfaces. One is source interface, the other one we call journalist interface. And we are going to learn about it later during the talk. The second server is a monitoring server, which is running a host-based IDS system, OSSEC in this case, which monitors the application server and sends out encrypted alerts to the system administrators. It also sends some other messages at regular intervals to the administrators. Now, both of these hardware server boxes are connected to a dedicated firewall. We prefer to use pfSense-based firewall, and this firewall enables us to completely isolate the SecureDrop environment, both the servers, from the rest of the network. Now, here is the most important thing to remember, that SecureDrop is not a hosted service. At Freedom of the Press Foundation, we maintain the source code, but we do not host any instances. Every news organization who wants to host SecureDrop, they actually get all the servers and the hardware firewall, put them inside a locked room for better physical security, and then connect the firewall with their organization network. SecureDrop, the application actually depends completely on Tor project. If you never heard about Tor before, Tor is an open source project. It's a non-profit based out of US. It's a community and also more than 7,000 computers around the world, which altogether creates an open network where anyone can connect and browse internet in an anonymous private way. The Tor core, the daemon, actually runs on the application server, and that goes through the NAT of the organization, the network details from the news org, without requiring any public IP address, in such a way that anyone over Tor network can actually access the application server. When a source, means a person like you and me, wants to submit some document or send some messages, they can actually visit the source interface via Tor browser, and they will upload the documents or send those messages to the application server. And those documents get stored in a completely encrypted form using the public key of the instance. We use GNU-PG for this encryption purpose, and all the files and messages from the sources are stored in an encrypted form. Here is a screenshot from the source interface. It will be an onion address. That means you will have to visit it over the Tor browser. And if you are visiting for the first time, you can click on that blue icon, or you can actually come back later with your login details and send some more information or visit for messages from the journalists. The journalist, in the other hand, they use a pre-configured Tails operating system on an USB drive on a laptop, which is generally stays inside the same locked room, where they can go in physically, connect the Tails operating system to the laptop, and that enables them to connect to the journalist interface. The journalists have to use their username, password, and two-factor authentication to log in. And then they can visit different sources which already submitted some documents or messages. They can see those messages and they can download them. But you have to remember that whatever the journalist can download at this moment, all of that is actually still encrypted. And the journalist laptop, the Tails, in the image, it's written JWS, Journalist Workstation. It doesn't have the decryption key. So the journalist still cannot view the original content of the message. So generally what they do, that they copy these files into another fully encrypted USB drive, which we call transfer device. And before we know what they do with the transfer device, we actually want to go back to both the interfaces. On the top, it's a source interface, which is the onion address anyone can access over Tor network. But the interface journalists use, that is behind an authenticated onion service. That's a feature from the Tor project itself, which enables us that even before login, only very few selected people using the pre-configured Tails reach to that web page, web application. So even if you are on Tor network, you will not be able to reach to the journalist interface of the SecureDrop instance. After copying the sources, like information, into the transfer device, the journalists have to take it to a second computer just beside in the same locked room, which is air-gapped. We call it Secure Viewing Station, SVS. Its air-gap means it's not connected to any network. The only way to get the data onto the system is via this transfer device. And this laptop is also running another Tails, which has the private key of the instance. So here on this computer, the journalist can actually decrypt and view the messages. And they can also then decide whether they want to take a printout or they want to export it to a separate, let's say, USB drive, so that they can share within the news organization. Now, till now you heard how the system works for the journalist and sources, but let's talk about the actual building blocks inside. If you want to do development of the tool, you can actually check out the source code from GitHub and start a Docker instance, which creates a development instance within few minutes. For the actual production servers, we use Ansible. Many of the roles and playbooks are written by us, and many of them are from the community. And using the same, with the help of Molecule project, you can also set up your own SecureDrop production quality virtual machines using Vagrant. Virtual machines, that means it will not have the firewall, but you can still see how a production SecureDrop instance works. There are also staging instances so that you can test out your changes very fast. We write our test cases using Python's PyTest module. And at the same time, for the integration test cases, we use Python Selenium to test over the Tor network via the Tor browser. And SecureDrop works on top of the Ubuntu operating system. And just 2 days ago, we released SecureDrop 1.8.0, which is the first SecureDrop release which can run on Ubuntu Focal, the 20.04 release, the LTS release. As I mentioned earlier, that SecureDrop works around the world. So the SecureDrop application is also translated in multiple languages. We managed to achieve this with the help of localization lab and many translators from the community. There is a URL in the PDF, or in the screen right now, so you can visit it later on if you want to translate SecureDrop for your language. Now, anyone developing software facing users, or actually any developer who wants to increase the security and the usability at the same time, gets into a difficult choice. As you heard about SecureDrop till now, you can understand that SecureDrop is not an everyday web application which can be configured and deployed everywhere. It requires high level of security focus. Actually, for the development purpose, we think about security for each and every patch, each and every feature we write. So increasing the usability at the same time is always a difficult choice. And if you remember the journalist workflow, where they have to download from one computer, copy into a transfer device, copy to the second computer, then only they can click and view, it takes a lot of time. So with the help of folks from the community and also usability experts, we started working on a new project which is called SecureDrop Workstation, and that is based on the Qubes operating system. If you do not know about Qubes, it's a Linux operating system which heavily uses Zen virtualization inside, which allows different applications within the same Linux to run on as a separate virtual machines, thus allowing us to create air-gapped system within the one single laptop. At this moment, I will move into actually a live demo where I can actually show you a little bit of how this works. So here you can see the Qubes operating system, and this is the new client which we wrote for the journalist. Here the journalist can log in just like any other chatting application, and they can see all the details from the server, the submissions, the messages, etc. And if I click here, you may not be able to read this, but you will notice that there are many icons representing different virtual machines. And if you remember about the Tor authenticated service, the journalist works interface, here we have a couple of VMs which has the same authentication details, which allows this application to talk to the journalist interface via the web API. At the same time, the VM where this tool runs doesn't have any network connection. So I'll try to log in here. You will notice that login is a little bit slow because it's happening over the Tor network. And this application will look like most probably most of the known chatting applications we use on phones and computers. There are messages from sources. We can actually type here and write some message and send it across. But one interesting thing to notice will be the submissions. So for example, here is a submission. I can actually click here and download another file from the server. It will download and auto decrypt for us. As I mentioned, SecureDrop is focusing a lot on the security of the journalist too, not only the sources. So it may happen that somebody submitted malware targeting the journalist. So when the journalist actually can open these files, what this tool will do, that it will create a fresh virtual machine for each of the files, which we'll try to visit. So I'll just click here once, and you will see a black box appearing somewhere here, exactly this one, which says that it's creating a new disposable VM. Disposable VM is a Qubes term. It means it's a VM which will be destroyed as soon as the work is done. The VM will not have any network access. That means even if it's a malware targeting Linux system, it will not have any access to any other VM within the laptop or talking outside network. So the message says it started, and now I'm going to hopefully see within seconds the actual text. So we can see it was a text file. It opened in, I think, gedit, the standard Linux text editor. And the moment I close this, Cube's operating system will take care of destroying that VM completely. So that next time, when the journalist, you can see here, another message says that VM is gone. So next time when the journalist will click on any of the files, it will open in a completely fresh VM, giving them an air-gap clean place to view these messages. This application and how Cube works, explaining that will take actually a lot of time. So I tried to just showcase how it works. And there are multiple screenshots on the slides I have in the PDF. Here is a screenshot of the team where we mentioned like there are only few people who are working full-time on SecureDrop. There are few people working part-time. And then there is the community of contributors around the world who are contributing via the GitHub repository. If you want, you can go to demo.securedrop.org and visit a demo yourself. It has both the journalist and the source interface. It contains also the authentication details so that you can log in. There are a few other links mentioned here. And also, many of the major projects SecureDrop is built upon, all of them are free software and open source projects, and they work based on the donation. So if you want, you can go to those projects and donate as you wish. I think I'll move into the Q&A session right now. I have around 6 minutes, I believe. So thank you.
Yes, I have you as 6 minutes. So, do we have questions for Kushal? I just realized we did not clear the questions from the main session. Okay. Nope.
I will be available in the conference during like in the other chat rooms and general places, and also available over Twitter. So if you want to know anything particularly about the cubes, I still have time to demo if you want to actually ask.
Well, that would be awesome, because I wanted to ask just now how it works. But if you could demo a bit, Kushal, I would definitely appreciate it.
Yeah, I mean, I did the demo of the client application right now. So do you want something else?
Yes, please go ahead.
No, I mean, Mario, this is the demo which I was talking about. And so like the people who are new to cubes, it's another Linux system, but as you can see, there are multiple VMs, and I can choose to, let's say, run Firefox at the same time, 3 different instances in 3 different VMs, which are completely different from each other. And each of those VMs can also have completely separate networking preferences, like without networking or via some particular VPN. Or in our case, for example, there is a Unix VM, which is called SD Unix here, which contains the authentication details to go over the Tor.
Okay, so could you tell us a bit more? Like you mentioned the team and the community. So how is it like? How can I onboard? How can I participate? And what are the current challenges?
Okay, so we also have a GitHub channel, which is mentioned in the PDF. And also, if you go to github.com, Freedom of Press, and then SecureDrop, you will find the Gitter URL there also. That's the easiest part to start. Most of the people are online during US time zone, that is between EST and West Coast, East Coast and West Coast. I think the biggest problem as a community project for us is that the actual setup is pretty complex, and it requires many different projects to work together. So for new people, Sometimes it's much easier to start contributing with the easier Python topics as far as it is just another web application. But making any bigger changes, but anyone has to understand how the system works. So that takes a lot more time. And for example, if you want to work the Python PyQt application, which you just now saw, the client application, it will require you to have a separate laptop running Qubes OS. There is no way you can virtualize this and test it out. But if you want to only develop the application without thinking rest of the system, you can do it in any like a Linux or Mac computer.
Okay, excellent. And I see more questions popping up. I think like people were just surprised, and now like questions are coming in. So please share the link here in the chat. And I think also people would love to join the Gitter chat. So they're asking for for this. And another question is what expertise is needed for the contribution? You mentioned infra and Python. Could you like share a bit like what level of expertise is needed and a few other skills?
So I'm sharing the links here in the chat. So Python, anyone who is okay with writing some amount of Python and mostly focusing on web application, they can start looking into multiple bugs. But otherwise, we have parts of the project where we need, starting from UX to documentation to testing ideas to multiple DevOps kind of work, which is, I guess, still a buzzword. I don't know. But we have a lot of things to work on. And as you can see, the actual team is very small in number. So more people are always more like welcome. And I think Edwin told me that there is a discussion room, so I can move into the discussion room after this.
Okay, so that's pretty nice. And yeah, we are at the end of the session. Any final words from you, Kushal? I think definitely, please, like if you could join the discussion room. And we are still at the beginning of the event, so I think a lot of people are still figuring out how it works, right? So just like open the side panel and click on the discussion room. It's a Jitsi discussion room where you can just connect with each other also directly. So I definitely recommend whoever is interested in the project and would like to start contributing, please join Kushal. Kushal, how long would you be available there? Half an hour or what? How long can we come there?
I'll be there right now, another half an hour maybe, and then later in the day. Like there's still a lot of talks and things available, so I'll be in the discussion room. If anyone wants to contribute, they can come over there.
Awesome. I know you also have a very active Twitter channel where I think people could possibly contact you at a later time. Please share the link also here in the chat. Would be awesome. It's always like very interesting for me to follow your tweets. So thank you very much. We really appreciate. And I think like a lot of speakers will also be inspired how you run this session with an awesome background and the small icon of yourself on the back and so on. So it's really nice. I actually would love to get another session from you one time to show me how this is done. And I saw that on YouTube. It's also very nicely shared. So thank you very much. We definitely appreciate this talk, and it will be shared later. And Gaurav Soni just says OBS rocks. So thumbs up for OBS and thumbs up for making it very professional. Kushal, see you in the discussion room. Thank you very much.
Thank you. Goodbye, everyone.
Thanks, Kushal, and thanks, Mario, for stepping in while I was having some difficulty. Join us in a minute for Marco to talk to us about open source robotics. Marco, if you're in the room, please hang around and I'll set you up.
Marco, if you are here, please activate your camera.
Hello.
Aha. Yeah. All right. So, you should upload your presentation. Are you able to upload? Oh. Marco, you are muted. There's a microphone button down the bottom you can press.
Yeah,
Hi,
I'm just waiting.
And are you able to upload your?
Yeah, do you want me to, can I share my screen? I'll share my screen.
You also can. I'd only point out, as we just saw with the other thing I'd point out is that if you try to play video that way, it will tend to. But if you're just sharing like slides or.
But I can share the video on the actions button, right?
Yeah, that's the way to share a video.
All right, just let me share my screen. All right. Entire screen. All right, are you able to see my screen? Should be a bit confusing now. All right. All right. Thank you, guys. I'll start presenting then, I guess. All right, I can't see the chat while I present, so just so you guys know, I'll be doing a full presentation here.
Actually, we're at time. Please go ahead.
All right. So thank you very much. Thank you, Roland. Very excited to be here. Thanks a lot to the FOSSASIA team. It's very amazing that they managed to get this through, even given the constraints and the situations. So my name is Marco. I'm located here in Singapore, and I work for this company called Open Robotics. And we basically make a bunch of open source projects related to robotics, of course. And I'm here to present them and tell you what we do and a little bit of what is going on here. So let me start a bit with who we are. Basically, we are a company that we like to create open software and hardware platforms for robotics. And we like to use those platforms to solve important problems and help others do the same. That is our main goal. A little bit of where we are. We have like a main hub on California, which is where everything started. And then we also have a little bit of a big team in Singapore, which is where I'm located, and where we're doing like some specific developments. And then we also have a bit of the rest of the spread out people in different locations around the world, with European hub in Madrid, with 3 guys over there. So the main robotics projects that we run in Open Robotics, there's the Robotics Operating System, which is one of the main ones and the most famous one, I guess, which started with ROS and now is transitioning into ROS 2. So ROS is slowly being deprecated. Now we also have Gazebo, which is the simulation software for robotics. And we're also doing rewriting that is called Ignition. I won't talk too much about this because Luca will talk later about Ignition a bit more and about the simulation part of robotics. And then we also have RMF, which is the Robotics Middleware Framework, which is the main software that get us PC here in Singapore. So we're working a lot in RMF. So let's talk a bit about ROS. And for that, I want to try to share this amazing video that the guys from Red Hat made about the robotics. Is there a video? So they made this amazing video, and this is yep.
You know, let me just tell you the story a little bit.
There wasn't a lot of cohesion in the robotics community, and everyone just had to start over every single time.
Where it takes years to make even incremental improvements or add even small capabilities because you essentially are starting from scratch.
And if we could upend that, if we could create a common platform that we could all build on, the world would just change really quickly. Willow Garage was this really kind of strange place. It's just strange enough to be able to bring the community together.
It looked like people were having too much fun to be doing serious work.
It became this almost mythical place. There were these incredible robots doing incredible things.
It was a little bit research lab, it was a little bit open source development lab.
It was to make robotics better as fast as possible.
ROS stands for Robot Operating System.
I mean, you gotta be careful what you name things.
ROS is not an operating system.
I think of it as just the stuff that makes everything work, so we tend to refer to it as the plumbing.
That notion, that core idea that I can use ROS and combine it with everybody else's best of breed stuff, that's a really powerful idea, and that idea spread like wildfire.
You get a whole bunch of young people, you bring them to some place, you teach them ROS, and then you say, go back to school and convert all your robots to ROS. And that's what kind of happened.
And then without that one common platform that everybody's building on and contributing to and enabling people to build on each other, without that common platform that brings the community together, robotics would definitely not be where it is today.
You know, this was a catalyst, and this was the chance to kind of really do something big for the world.
All right, so back to the presentation. Yeah, that's a very nice, it's a 5 parts video. This is only the trailer, but it's a very nice video from the Red Hat guys that explains a bit how ROS got started and how this robot evolution got started. So really worth it if you guys have time to check out all these 5 parts entirely. Let me just go through. Yeah. So one of the main keys why ROS got started was to avoid reinventing the wheel. So every time in a robotics lab, someone wanted to do robots, they were starting from scratch, having to write everything, all the plumbing, all the tools and everything. So it was a lot of a waste of time, right? So as we saw in the video, one of the key things that happened is that this R&D company in the Bay Area called Willow Garage, back in the 2007, they developed this platform that came with something called the Robot Operating System, or ROS for short. And they moved this platform, they gave it away to different robotics labs and companies, and they started working on this. And because it was open source, everyone started contributing, and it became what it is today, which is, we could mainly say, is like the de facto standard on robotics. So it's been around for a long time. ROS, it's been around for more than 20 years, and it's been very useful, and it's very interesting. So when it was built around the research community. So all this was created by the research community, and all the tools came with a little bit of that. So a little bit on what ROS is. ROS, despite its name, is not an operating system. It's mostly an SDK or a framework, a set of tools and libraries, however you want to call it, which provides basically 4 main things. It provides with the plumbing, which is a message passing system that allows you to patch information between different processes. So let's say you have a camera, then you want to send the camera images to some image processing algorithm that will detect some faces, and then that message you want to pass it on to some actions that the robot will make. Then you also have the tools, which basically are developing tools that can allow you to introspect your system, log it, replay it, all those things. Then we also have capabilities, which are implementation of commonly used algorithms. Let's say navigation algorithms like avoiding obstacles, localizations, mapping the environment. All those things are already there for you, so you don't have to rewrite them. And there's an ecosystem, which is a set of developers, users, and software that anyone that comes and wants to start creating robotic applications can build up on. So the initial ROS, as I said, was created in order to make it easier to build robot software and try to reduce the reinvention of the wheel. There's 4 key points where it was built on, which was distribution, which is the distributed way, and you can write code in different languages and all those things. There's abstraction, where you can plug and play different parts of the system, and as long as they share the same interfaces, you can reuse those. Federation, which is a key thing of the ROS ecosystem. So federation in terms of like, there's no one repository that contains all the code. So anyone that wants to develop some ROS components, they can just do their on their own, place them wherever they want. And in the end, they all gather, they're all written down together in a ROS index. And then that index, you can use it to search for different packages and run them yourself. And there's introspection that allows you to check the system. There's the command line interfaces that you can build up on, and GUI tools that build on top of those. For ROS, there's 2 current releases. There's the Melodic Morenia and Noetic Ninjamis. And this is the last release that is there for ROS 1. Because now we want to focus more on ROS 2, which is the new rewriting with like everything that we've learned from ROS 1, everything that the community learned, all the things that we could improve, those are in ROS 2. So regarding releases, there's been quite a few releases of ROS 2. The last one is the Foxy release, which came out on June last year. And we also have a rolling release, which is called Rolling Ridley. And that one is basically a continuous release with the latest changes. The only different thing with this release is that some compatibility between different packages is not guaranteed. So the API can get broken as new updates comes on the rolling version. Whereas on the other versions, that won't happen. So one of the ROS 2 priorities that came out of the rewriting and all that was to focus a bit more on the plumbing, so developers can somehow spend less time on that part of the development, and they can spend more time developing tools, capabilities, and in the ecosystem, right? One of the key things that happens is that the communications were moved to a standard called DDS. And because it's a standard, now we can use different implementations of that standard. The goals of ROS 2, it was moved a bit more towards real applications in industry environments and final user-facing applications, and not and leaving behind a bit all that research focus. So there's an enforcement on quality of design and implementation, system reliability, real-time control and deterministic execution, validation, verification, flexibility in communication, which is what we brought with DDS, and support for small embedded systems, which is something that we didn't have before and the community was asking for. So if you look at the architectural changes, On ROS 2, you can see the user code had a master, which was part of the discovery process to connect the nodes in ROS. And that master was like a single point of failure, and it was a bit not too reliable. So that is removed now with the DDS implementations. And then we had C++, the ROS CPP and ROSPy library that will run on top of the communication layer and on top of Linux. Whereas on ROS 2, we have the user code running on different libraries. So you can run code, you can write code on whatever language basically you want. And then that stays on top of the RCL ROS library. And finally, there's the DDS layer, which you can select the implementation of DDS that you really want to run. So any implementation that it's there, you can use it. And also, we widened the support for Linux, Macs, and Windows machines. There's also something called MicroROS, which allows you to basically run DDS on microcontrollers. So this is an example of a microcontroller directly publishing ROS topics. Regarding releases, I talked about Foxy being the one, and the next one being the Galactic. So then we also have Gazebo, which is the simulator software that we have at Open Robotics. And the idea of Gazebo is to be the best possible substitute for real physical robots, right? So the main idea of Gazebo is that you have a simulated world, you have some code, in our case, written in ROS. It doesn't have to be written in ROS, but of course we encourage you to use ROS and develop with ROS. And then basically you will run your code in the simulation, and the same code will run on the real world. So that is something very cool. And last but not least is the Robotics Middleware Framework, which is the software that we're working here in Singapore. And it's a very interesting project. So regarding the RMF, it all got born with the need of running multi-robot systems within infrastructures, right? So there's certain process flows that will inherently require one or more robots, and these robots might not be from the same vendor, because the best robots for each subtask might be exactly from different vendors, right? So there's a need for multi-vendor integration in current systems, right? This multi-fleet integration is very challenging because these robots have a lack of interoperability. They don't talk to each other. There's infrastructure constraints. There's dynamic environments. People are not trained to walk around robots. There's a lack of realistic test environments because you cannot build an entire warehouse or an entire hospital just to test your robots. That's why simulation plays a big part of this. And there's also big cybersecurity concerns, because you're gonna probably use a shared network, and your robots are gonna be roaming around different people and all those, right? So all these challenges are something that we have to face when building RMF. So what can we do with RMF? So with RMF, we can do task planning and allocation. So you can see that we can, on the right, you can see that that's the RMF panel where you can select different tasks, and you can run all of them, and you can tell the system RMF to execute them, and it will optimally select whatever robots are available to fulfill your task, and it will take care of that. And then we manage the fleet traffic. So robots will be roaming around an infrastructure, and they will have to efficiently talk to each other in some manner and allow each other to go around, stop whenever they need to stop, to let other robots pass by and all that, and replan at a certain points, right? And then there's also integration with the infrastructure. So for example, doors and lift integration. So robots will have to open doors, close doors, share lifts with other robots with different vendors, and open and use the lifts as per normal. And finally, we also make the robots interact with walk cells. So basically, walk cells are ingestors, or so we basically the robot will interact with like static injectors, or so they will take objects from robots or dispensers will take objects from the robots. So let's say in this example, there's a robotic arm that is dispensing a Milo can to the robot, and the delivery robot will bring it back to whoever asked for it. There's different tools in RMF. So we have the traffic editor. So the traffic editors allows you to annotate floor plans, create walls, doors, lifts, and it also allows you to place simulation models inside the floor plan. And you can import these traffic lanes into vendor-specific fleet adapters. So this can be used by the fleet adapters later. And then the output of the traffic map, traffic editor can be generated into physics-based emulation world with all the 3D assets by using these building map tools. So you just run these building map tools, and then suddenly you have a 3D world running in Gazebo that you can use to test your environment. Then we created a lot of open source simulation assets, which are available in Ignition Robotics Fuel. Probably Luca will talk more about this, but you can go to Ignition Robotics Fuel, and you can find a lot of the new assets that we created and are ready for you to be used. Then we have RMF Core, which is all the brain of RMF, where you have like C++ libraries for trajectory interpolation, path planning. We also have the ROS wrappers of these C++ libraries, templates and examples, and adapters for your fleets, adapter for doors, lifts, and abstract task configurations and all that. We have the connections ready to connect to UIs. So we have desktop web UIs and also mobile UIs. So we have the bridges between ROS and those types of communication. And then we have an operation dashboard, which is the one that you saw, where you can just basically log in, select your task, and ask the robots to execute different types of tasks. And I don't want to leave without mentioning the amazing community. Open source is all about that, right? So there's a huge, incredible community collaborating in ROS and collaborating in these projects. And it grows every day more, and they do like very amazing things. There's a technical steering committee for running ROS. So this is the current, I think this is the latest ROS 2 technical steering committee, which they come together every now and then, and they take decisions on the directions of the development of ROS. And then if you guys want to get started on ROS, there's I wrote down a few of the ROS websites. There's a discourse if you want to check it out. There's also a discourse for Gazebo and Ignition, which is the community.gazebosim.org. And for RMF, we also have a book which has all the documentation. And then you can also access the Open RMF org on GitHub. And I recommend you to check the RMF demos if you want to have a look at some cool simulations with RMF. We have really cool community events. The ROSCon is the main one regarding ROS that is growing every day. This year, we're trying to make it happen in around November, I think, in New Orleans. And yeah, there's many community events that run around the world, so you're welcome to join them and to join the ROS community. So yeah, thank you very much. Thank you, everyone. And now I'm ready to take questions.
Okay, perfect, Marco. Thank you very much. And we have a few questions here. So, David Effendi, would you like to ask your question? Then you can, I can activate your microphone. I unlocked you. If you want to ask, you can activate your microphone. If not, like I will ask it in a moment. We can first maybe go to Alvin Hall's question. Tomorrow morning at 10:30, is that a continuation of the current session?
So tomorrow morning at 10:30, I'm going to show a little bit of how to use ROS and how ROS works. Hopefully, if we have enough time, I'll try to show also a little bit of a Gazebo. I'll try to run everything online, so no one has to install stuff. And maybe the part of Gazebo, which is a bit more complicated, then that might be just mostly a showcase. But the idea, I have everything I can share here already. The GitHub, I have a GitHub. Let me just check. I have a GitHub URL with like some of the contents that it will be based on this. So you can have a look and start playing around with it if you guys want.
Awesome. Thank you very much. And then I've Harish here, and we are getting like used to using a bit the interactive features of the system. So Harish, please go ahead with your question. But I think you need to click the microphone again to activate it, because I only see your headphones are activated. So click the microphone again, and then like probably an option comes up. And in the meantime, I will ask the question of Anatoly Barbenya. I don't see you here with the name in the list of users, so I'm not sure what is your username. The question is, does Traffic Editor help with building floor plan automatically using SLAM or similar algorithm?
So Traffic Editor, it's only meant to create the flow map. So there's the algorithms that run on that you run. They're not related to this tool. This tool only creates the map, and then you can use that map for the fleet adapters, and you can use that map to generate the simulation world that you will run on Gazebo. So it's not. It's only related to you creating the lane maps and the waypoints, locating the robots in your map.
Okay, perfect. Thank you very much. And I'm heading over to Harish.
Thanks, Marco, for that talk. I'd be interested to know how much of the RMF would be able to consider drones, flying drones that, unmanned vehicles, because it's a kind of a robot. At the same time, it's now three-dimensional instead of two-dimensional, which is what a standard robot is in terms of movement. Does the framework contain anything that addresses that portion of that, the three-dimensional part of it?
Yeah, so there's been some discussion about drones, but the problem is it was already hard enough in 2D. So we've been focused all the efforts on solving that problem first, so the main locations that we're running this is indoors these days. So we haven't moved it outdoors yet. There's some work towards moving it outdoors coming soon, but it's not yet considered in the framework.
Okay, thank you very much for answering this question, and I think we will go more into detail. There is another question here from David Effendi, and about how does ROS 2 compare with JetBot from NVIDIA? I think Marco, you didn't hear me. Oh, you did.
Yeah.
Okay.
So I have never used JetBot, to be honest. One of the main things I would, without knowing much about it, one of the main things that I will like to showcase about ROS is that the community is quite big, and I can probably say that the amount of resources that are available for ROS are quite impressive. So by saying that, like things like the nav stack in ROS can get your robot running in like a matter of minutes, and you don't really need to re-implement all those parts. I would say that is the main difference that I can showcase right now, because I haven't looked into the details of the actual implementation of JetBot.
And okay, it's the last question, and please, with a quick answer, a short answer, when there would be an event in India. So basically, when is there an event in India really in person? Because people would like to meet up. This is a question from Rainer X.
I'm not sure, but I would say that there's probably events in India already running. The only event that Open Robotics runs officially is the ROSCON, and we used to follow this conference called IRIS, and now it's like a bit separate. And the next one is in New Orleans, but we don't know about following ones. But yeah, I'm pretty sure that you can run, you can check out meetups. There's a lot of ROS meetups around the world, so that will be my first recommendation. And also check on Discourse. There's a lot of discussion going on there, and then you can probably find more events on your area.
Okay. Excellent. So thank you very much, Marco. This was basically an introduction to the robotics and a lot ROS mini track, which is running like for the next 2 hours here with more sessions from your team. So we really appreciate it, and congratulations to this great start into the track. Thank you very much, and we're continuing in a moment. Thank you very much, Marco.
Thank you.
Mario, you are muted.
I'm like muting myself, always like to not be too like not sharing anything that we shouldn't share. So we will start in a moment with Luca Della Vedova. Luca, are you here already? Please switch on your microphone, switch on your screen. I'm looking for you. I need to unlock you. Or are you? I don't see you in the list yet. Or will you be using Marco's laptop? Because I heard that the robotics team is all together. Here I see Luca. You already have the access joining here. Excellent. So Luca, you want to test your microphone quickly? Oh, I can't hear you yet. Can't hear you yet. Can't hear you yet.
Can you hear me?
Yeah, yes, we can hear you clear and.
All right.
Yes. Okay, excellent. Will you be sharing your screen? Are you aware?
Yes, I will be sharing my screen.
Yeah.
So,
okay, cool.
Entire screen. Hello. Okay.
Okay. Will you also be sharing a video? Are you aware how to do that? Yeah. No.
Yeah, no, I will not be sharing any videos, so it's fine.
Okay, excellent. Then Luca, yeah, cool. So we are now starting into the session right away. Welcome everyone to this next session of Luca Della Vedova.
Yes.
I hope I said it nicely.
Yes.
Luca, where are you from? Are you from Italy or Spain or something?
But yeah, I work in Open Robotics. But yeah, so that is, yes, that is an Italian name.
Yeah. So Luca Della Vedova is a software engineering supervisor at Open Robotics, and he's also based in Singapore. Luca currently works on building large-scale robotics simulations and open source hardware. So big round of virtual applause for Luca. Thank you very much for joining us. Please go ahead with your session. Thanks.
Okay. All right. Yeah. Thank you, Mario. And again, thanks for the organizing the event, especially in this in these challenging times. So we're talking about Gazebo. Marco briefly mentioned the simulation software that we use, Gazebo, and he briefly mentioned also Ignition, which is a rewrite. So this is a different presentation running inside a simulation. So here simulate to be the
So Luca, I'm sorry to interrupt. There is some issue with your sound, and I can't identify it. I have like now several people reporting something like that. I can't know if it is the browser or something like that. Do you have an idea? I also can't hear you anymore.
Okay.
There's a Daryl also is about, so if you want, I could suggest something. Jens says maybe try turn off your camera. Let's see if that works.
No?
No, you need to speak a bit more so we can identify.
Yeah. Can you? Okay, let me. I can try to turn off my camera. Yes, stop sharing webcam. Can you hear better now?
Well, we can hear you, but then it's breaking up every few seconds. And maybe speak a bit so we can identify the issue. Yeah, Daryl, try headset. Yeah, well, this kind of issue that we sometimes have, it's usually related to connection or to browser issues. There's so many different browsers out there and configurations that yeah, we're having a hard time sometimes to identify what is the real issue. Abi Trolley is talking about codec overload, and yeah, Mozilla browser sometimes. Yeah. So Luca, what's your idea? What would you like to do? Okay. Luca, I can see your screen, but I cannot hear you. Can't hear you. So, you need to press the microphone icon. I can see on your screen that you didn't activate your microphone on the left-hand side. Yeah. Yes, and now we can try to hear you. Okay. So I know that Luca and a few robotics guys are just around the corner, close to each other, and I can recommend to you, or I can suggest that if we can't get the sound working, we could do the next robotics talk before you, Luca, and you could like test this in our support room. But because I still can't hear you, I don't know if anyone else can hear Luca. Nope. Mohammed says nobody can hear you. Yeah, Luca. Sorry about that. So Marco's machine works fine, but you can't do it from Marco's machine. Can you? No. So how about we give you to the support channel? And I don't know, Luca, if you know if the next speaker is would be already available. That would be Yadunund Vijay. So Yadunund, are you here already? I don't see you here in the list of participants, but I would say that we could like.
Hey Luca,
I see you. Yeah.
Please enter the support room. We are there to help you to test
Luca,
it.
please, on the left-hand side, you see a gray icon on the top left where you can extend the screen, and please come into the support room, and the team will try to resolve the problem together with you. Okay, Yadunand, I activated you, I unlocked you. if you want, you can try to join us, and we can basically switch both of your sessions. I think it would be fine because we have a related topic here of the same team. But Yadunand, I don't know if you are already, if you would be already available. Okay, Yadunand, you still need to click on the heads icon 2 times in order to activate your microphone. There's in the middle of the screen a head icon to activate your microphone. Alternatively, you just refresh the screen and you will get all the options again. Yeah. So, you need to, you need to click 2 times the the head icon to activate the microphone. Yadunand, are you able to share your video? Okay, so I'm sorry for the issues here. We actually tried to test this as much as possible. We had onboarding sessions with like tons of people, like I think 100 plus ex-speakers joined us at test sessions. But as you see, it is challenging sometimes on the event day. As always, it always works before, but it doesn't work when you actually try to do it. So Yadunand, when you join again, you're unlocked. You're locked. I'm unlocking you again. You need to click the headphone icon in order to switch on your microphone. Yeah. So I don't know what to do. I can. So if that is not working, I don't know, switch to another browser. I don't know which browser you are using. Yeah.
I suggest now we play that guidance videos, how people can activate their audio.
Well, I leave it to you. Please play this video. Go ahead.
I think they're playing something.
Hi, can you guys hear me?
Yes, we can hear you now.
Okay, I'm using Marco's machine and hopefully I can run the presentation from here. Really sorry about that.
Wow, Marco has the best machine in the company.
Yeah, it seems like it.
Excellent.
Okay, Sorry about all the technical difficulties. Can someone indicate if they can see the screen?
Okay, excellent. Thank you very much. So this is Yadunund, right?
That's right.
Yeah. Okay, because we see Marco's name on the screen, so it's nice to make it work, and we'll definitely learn from this experience and improve. Yadunund, Vijay, let me introduce you quickly. Yadunund is a hobby maker who derives joy from DIY projects that involve design and fabrication. He is passionate about robotics and aims to leave a positive impact on society through his work. He received his master's degree from Massachusetts Institute of Technology and bachelor's degree from the Singapore University of Technology and Design. Presently, he is a software engineer at Open Robotics. So welcome very much, and please go ahead with your presentation.
Thank you very much for the warm introduction, Mario. Good afternoon, good morning, everyone. My name is Yadunand, and thanks for the opportunity for me to present this talk at FOSSASIA. Today, I'll be talking about developing a low-cost autonomous mobile robot that is powered by two major open source technologies. One is ROS2, and the other is Navigation 2. So let's get right into it. So what will this talk cover? First and foremost, this will be a very practical overview of building your own autonomous mobile robot using these open source technologies. We will cover the minimum hardware required to build such a robot, as well as cover some integration steps needed on the hardware as well as the software side. What this talk will not cover, we're not going to get into too many details about ROS2 and its capabilities. We're not going to focus on any of the navigation techniques or algorithms used for localization, path planning, or control. This will not be an overview of how to tune your own navigation stack. So with that in mind, let's jump right into it. So as you can see on the screen right now, we have a whole bunch of different kinds of robots here. Some of these are autonomous cars, autonomous boats. We have mobile robots, AMRs, AGVs. We even have some drones. What's common across all of these robots is they're all ROS-based. So I think Marco has given us a good introduction of what ROS is and how it's used in robotics, especially to connect different subsystems, pass messages from one sensor to another, process information, as well as send information to actuators. So ROS is kind of the building blocks of robotics, and a key feature that ROS comes with is a navigation stack. And this navigation stack is a set of software libraries that allows you to perform autonomous navigation with your mobile robots. So with that in mind, where do we begin if we want to build our own mobile robot? In this presentation, I'm going to share the approach that I followed to build my own mobile robot, and hopefully that can serve as an inspiration for others. So the approach that I followed was to work backwards. So I first studied the workings of the navigation stack, try to understand what is the information that it needs, what kind of sensor data does it need, what is the output of the stack, and from there basically derive a minimum list of hardware as well as software requirements. So that's been the starting point for this development. So let's take a quick look at a navigation stack. This is a broad overview. It's not specific to any navigation stack, but it should generally apply to ROS-based navigation stacks and other stacks. So navigation stack basically takes in some inputs and produces certain outputs. The input for the navigation stack consists of broadly four topics. Firstly, it needs some information about the robot. It needs to know where the sensors are on the robot, what's the size of the robot, what kind of kinematics does the robot have, what speeds does it follow, etc. Secondly, it needs to know something about the robot's odometry. So this is basically an estimation of the position and the velocity of the robot in the environment. Next, it needs some information on the surroundings that the robot is operating in. This is usually obtained through sensor data, and the stack usually constructs a representation of the environment while it's running. And lastly, we obviously need a goal. This is to basically tell the robot where to navigate to, and the navigation stack will proceed to generate some outputs for this. If we look at what the outputs are, well, the ROS navigation stack has a very simple output. It simply outputs the velocity that the robot should follow. So this is a combination of linear as well as angular velocities that the robot can take. So with that in mind, we can sort of draft our requirements for our robot by looking at the inputs and outputs to the navigation stack. So broadly, there are 4 pieces of software that we need to implement, and these are numbered 1 to 4 as you see on the slide. There is the inputs for the navigation stack, which is LiDAR data to construct the surrounding environment. We need some transform frames. This is basically telling the navigation stack where the robot is on the map, where the sensors are located, as well as how the robot is localized in the map. And lastly, we have something called odometry. This is, again, an update to the navigation stack to let it know where the robot is in space. So from these software requirements, we can infer certain hardware that we need at the minimum. So if we look at number 1 on the right side, let me pull up my pointer here. This might be easier. So we need a mobile base. So this is the chassis for the robot, and ideally it has some motorized wheels that can allow the robot to move around in the environment. So the output of the navigation stack should be fed into this base controller, which then controls the motor speeds of the robot. Next, we obviously need to gather some information about the environment. So we need some kind of a sensor. Most popular sensors used in autonomous navigation are LiDAR based. This allows us to gather information on the environment. And lastly, to perform odometry, we typically require wheel encoders. So these are sensors that we mount on either the wheels or the motors themselves that tell us how much the wheel or motor has rotated by. And with that information, we can determine how much the robot has moved by. We'll talk a bit more about this in the coming slides and how we can sort of get away without having encoders for our robot. So since we're talking about ROS and robotics, all of this can be encompassed within the ROS framework. And as we know, ROS is an excellent tool for plumbing. What this means is it's used for generating messages and publishing them from one piece of software to another. So the navigation stack that we use here is a ROS2 navigation stack. It has some predefined messages that it needs to receive this data in. So it needs to receive the LiDAR data in the form of a laser scan message, the transform frames in the form of a TF message, similarly for odometry. And it also standardizes the output of the navigation stack. So it publishes something called a twist message. And this basically consists of a vector of linear as well as angular speeds that the robot should follow. So with that in mind, I'm going to cover a bit about the process that I followed in designing a robot. So I first started off by doing some basic back of the envelope calculations. We don't want to build just any kind of robot. For me specifically, I wanted to build something that has some novelty to it. So I decided to use something with 4 mecanum wheels. So these are these special wheels that you see here on the slide. These allow the robot to move omnidirectionally in the environment. Along with these 4 wheels, I wanted the robot to be able to carry a payload of 20 kilograms and travel at a speed of 1 meter per second. So I did some basic kinematic calculations to derive the amount of torque I need for this robot, for the motors in this robot. So that was a good starting point. From there, I began to CAD out the chassis for the robot. This is done in Onshape. From the CAD, we can move into the bill of materials that we need. So we understood what the navigation stack needs. From there, we derived what is the minimum hardware we need for those sensors. And from there, we can generate a list of materials that we need for this robot. So for the robot I built, these are the parts that I used. So in total, I spent about roughly around 400 Singapore dollars to build this robot. I have the robot with me right here, if you guys can see. So it's a pretty compact robot, but at the same time, it can carry about 20 kilograms of weight. Here on, I'm just going to document the build process a bit. So some parts were 3D printed, others were procured. The chassis was assembled. We added the electronics and the sensors finally, and the robot is ready for programming. So the brain of the robot is a Raspberry Pi. I think most of us are familiar with this single board computer. And I was working with the Pi 3B, which is an older model because I just so happened to have it with me. So this Raspberry Pi, it's running Ubuntu 20.04 server, and it has the ROS2 binaries installed in it, along with the navigation 2 binaries. So from there, remember from our previous slide, we had 4 things that we had to implement. We'll just cover these 4 things really quickly. So the first thing is a base controller. So we discussed that the output of the navigation stack is a set of velocities. So we need a way to take these velocities in and make our motors move. And this is what the base controller does. It's basically a ROS2 node. It subscribes to the command velocity topic that's output by the navigation stack. It then uses a basic inverse kinematic calculation to transform the robot, the desired velocity, into the individual wheel velocities. So that's what the basic function of this piece of code does. And finally, it sends over the wheel velocities to an Arduino, and the Arduino writes the wheel velocities to the motor controllers or the motor drivers, which in turn spins the motor. So this is a very basic functionality that is required for all robots. And let's talk a bit about one of the disadvantages. So let's talk a bit about the use of, or the lack of motor encoders. So in my previous slide here, I kind of brushed through it, but among these materials, I procured some motors without any encoders on them. So I was curious, is it possible for me to still build a robot that can autonomously navigate without these wheel encoders? One of the reasons that I chose not to get the ones with the encoders is because they cost significantly more, and there's also further complexity with their integration. However, I soon realized there are several disadvantages of not having encoders on the robot. First and foremost, we cannot perform closed-loop control of the wheel speeds, so we can't expect the robot to follow the input velocities in a perfect manner. Secondly, there are tons of inaccuracies with estimation of the position of the robot. This is because we're not getting feedback from the wheel itself. So our software may ask the wheel to spin at 100 RPM, but the wheel may not actually be spinning at 100 RPM. So because of this, our estimates on where the robot is will be poor. With that in mind, we were still able to successfully write a base controller for this robot. So as you can see here, I have a joystick that's publishing signals that is similar to the navigation stack. So it's publishing these command velocities, and this is making the robot move in plane. So the second piece of software is integrating some form of awareness of the surroundings in the robot, and this is in the form of a LiDAR sensor. So I bought this really cheap LiDAR sensor that does not come with a ROS2 node. So I wrote a small ROS2 node that basically connects to the device. It extracts the signals from the device and publishes this in the standard message form that we need. So on the image on the right-hand side here, you see the sensor here in my living room, and we can see the outputs of the sensor on the screen here. It's basically a 2D projection. We have a laser beam that shoots out and rotates 360 degrees, and we measure the point where it bounces off the surrounding. So that information we get data points that represent positions of boundary objects in our environment. So the third thing that we need to implement is provide the navigation stack with some understanding of where the sensor is on the robot and where the robot is on the map. So this is provided by something called transform frames. And we have, in the ROS ecosystem, we have an extensive document called the REP 105. This describes the name of the frames that is required and ideally where the frames are located in your robot. So for very complicated robots like the one you see on the right-hand side, this is the PR2, we have tens of 20s, maybe even more frames that we need to keep track of. But in the robot that we're building so far, we have 3 frames that we need to keep track of, where the base of the robot is with respect to the LiDAR. We need to know where the base of the robot is with respect to the wheels of the robot. And finally, we need to know where the base of the robot is with respect to the odometry frame. And we'll talk a bit more about the odometry frame in the next slide. So as mentioned before, we need to supply the current position as well as the velocity of the robot to the navigation stack. However, there is a problem because the robot is initialized randomly in the world. So we need to keep track of how the robot moves from that random initialized location. And this is basically what the odometry keeps track of. It keeps track of the relationship between this base link as well as the odometry frame. So you can think of this odometry frame as a position or pose in the environment where the robot first was booted up or turned on. And from there, when the robot moves around, we need to keep track of how much it's moved from this initial position. So typically with the wheel encoders, this is pretty straightforward. We're able to read the encoder values to determine how fast the wheels are moving. And from that, we can determine how much the robot has moved. However, without encoders in the situation that I described, this is a bit more challenging since we have no feedback at all about we have no feedback at all about how fast the wheels are spinning. So as a workaround for this, I was curious if I could just use some kind of feed-forward control. In this case, I just assume that the robot's always following the command it receives. So if it received a command to go at 0.5 meters per second, I just assume that the robot is definitely moving at that speed. And based on that assumption, I update its position and velocity. So this is kind of a hack that I did for the robot to overcome the lack of encoders. So that's pretty much it. So we've implemented the 4 things that we need for the navigation stack. The next up is to basically create a map. We have another brilliant open source tool for this called Cartographer. This was originally developed by the folks at Google, and it's also open sourced. And it's basically a SLAM algorithm. SLAM stands for simultaneous localization and mapping. And basically, it's simple enough for anyone to use. All they need to do is configure certain parameters and start this piece of code. And in our case, the only things that we probably need to change is say that, okay, we're not going to rely too much on odometry because we know it's inaccurate. We need to specify certain frames that the robot has. And with that, we're ready to build a map of our environment by driving the robot around. So with the map ready, we can actually begin to autonomously navigate. It's really that simple because of all the open source tools that we have. So all we need to do is basically set up the configurations for the navigation file. And this involves setting up certain parameters for localization as well as the planners in the ROS2 navigation stack. So once all of this is set up, it's a matter of simply launching up all your files, and then you can give the robot a goal position, and it's going to autonomously navigate in the environment to reach that goal. While it may be as simple as that, there are still a lot of details that go into tuning the navigation stack itself. You could easily spend weeks to even months tuning this navigation stack to achieve the performance that you want. Typically, a few things that you need to do beforehand is make sure that your odometry is working all right. There are several guides to ensure that you can get the right set of data from different sensors, make sure that your odometry is working okay, the navigation stack is set up correctly, and the links to these are in this slide here. But overall, there's basically tons of parameters that we need to tune. It's absolutely important that we read through the documentation in the open source navigation stack to understand more about what these parameters do and tune these parameters accordingly. So in the interest of time, I'll just head over to some takeaways from this experience. First and foremost, open source frameworks like ROS2 and Navigation 2 can astronomically shorten the development time for mobile robotics. Just from my experience alone, the whole process with designing, sourcing parts, and building the robots took about 2.5 months. However, once the hardware was assembled, going from hardware to autonomous navigation took little over a week. And this is only possible because of the amazing work that the open source community is doing with ROS2 as well as the Navigation 2 stack. Secondly, in industry especially, there is a negative connotation towards open source software. People tend to believe that it's not maintained well, or there's tons of bugs in it, or perhaps it's not state of the art. I can guarantee that the open source tools that we're using for this project are indeed state of the art, and the results speak for themselves. And lastly, mobile robots need not be expensive to build, and I encourage more hobbyists to give their shot at building their own robots. I've added some relevant links to the last slide here. The entire code base, along with documentation to run the different pieces of code, along with where you can find the CAD and building materials, steps to assemble the robot, as well as other pieces of code that I've used along the way, are all in this slide. So, like I said before, I encourage more people to build their own mobile robots, use ROS2 as well as Navigation 2 stacks for their robots. And with that, I'm happy to take any questions.
Okay, excellent. That was really nice. Okay, so we can take some questions, and I have here the first question from Harish. And Harish, I think you still have the sound right, so you can ask your question in person.
All right, thank you. I guess the question was got to do with the Ingenuity helicopter that's landed on Mars. Do you have any sense of what is the code base that was used for that one? And if so, you know, is there, if not, could that be incorporated in whatever that you guys are going to be building on?
Yeah, that's a great question. Unfortunately, I don't have clearance to NASA information, so I'm not sure about what code base they're running their robots on. But recently, this is kind of relevant to the project. There was a news article on the NASA website where they basically mentioned that they're using ROS2 for their upcoming mission to Mars, to the moon, excuse me. So it's good to see that open source technologies like ROS2 will indeed make it to a space mission that NASA is commanding. This not only reflects the safety critical aspect of ROS2, but also how we can leverage on its real-time factor, as well as it's basically a testament to the trust in open source software.
Maybe as a follow-on, maybe just I read that the helicopter code was all open sourced. It may not be the rover, but at least the helicopter portion of it.
Oh, that's fantastic! If it really was.
Yeah. I'll look it up and I'll put it on the link somewhere.
I'd love to read that. Thank you very much.
Okay, thank you very much. And we have another question here from Milan. Milan, I activated you, but I don't know if you were able to switch on your microphone so quickly. So I will just ask the question for you. How did you interface ROS2 to Arduino? Isn't ROS serial not intended to be used in ROS2?
Yeah, thanks for that question, Milan. So the Raspberry Pi, which is running ROS2, communicates with Arduino over serial communication. So this is using the Python serial library called PySerial. And basically, you can set it up to open a serial communication on one of the ports, and then you can pack data into binary form or byte streams and send it over a serial. So that's how the serial data was sent in this case.
Okay, excellent. And then another question from Raina. And Raina, you're also unlocked, but I guess people still have to find out how to activate the microphone. Yeah. So the question from Raina is this. I had used ROS and Gazebo for developing mobile robot for stimulation, but in real life, there are many more problems which make it very difficult to work on the project, I guess. Any guidance from you for that?
Yeah, absolutely. So first and foremost, I need to state that a lot of times when we develop robots, we test extensively in simulation in Gazebo environments as Rainer has proposed. And oftentimes the goal with simulations is to mimic reality as closely as possible. To this extent, most of the plugins that we have in Gazebo, this could be either sensor plugins or environment plugins, we try to model in some amount of noise into them. So typically when we look at why the robot doesn't perform as well in real life compared to simulation, it's often because of noise that sensors experience in either collecting data from the environment or noise in update steps with the navigation itself. So a lot of times the ways we can improve our navigation performance in simulation is by modeling this noise better. And our sensor plugins in Gazebo, such as the LiDAR sensor, the camera sensors, etc., allow users to specify certain parameters for noise. So I'd recommend playing a bit more with those settings. Hopefully we can get your robots to run better in noisy environments in simulation, and that should translate to better performance in reality.
Thank you very much. And there is a question from Anatoly or Rainer X. I see you're activating or somebody. Okay, guys, just feel free to butt in if you have anything additionally. But I'm heading over to Abitroli Anatoly Babenia. Are there any lightweight machine learning or AI algorithms that can learn to compensate navigation errors, for example, through external cameras to avoid manual fine-tuning?
Absolutely. I think in practice, in industry, a lot of problems with mobile robots come from localization itself. So just given natural phenomenon of how the sensors behave, a phenomenon called drift arises, where basically your position of the robot drifts over time. And a lot of times because of this, robots lose their sense of awareness of where they are in the world. And because of which they run into a bunch of navigation errors. So recently there have been a lot of ways to improve this localization and make it more robust. One of these ways is perhaps to monitor the position of the robot itself, either have other type of sensors, perhaps RFID tags, UWB sensors on the robot, perhaps even cameras as mentioned in the question, where we can keep track of where the robot is, and automatically relocalize the robot once we see there's more drift that is accumulated over time. So that could definitely be a good solution to the localization problem.
Let me just add I just checked, and the article on IEEE Spectrum does mention the code, and I put it in the question in the shared documents as well. The code base is on GitHub.
That's awesome. I'm going to check it out tonight.
Okay, wow. So the interest in your project is huge, and I wonder if we should schedule maybe later on another session about it, even though the plan is quite full. So thank you very much for this very interesting, insightful session. I actually have a lot of more questions myself, but I think I have to follow up another time. We are already over time, and I heard Luca is ready, so we will be continuing with Luca's talk in a moment. Thank you very much for this session, and we really appreciate it. Thank you very much.
Thank you, everyone. Appreciate it.
Test. Yeah, okay. Can you hear me now?
Okay, excellent. Luca, I would just head over directly to you.
Yes.
Please share your insights, share a bit about yourself. We appreciate your session, and thank you very much for resolving all the issues. So,
yes. So yeah, apologies for the issue before. So I will share my screen first. Yes. So yeah, I'm Luca. I'm a software engineer in Open Robotics, and then I work on hardware as well as robotic simulation. And today I will be talking about Ignition Gazebo. So the presentation will be actually run inside a simulation. So if you can see now, you should be able to see my screen. So Ignition Gazebo is a rewrite of the Gazebo simulator that Marco mentioned before. So I will skip the part about who we are and what we do because Marco covered it already. So we are Open Robotics, and we do open source software for robotic simulation. And I will be focusing on simulation. So first of all, what is the purpose of simulation? So there is several purposes. So first of all, in simulation, what we do is we create a simulated environment for a virtual robot, and there is several reasons why we would. So the first one is, as our question just now was asked to Yadu, is that real life is very complex. So the more you can test in a simulated environment, the less you need to deal with issues in real life. So for example, even as it was mentioned that there will be an upcoming mission on a rover on the moon, running raw software. In that case, clearly it's very hard to do a real hardware test. But what you can do is try to simulate as much as possible. So to at least to analyze the high level behavior of the robot. And then another purpose is also to try to run large scale tests on a lot of different environments. So this is very important, for example, in cases like development of self-driving cars, where it's very important to try test the performance of your computer vision pipeline in a lot of different environments. So by running it in simulation, you can test on a much larger variety of environments than you would be able by doing it only if you were restricted by the physical robots. So that being said, the main simulator that has been used so far is called Gazebo, which has been developed. It started in 2002, so it's been about 20 years. But like the Gazebo as we know it today, the simulator has been around for about 10 years. But similar to what happened with ROS and ROS2, as Marco mentioned, there have been a lot of lessons learned with the development of Gazebo, and so that brought to a full rewrite of Gazebo into what we call Ignition Gazebo, which is like where this presentation is running. So Gazebo, as a classic, like if you ever used it, is a very nice, like fully functional piece of software. But the issue that we found throughout the years is that it doesn't allow a lot of flexibility and a lot of choice to the users. So you would just run your simulation in Gazebo, and then you don't have a lot of control over, let's say, what the rendering looks like, or even like what the physics, like how the physics behave, or what your user interface looks like. And this is one of the reasons why we went into Ignition Gazebo, which is now it went from a monolithic approach to a large set of loosely coupled libraries, where we have a GUI library or a physics library or a rendering library, and they are all brought together, like they're all packaged together through Ignition Gazebo, which is like the idea that you see here about all the loosely coupled libraries. And the words, like in a way similar to Gazebo, are described through this language as SDF, standing for Simulation Description Format, which is an XML-based language that I can like show you quickly here, which also gives us an idea of like how much control we have over the simulation, because we can specify like every single plugin, and we can specify, let's say, if we want physics in the system and what types of physics we want, and we can specify which models, like which 3D models we want to have in the scene, like to create our simulation environment. Specifically about 3D models, so Marco mentioned before our online portal, which is called Fuel, and this online portal at the moment has about 2,000 models that are under Creative Commons license mostly, and they can be used and downloaded freely by anyone. And also it's very tightly integrated with both Gazebo and Ignition Gazebo, which I will just give a quick demo here. So we have our website here, Ignition Robotics, and then let's say if we were to browse some models, let's say we want to put let's say a small object maybe. So yeah, we have any of those objects, and this is very tightly integrated with Ignition, because you can just in our world we can just find the object and then like drag and drop from the server to our simulator. And what happens behind the scenes is that the simulator will send a request to the server, download the object, and then spawn it in the simulation. And then I mentioned the flexibility of Ignition Gazebo, and basically Ignition Gazebo is fully plugin based, which means that every single system, including starting from your rendering engines all the way to like the physics engines and the GUI, is all written in C++. Which might be a bit of a hurdle for developers who maybe are more used to scripting languages, such as it could be JavaScript or it could be Python. the recommendation we give in this case is that since Ignition Gazebo is also very tightly coupled with ROS and ROS2, what these developers can do is they can develop their software in ROS2, which can be done in like a variety of languages, from Rust to JavaScript to Python, and then they can just send the data back and forth from the simulator Ignition Gazebo to ROS2, and this gives this also gives access to the very large ecosystem that Marco mentioned available for ROS. And then so a bit more about the flexibility. So the first probably one of the most important parts is the flexibility in the physics engines. So yeah, back here we have a double pendulum swinging. So in the physics engine, we have support for a lot of different for a few different physics engine. So we come with like built-in support for Dart, which is, if I remember correctly, is developed by a university in the US, and which is also the physics system that you see running now and simulating the dynamics of the double pendulum. Then we developed an in-house physics engine called Trivial Physics Engine, which is designed to be as simple as possible and as high performance as possible. And it's designed, for example, for people who want to simulate let's say a warehouse with hundreds of robots, and maybe they don't care about knowing how the friction and the wheels behave, and they just want to simulate hundreds of robots moving around for days and making sure they don't collide, for example, which was developed for RMF. And then we have ongoing development to add support to Bullet, which is also a very which is a physics engine that is growing a lot in popularity nowadays. But then, of course, like you wouldn't be able to talk about robotic simulation if you wouldn't be able to simulate the behavior of sensors in robots. Of course, we can simulate simple sensors like GPS or IMUs or altimeters, but we can also simulate more complex sensors like related to rendering, like for example cameras and lidars. So for example, here you can see the data being published by the robot, by the robot's camera that is now going to collide against this person, and you can also see like the lidar rays, that whenever the robot is going close to one object and is within range of the lidar, then the lidar sensor will report that it detected an object in that area. Okay, maybe I will stop the robot now. And of course, as I mentioned, we also decided to focus on the flexibility on the physics side, but also on the rendering side. So Gazebo Classic only came with a single rendering engine, which was Ogre 1, and it was good back in the day, but now it quickly became very outdated, and it doesn't look realistic or good enough for like modern simulations. So now the out-of-the-box simulator for Ignition is Ogre 2, which adds support for much more realistic rendering, especially from a textures and shadows point of view. But we also added basic support for an NVIDIA rendering engine called Optics. But then again, both for the physics and for the rendering, everything is just a plugin that is decided at runtime. So anyone who has their own rendering engine or their own physics engine they want to integrate would be able to integrate it with Ignition, as long as they put it together with the API that Ignition requires. And then, okay, just a bit here, and the most interesting part about rendering is that we can switch between let's say high accuracy rendering if we want to really go for photorealism, or we can choose maybe like more basic type of rendering if we just want performance. So for example, over here we have an example of the two in action. So we have two fire extinguishers, and then we have a model with like simpler textures on the left, and which is because it's simpler, you will require less resources to simulate, or a model with like higher accuracy textures and like like much more accurate like reflections and some much more realistic model, which requires, of course, like more resources. And then Ignition even offers the possibility of, let's say, using a rendering engine for the user, and a rendering engine for the robot sensors over here. So what you could imagine is, we'll go to the robot. So what you could imagine is a scenario where we want the environment to look very realistic for the sensors and for the robots, because we want to test our algorithms and maybe even our computer vision pipelines. But we also want good performance, and maybe we would be okay with having a less realistic simulation just in the GUI, because maybe the developers just want to check and debug what is happening. And that is also something that is possible with Ignition Gazebo. And finally, just a brief introduction on the GUI side. So again, like Gazebo was a monolithic, a very nicely looking GUI, but then like not very flexible. While now in Ignition, every single element of the GUI is a plugin. So all the parts you see here, like ways to show the sensors, or like way to, let's say, spawn objects, like are all like plugins. So for example, let's say we wanted to use a plugin to look at the properties of objects. We just add the plugin, and then we can like change and like visualize the properties of objects. And again, all those plugins, they're developed in Qt. Specifically, they're developed with QML, which compared to the way plugins were developed for Gazebo Classic, which was Qt widgets. QML is first of all, it's not pure C++, but it's based on JSON, so it's a bit easier for developers to work with, and also it has a much more modern look, like both from, as you can see, it has shadows and a much more modern looking color palette. And again, like all the Ignition GUI part is also like plugin based. So basically, the way Ignition is developed, everything is loaded at runtime. So what you can do is you can just create a simulation world that contains the description of your world, and then at runtime you can choose to run it, let's say, with a certain graphics engine, with a certain GUI, or with a certain physics engine. Or if you wanted to, we also introduce support for distributed simulation. So at runtime you can also choose, okay, I want this simulation to be distributed among multiple machines to increase the performance, of the simulation. So yes, I kind of powered through the presentation because we got a bit late with the previous technical details. But if you want to know any more about the project, you can just visit ignitionrobotics.org, and the whole presentation, including the simulation world, is of course it's open source. It's on the GitHub, including like instructions on how to run it and how to set up the environment. And then I will just give credits to our colleague like Luis Pubel or Chapulina on Twitter, who developed the plugin to get like slides into simulation, like to presentation like inside the simulator. Yes. So yeah, I will leave you here with this guy checking his phone, and yeah, I'll be happy to take any questions if there is any.
Thank you very much, Luca. And yes, there is a question from Abi Charlie. Would be nice to see Godot game engine integration to program interactions in Python-like GD script instead of C++. Are there any initiatives like that? Does the integration make sense?
Yes, so actually we have been looking for quite some time into integrating higher quality rendering engines, like maybe like newer rendering engines into Ignition, and Godot has been a candidate. And I think we spent a few months of development with it, and we actually also set up a few meetings with the developers of Godot to like see what the possibilities were. The main issue that we found with Godot is that it's a full game engine, while for something to be used with Ignition, what we really are looking for is a very is just like a rendering library. So while so the problem with Godot is that it just doesn't. It's the way it's developed, it cannot be used as a library. Like you need to use the whole engine, which makes the integration with Gazebo very challenging. And then, okay, there was a second part of the question other than Godot, sorry.
The second part of the question is, yeah, I just read the question entirely. By the way, you can also access it through the shared notes.
Yeah, sorry, yes.
Would be nice to see Godot game engine integration to program interactions in Python like GDScript instead of C++. Are there any initiatives? Just the
yes. So as I mentioned for the, okay, let me stop sharing the screen. Yes. So as I mentioned for the languages, yeah, the main development is done in C++. And again, like if you want, let's say, to write some code in Python, you can do it, but what we recommend doing is using, let's say, for example, ROS. So if you want to write, let's say, a piece of code that takes images and then maybe uses like TensorFlow or some deep learning framework to analyze the images and do some like AI or decision making, what you can do is you can bridge the data from Ignition to ROS, for example, and then you can access any of the, probably hundreds of open source implementations in ROS to process images, and then send the result of your computation, which might be, for example, an action from the robot, which might be like an action like go forward. You can send it back into Ignition to control the robot itself. So I would say you can probably, if you need any other language, you can just leverage the ROS code base.
Excellent. Thank you very much, Luca. So we're at the end, and it's really impressive how you managed in the end to fit so much content. So thank you again, and I think there would be a big round of applause if we actually had people in the room. And let me just tell you, we really appreciate that you're sharing all these insights here.
Yeah, thanks, Mario.
Have a good day. Keep in touch, and for all the speakers, please feel free to drop into the discussion room or maybe continue chatting with people. We also have the chat here directly in the room, or we have the chat in other ways. And I see that you shared your Twitter. So there are different ways to get in touch with you, and I hope a lot of contributions and connections will come out of this session. Thank you very much, Luca. See you later. And we're coming now to Aaron Chong. Aaron, are you already here? You're already upgraded to be a moderator, so you have all the rights in this session, and you should be able to activate your microphone, activate the screen, and so on. So while Aaron is getting ready, let me share with you the program. So we will share all the videos later on, and if you haven't seen it yet, we have the shared notes here where you can already post questions for the speaker. If we have a little bit time, we will also try to switch on your microphone so you can have like direct interaction. And I see like people already sharing all kinds of questions here in previous talks. So if anyone has missed it, please feel free. And to the speakers, I see some of you already putting in some additional links and answers. Feel also free to add notes here in the track. And I see Aaron. No, Aaron is gone out again. Aaron, are you still there? Aaron, and promote you again to moderator. I think you should be able to share again. So Aaron, you usually need to click on it's sometimes a bit confusing. So for anyone who's using the session, you need to click this icon with the earphones that you see on the screen, and then you need to click it again until you see the microphone, right? So it's like basically you're only here, and then when you click 2 times, I think you will see the microphone. Yeah, we can't hear you yet because you still need to click the icon in the middle of the screen below there. Click the icon 2 times where you see the headphones. So for anyone else, we will be continuing here in 3 minutes and give Aaron a chance to figure this out. So please be back in a few minutes.
right, can everybody hear me?
Yes, indeed.
All right. I think we may have found the solution for it, which is basically just keep clicking refresh, like there's no tomorrow. So that kind of got it working for me.
Okay. Aaron, which browser are you using?
I'm using Mozilla right now.
Okay. Okay, excellent. Then I hear myself in a
Right, let me share my screen. Right.
Okay, Aaron,
should I start?
thank you very much for preparing. And usually it just wait a little bit, then it works. So rather than refreshing, but I also don't know, maybe it's like challenging as more people are using the system. Today, we'll definitely investigate, but it's great to see that you worked it out. So yeah, let me also introduce to the audience now. We have Aaron Chong here. Aaron is a software engineer with Open Robotics, where he works on multi-robotics integrations in the robotics middleware framework, also abbreviated as RMF. He received his Masters of Science in Robotic Systems Development from the Robotics Institute at Carnegie Mellon University and his Bachelor in Engineering Product Development from the Singapore University of Technology and Design, SUTD. His interests include, of course, robotics, open source software, and computer vision. So thank you very much, Aaron, for joining us. We're looking forward to your talk. Please go ahead.
Right. Thank you for the kind introduction. So the topic today is the software that we are developing at the moment in Open Robotics. It's called Free Fleet, and it is an open source robot fleet management system. So this would be kind of like the agenda of the presentation today. So I will talk about the project description, how it originated, its motivation of it, and what the current architecture, system architecture is looking like. I'll try to show a demo, and then I guess the afterthoughts of the current architecture, and then like what we're actually developing and the newer features and systems that we're working on regarding this piece of software. So the project description, so these two links at the bottom are some of the documentations that we have put together. So this, the software is up on GitHub. It's under the OSRF organization. So let's start off. So the motivation of this project came from RMF. So Marco gave a quick introduction on what exactly we're doing in the Singapore office with the robotics middleware framework. So we are trying to integrate multiple fleets from different vendors and to have them share resources such as corridors, lifts, doors, and then integrate with infrastructure such that we can control them using our core system, which would allow us to orchestrate the whole system working together, like within basically to deconflict for robots, deconflict traffic issues in robots, like have them share lifts, wait for each other to cross before trying to get into the deadlock. So I've added some links here for some of the documentation we have for RMF. And the inspiration of it is that we would have liked to integrate standalone mobile platforms as well. And this would most of the time when we think about it, it would involve the very popular Turtlebot, the Magni from Ubiquiti Robotics, as well as the Husky from ClearPath, for example. So these are all standalone mobile platforms where they do not have a designated vendor managing them. They do not come with their own fleet management system, and they are highly and very popularly used by a lot of research institutes as well as R&D projects. So we would like to be able to integrate these robots into systems like RMF to support smaller deployments as well as to allow researchers as well as companies to prototype as well as work with RMF, because it is a system that we would be deploying and working with multiple industries in Singapore. So let's look at the system architecture of it right now. So Free Fleet is actually, we have been working with Free Fleet on one of our deployments that is at the hospital. So what's happening right now is that we have Free Fleet split up as the server and the client, where the client works with the mobile robot itself. So the client actually uses the API of the mobile robot to control it, while the Free Fleet server acts as an aggregating as well as controlling unit, which talks to each individual client, passing down requests, passing down commands, as well as aggregating each of the individual states of the robots such that we can actually put them together in something like a UI. So in this sense, this particular configuration is where we have the Free Fleet server working as a user interface. So this is where the user interface, we would be integrating with ROS2. We would use it to send down requests for individual robots to maybe pause what they're doing, to go somewhere, or to follow a specific path throughout like a narrow corridor, for example. And at the same time, we can use it to visualize what exactly is happening with each of the individual robots. So let me, if I can pull up, I'm not too sure how to use the pointer, but so I've set up like a red line here, and that represents the layer in between the server and the client. And what happens is the client and the server uses DDS, uses Cyclone DDS, for example, specifically to communicate with each other, where we can handle the quality of service and make sure that in the event of choppy network issues, they are still able to maintain connectivity and still able to connect with the robots, command it, as well as receive states on what exactly is happening with the robots. And these messages have been frozen and used in that sense, while on the other end, on the server, we put together a few sets of messages and topics as the API on how we control each of these individual robots. So in the project of in the RMF project, we use the same configuration, but we use these API to work with a fleet adapter in RMF. So this allows RMF to work with each of the robots and to make sure that they do not conflict with other robots within RMF as a system. So the key thing to note is that the messages between the client and server are specific to only Free Fleet, while on the other end, ROS2, the Free Fleet server uses a bunch of ROS2 messages as its interaction and like its interface. So this is the fleet management level, and then this is how we intend to, how we have been interacting with RMF. All right, so I'll try to pull up a small demo of it. So this demo would be using RViz as well as Gazebo Classic. So I'm not using Ignition here, despite Luca having presented it just now. So what's happening here is that we have 3 simulated turtlebots running ROS1 navigation stacks, and then they are all in this simulation. So we have one over here, one over here, and one over here. So even though I am in a ROS1 environment, this demo is essentially how we have been using Free Fleet to actually communicate with the robot. So this particular RViz plugin is actually using the Free Fleet server API, where writing in the fleet name as well as the robot name, for example, and then let's say I do it like this. I give it a navigation goal. So I send the navigation goal to one particular robot over here, and then in the other case, I can do this thing and I'll send it to the other robot, which is trying to get there now, and then I'll do it for the other one as well. So this is a small, short, hacky demonstration of how the Free Fleet server communicates with the Free Fleet client and tries to control each individual robot. So that's kind of weird. Yeah. So we can see here that it's working and it's actually controlling each of the ROS1 navigation stacks at the moment. So I will try to get past this right now. So keep in mind on how the interactions are going on at the moment. So let me just go back to the presentation. Yeah, so I had a GIF here just in case it wasn't working. So consider what have we seen here. So essentially, even though we called it a fleet manager or a fleet management system, what exactly do we require a fleet management system to do, and is what we have implemented so far really doing that? And as far as I'm concerned, I have thought about it, and this system that we have right now has only been handling the middleware quality of service. So using DDS, we can basically tune the quality of service such that the connectivity between the robot, the Free Fleet client, and the server doesn't drop in choppy situations like the robot entering lifts. We have been using the server to aggregate all the robot states together such that we can read it over ROS2. And we have also been using like ROS2 as well as Free Fleet server to pass down the request to the robot. So we aren't exactly doing much fleet management here. So another concern is that right now, the first iteration that we've done at the moment has only been for ROS1 navigation stacks. So I can dive a lot deeper into the interactions between the client and the robot itself, but it basically uses the move base package and to control what the robot does. So right now, that particular Free Fleet client is actually only for the ROS1 navigation stack. And then what about the middleware? So what if we were in a situation where the users would like to use their own custom middleware instead of Cyclone DDS, the DDS and the Free Fleet messages that we have used? So these are a few considerations that we have really put together to further improve on Free Fleet. So after a lot of remodeling and rethinking about what we can do about Free Fleet, so this is the current system architecture that we've come up with. So we have put together a few different abstractions. So we have tried to dissect the whole system and put it as levels of abstraction such that people can implement what they would prefer to use. So for example, right now the middleware is an abstraction that we have pulled out. So in this case, people could choose what they would want the Free Fleet client and the server to communicate with each other. It could be using ROS, it could be using ROS2, it could be another implementation of DDS, REST, or other sort of web APIs if they would like to. We have also had another one called the control handle. So this would allow users to implement the interactions between the preferred navigation stack. So we have the ROS1 nav stack working right now, but what about ROS2 nav stack and other custom nav stacks, like for example, vendor-specific one? So in this would allow users to implement their own control handle and to really integrate Free Fleet with their own custom robot. And the last one is called the status handle. So this would allow us to basically aggregate all the information within the particular mobile platform to update the fleet management system upstream. So this is how it looks like at the moment. So the client is basically this particular stack of pink blocks at the moment. So you have the control handle working with the mobile platform. You have the status handle trying to get information from it. And then you have the middleware where we use the same middleware implementation for both the fleet manager and the mobile platform. So this way they communicate with each other. And at the same time, we have also written the fleet manager as a C++ library. And we would actually be able to see why that is important. So noting the clients right now, so what's happened at the moment is that with this particular abstraction, we would be able to implement control handles for ROS1 navigation stacks, ROS2 navigation stacks, as well as any other control handles that would be working with custom vendors, for example. Similarly, for the status handle that's happening, and all of them would still use the same piece of middleware that would communicate with the fleet manager. So a few examples that I can come up with would be using the Magni from Ubiquiti Robotics for the ROS1 robot, and to use the open source ROS2 robot that Yadu presented just now as the ROS2 robot, and all of them could use the same piece of middleware to talk to the fleet manager in this case. So we have the abstraction here where this currently, the middleware that's been implemented at source at the moment, using Cyclone DDS similarly, but users can choose what they would like to use essentially. And the reason why we wrote the fleet manager as a C++ library is that we would allow people to build applications around it. So in this sense, instead of using ROS2 to bridge between the fleet manager as well as other pieces of software, with the fleet manager as a library, people could actually write their own user interface wrapping around this library and to use the fleet manager's API to work with the robot downstream. And similarly for RMF, we would be basically writing a single executable together with the RMF fleet adapter using the API from the fleet manager and to get it working together. So in this sense, we cut out using ROS2 or any other middleware in between the fleet manager and the fleet adapter. So the features that we have thought about in terms of how to make Free Fleet a better or a proper fleet management system, in this case, other than the abstractions that I've mentioned, would be to properly track and manage the robots in terms of where they are, instead of just pushing around messages and status and information about the robot. We would like the fleet manager to actually have a concept, a spatial concept and temporal concept of where the robots are and where they're going to be. And we've introduced the use of navigation graphs that will have been used in the RMF project as well. The Free Fleet Manager, as well as the robots, will use the navigation graph as well. And the Fleet Manager will be tracking each individual robot throughout the navigation graph to be used in its API, where people in their user interface could query where exactly the robots are. And we have also added relocalization intervention. So these are just a short, a pretty small list of things that we were planning to add as the next generation of Free Fleet. And one of the reasons is because it's actually been rather requirements driven based on the projects that we're running. So it would be amazing if we could hear more from the community or vendors or people in the industry, what would they like to use Free Fleet for and how they would think a proper fleet management would work for them. All right, so this, I've come to the end of the presentation at the moment. So this is Free Fleet as a robotics fleet management system, how it's been for the past year or so, as well as going forward, what we're going to be working on. And then I thank you. So this is just a photo of us pre-COVID. So I would, oh, what did I do?
Yeah, it was an excellent presentation. I really like the demo part where different robots make their way through it. So thank you, Aaron, for your lovely presentation on robotics. And on next, I would like to invite Mr. Kelvin Tan. So if you are here in the meeting, Mr. Kelvin Tan, then you can switch on your camera and audio. Thank you, Aaron, for your presentation. Now you can switch off.
Hello?
Yes, yes. Can you switch on your camera, Mr. Kelvin?
Sure, sure. Hello, can you see me?
Yes, yes, I can see you.
Okay, great. Should I start or wait another 2 minutes?
Yes, I'll first give a short introduction about yourself and then we can start. So Mr. Kelvin is himself a maker, an entrepreneur, an educator with interest in robotics and machine learning. And today we will be learning a robotic platform for exploring and evaluating search and reinforcement learning algorithms from him. It's a 15-minute talk, and I hope we'll learn many things from Mr. Kelvin. So, Mr. Kelvin, you can take the presenter, right? Wait, I'll just...
Okay.
Okay, I have made you...
Right. Okay, sure.
Yes, I have made you
No.
presenter. Now you can present your scheme.
Okay. I click on it and I'm trying to share my screen, but okay, good, got it. Can you see my screen?
No.
Oh, no?
Yes, it's coming.
Oh, okay,
It's coming.
sure. There's a little bit of lag. Okay, great.
Yeah.
Thank you for the introduction. So, okay, let me get back to my PowerPoint. Okay, so basically, I don't claim to be any expert, and I'm just playing around, right? So my background is in microelectronics, and I was spent a few years in the semiconductor industry, doing different things from engineering to sales to operations and so whatnot, right? Then I came and start my own business, and the business is in people counting and also dash cam, like people counting the Singapore Bicentennial exhibition, ran the people counting project for them, and also the Borneo motors, and we supply some of the camera for them. So I'm just curious person. Okay, so during the COVID period, while stuck in the COVID lockdown, just get myself busy and did some project. So this is one of the project. So this slide I've already put onto the link, so I would not want to go through this again. So basically, started to read some books on machine learning, and what interests me is this Dr. Clark Shannon, with his mechanical mouse called Theseus. So it is far ahead of his time. So so I know now we use the GIM platform to do machine learning, right? Especially the basic search algorithm, right? So I think when you look through the introduction to like reinforcement learning books, right? I think one of the chapters, first few chapters will be on the search algorithm, specifically even the frozen lake problem, right? So I think that's what I'm trying to emulate using a mechanical platform, right? So I'll just go through the other set of slides with the video. I think that would be more appropriate. So the electromechanical reinforcement learning platform, design and build journey, okay? So the inspiration basically is just a curiosity, you know. I just like want to learn and try out, right? Besides just repeating whatever that is in the book, like to just get hands-on and see how it works, right? So you can read more about the maze solving algorithm and search algorithm. I think there's a lot of resources out there. Wikipedia is a good introduction to that. So started the journey, I think also part of more time. So I enrolled in the National Library Board's Pixel Labs Intro to 3D Printing, right? So I booked some slots to learn the basics. After that, I purchased my own 3D printer and printed many things, and I started to look at, hey, what kind of things that I can build beside the basic souvenir, right? Then I also came across the code by Eric Delange. I think it's on the GitHub. So look at it, how to modify that to run on the mechanical platform. And then added some additional features like Bluetooth connectivity, improve the power supply circuitry, right? So this is the design, basic design. I just used Tinkercad, right, for the basic design to build the structure for this platform. And then this is how it looks, right, during the building process. A lot of soldering my wires. I made the mistake and then have to take out and re-solder and re-hot glue. So it's powered by hand. And put that together. So give you a demo. Maybe the sound is not needed. Okay, so it's running. It can work with Bluetooth. So as you can see that it's giving notification. I can also use the plan is to do it wirelessly, right? Ideally using a mobile device to control the platform, and the machine learning can be done through the mobile device, right, rather than the PC. So I've also ported this to the Raspberry Pi, but I guess because of the wireless, right, is not so fast. So I think the PC is still a little bit better, and wired serial is more constant. So this is just running a test algorithm. It's not running the deep learning. As you can imagine, because of the number of iterations required, right, it will really take a long time. Even on the software itself, right, without the mechanical platform, it's already taking a long time. So it's driving this magnetic ball across the stage. We can see that this is the Python, just basic Python running. Okay, sorry. So this is the algorithm. So at first it doesn't know what's on the stage. It's just randomly driving it around and discovering what is the advantages of the position, right? What is the, because of, for example, the SASA algorithm, right? Look at the current position and what is the value of the current position and the value of the left and the right and whatever surrounding location it should go through. So over time, it would discover advantages of a certain movement, right? So after a few iterations, it discovered that certain position it can't drive to, then it will be automatically labeled as a gray because it's still not 100% certain. And once it's certain that that location cannot be driven to, it will turn black. So you can see that the blue line is the movement, the red is the actual ball. Where is the ball now, right? Okay, a bit more. Then it's a bit further down the chain, right? You can see it's still not really particularly clever, right? It makes see, it's supposed to just move down, but it doesn't. The problem with, the issue with this is that sometimes because of mechanical state, right, it doesn't go as intended. The ball may roll a little bit to the left or to the right, so end up not exactly into the position that you the software or the algorithm intended it to be, right? Whereas in the software simulation, it just go exactly to where it intends to go. So a bit more. So it is a little bit later stage. So basically the same thing, right? So this process takes a long time. Okay. So maybe I just drive this. Okay. So finally, once it has learned enough times, you can see it's quite some time already. I need to turn on my lights already. It's able to very efficiently start from any position and find the destination, no matter where the starting position is, right? And my PC, this laptop doesn't have a graphics card, so it's just running on the CPU. Okay. Sorry, I think we just need to. Okay. So this is the learning from the episodes. You can see it takes like over 600 episodes to get to have enough confidence, right? Of this is like an error, right? How much error, right? How many steps are basically the cost, right? So it will go to the destination with minimum steps. So every step it takes will have a cost to it, right? So if it makes a lot of random moves, then the cost will be very high, right? So over time, it definitely learns, and eventually the cost is acceptable, the learning stops. Okay, so that is the first prototype using hand solder, right? So I think the next stage would be to do the 3D modeling and then PCB design using KiCad, which I've already done a bit. Then we need to I need to improve the sensing stability, because the sensing doesn't always detect the magnetic ball at the exact location. So we also need to optimize the code for improved speed. Now it's just running pure unoptimized code. Even the Arduino that is on the platform is just running on the Arduino Pro Mini, right? So maybe make a nice user interface on the cloud for loading. So the KiCad model, I haven't finished it, so a bit more. And this is the references, the references, right? So you can find out more about this. I'll upload this page. So I think the inspiration, again, I said that this is the Dr. Claude Shannon's work. I recommend you watch the video. The bit player is very interesting personality. That's all for my slides. Let's see. Let me go back to the presentation. Okay, can you that's all my presentation. Yes.
Yes. So thank you, Mr. Kelvin. It was really a nice talk. I was really amazed by the ball solving the maze, moving the movement of the ball. So there is a question from Luca. What is the sensor system to detect the position of the ball? Did you consider using camera to avoid the drifting of the side issue?
Okay, so I'm using the Hall sensor, magnetic Hall sensor. So I know that there are many systems out there that uses camera. So the problem with the camera that is bulky, right? You need to place it on top, right? Looking down, right? The camera system is not new. I mean, this invention is the theoretical basis is not new. Camera has its advantages because it has high resolution. But the problem is that it needs to be positioned exactly on top, right? And then if you drive the stage, then there will be alignment issue with the camera position versus the stage, right? So you need to either account for the alignment issue or drive the stage with the camera together. But then the platform will be high, right? You need to account for the camera to look down, right? Enough distance. The other issue is the lighting condition, right? You need to maintain ideal lighting, right? That the ball and
or else the image won't be captured that nicely.
Yeah, must have high contrast. And then another thing is that, let's say you have something that is blocking a maze, right? Then you won't be able to see. So it has to see the stage. Whereas this stage, right, without the camera system, I can have a lot of variety that is new. Right. I mean, like you have the ball go into the hidden stage and even go into a liquid, whatever. Right.
Correct. And Luca is also saying that love the Hall sensor solution.
Okay, great. Thank you.
Yeah. So are you available for in any discussion rooms or in the chat? So if any questions arise.
Oh, okay, sure. I will be available. I think Aaron has another question. So how many mazes have you tried on this? So the mazes actually is flexible. You can see, right? This is a maze. I can even take it out, right? And you can run. I can remodel this stage, or can replace the entire stage itself and give it a new challenge. So the algorithm, of course, he has to relearn, right, the new maze. So you can't just use whatever that I've learned and put it and run. It will get lost. It will not achieve the learning, right? I mean, we'll not be able to drive to the exit, right, without relearning everything. And the learning process is the one that takes time. So it depends on how complex the maze is. The more complex the learning will be exponentially longer for each next, like now
Yes.
8 by 8, right? It's already not trivial. I mean, it's not a short process.
The complicated the maze, the more time it will take to train.
Yes, I think that is the challenge, right, with the these algorithms. Right? I mean, that's why I thought maybe we can have this maze as a challenge game, right? See who can come up with the fastest learning algorithm for the maze, right, on a real platform.
Yes, it's really cool. So thank you, Calvin. It was an excellent talk. You can have an eye on the shared document. If there are more questions, then you can freely answer it in the comment section.
Okay, sure. Thank you.
Thank you. Have a nice day.
Okay, nice. Thank you.
So on next we have Shriman Venkatesh from India. So Shriman, are you here? Can you switch on your camera and mic? Shriman Venkatesh. Yes, Shriman is here. Shriman, can you switch on your camera and mic, please? Okay, we have Shriman. Okay, no problem. So welcome, Shriman. I will give a short introduction about you and then you can start. So Shriman is an engineering student from MACE, Kerala. He is a fourth year electronics and communication engineering undergrad student and his interests include electronics and computer science. He likes to play around with technology learning and about the working of hardware and software in the process. And today we'll be learning with him Introduction to Emulation Development. So Shriman, I have given you the presenter right, so you can just share a presentation and start presenting.
Yeah, thanks a lot, Shubham. Am I audible?
Yes, you're audible.
Okay, thanks. I'd like to mention that my name is actually pronounced Sriram, not Sriman.
Oh, sorry, my bad, Sriram, sorry.
So what I have done is I have already recorded the talk and uploaded it to YouTube. So I'll be showing the video first, and then I'll talk a bit more about the topic, or if there are any questions. So
cool, Sriram. You can do as you wish. All the best.
This talk is going to be an introduction to the concept of emulators. Today I'll be talking about developing emulators for video game consoles. So I'll just start playing the video. This talk is going to be an introduction to the concept of emulators, how they work, how they're designed, and how you can try making your own emulators as an exercise in programming. So what is an emulator? Wikipedia defines an emulator as hardware or software that enables one computer system to behave like another computer system. So an emulator is basically a program that is used to run other programs designed for other machines. In the context of my talk here, I'm solely going to speak about hardware emulation of retro video game consoles. So essentially, we are writing software that mimics the behavior of the console and allows us to play games intended for those consoles in our personal computers. At first, I'll be explaining everything with the example of the Nintendo Game Boy, since it is one of the most iconic gaming consoles of all time. Once we cover a bird's eye view of emulation, we'll see how we can get started with writing emulators and why it is a good programming exercise. Talking about the Game Boy, it was first released in the year of 1989 by Nintendo in Japan. Although less sophisticated compared to its competitors at the time, Nintendo has sold over 200 million copies combined from all the Game Boy models. The games intended for the Game Boy and other similar consoles came in cartridges called game packs. These game packs contained the necessary circuitry to store the game's program logic in a read-only memory chip. When inserted into the Game Boy console, the Game Boy processor, which we'll get into in a moment, reads the program from the chip and executes it, thus starting the game. In the context of emulation, in order to run this game designed for the Game Boy in another device, say our laptop, we need to first get the contents of the game pack. The contents of the read-only memory of the game pack are read to create ROM files, which is essentially the code for running a Game Boy game. This game code will contain instructions from the instruction set of the Game Boy architecture, and the size of the ROM file varies according to the game. For example, Tetris has only 32 kilobytes of data, while Pokemon Crystal is about 2 megabytes. Now that we have the actual program that we need to run in our computer, we need to see how we can execute this program in the same way a Game Boy would execute it. It is at this point we need to start looking into the internal architecture of the Game Boy hardware. If you're into electronics, you would have encountered microprocessor architectures and would be familiar with all of this. Essentially, a CPU has several components which makes it tick, like the registers and the primary memory or the RAM to store temporary data, and an arithmetic and logic unit to perform operations on this data. In the physical device, we are implementing this with circuits made up of logic gates with flip-flops storing bits of data and adder circuits doing operations on binary numbers and all that. But when writing an emulator, we are implementing the entire hardware architecture with software. So instead of the physical registers inside the CPU, our emulator program will have a few global variables representing each of the registers. Instead of a physical circuit of the ALU, we can just implement all of the functionalities of the ALU as functions, which takes these registers as their arguments and modify their contents. In a similar fashion, we can create other peripherals of the console like the keypad, the monitor, and the sound system. The working of all of these involves reading and writing from certain registers in the CPU. They might also need to keep some internal state as well. For example, the keypad might have an internal state to check if a button is pressed or not, and depending on this internal state, it might change the value in one of the CPU memory locations. In the case of a monitor, the 160 by 144 pixel screen of the Game Boy can be represented within an HTML canvas or any other equivalent method, and the pixels can be updated according to the changes occurring in the memory of the CPU. So if you're working with the object-oriented programming paradigm, you can create a class for each of the CPU and the peripherals and link them together. Once we define all the internal architectural details like the registers and the functionalities of the ALU and lay down the rules of how data can be transferred and processed in between these elements and with the peripherals, our software-defined CPU is starting to take shape. Now that we have a bare-bones structure of the CPU, we need to define what to do with the ROM file. The CPU needs to be able to read the ROM file instruction by instruction, decode what the instruction means, and then do the necessary processing that each of the instruction defines. This is same as the normal fetch, decode, execute cycle in microprocessors. And in our emulator, we write code to account for each of the instruction in the entire instruction set of the Game Boy architecture, and what to do when each of these instructions are encountered. You can refer the instruction set of the device, usually represented in the form of an opcode table, where all the instructions, their operands, and the operation involved are described to great detail. Once we program what to do with all the instructions and define how fast the instructions must be read and processed, we can run this program with the ROM file as the input, and our emulator should hopefully read and execute the game from the ROM file. So that has been a bird's eye view of what emulation is in general, and it must have been quite a bit to digest if you're unfamiliar with the electronics involved like the processor architecture and all that. So if you'd like to get into emulator development, a good place to start would be the chip-age system. The chip-age system includes many of the famous retro games like Tetris, Pac-Man, Breakout and such. Chip-age is also an ideal place to start building your first retro console emulator, since it is a really simple system with only 32 opcodes in the instruction set, meaning that you can finish writing the entire emulator within an afternoon if you're familiar with programming and a bit of electronics, or within 1 or 2 days if you're just getting started with these. The input and output peripherals of the chip-age system are also fairly simple. with the display being a grid of 64 by 32 pixels, which can either be on or off, meaning that you can easily program them with a simple array representing the state of the display. The sheer number of tutorials and guides for learning and building with the chip-based system also makes it worthy of the perfect beginner project. Now, with all that out of the way, let us conclude this quick talk with why you should try building an emulator. The reason you might want to get into this nerdy hobby might be different for each of you. For some, it might be the nostalgia associated with all games they played as children, while for some others, it might be the programming challenge involved in getting all the parts of the emulator to work together. Whatever your motivation might be, emulator development is a fun and highly rewarding hobby where you can learn a whole lot about programming and how computer hardware works in general. I really hope that you found this talk interesting and that it inspires you to try building an emulator on your own. So that was the talk. So before I go into any questions, if there are any, I'd like to mention that I'm still learning and building with different emulators, and I might not be an expert. So if I am not able to answer any of your questions, I'll definitely get back to you via email or something. And other than that, I hope you found the talk interesting.
Yes, it was. Like, I will surely try to make some hack on involving this emulator thing. And participants are also feeling like it's an interesting one. So let's see if we have any questions in our shared notes. Okay, so currently we don't have any questions in our shared note. And Shriman, till what time will you be available in our meeting, so that if any questions hop in our shared notes, you can just see them and answer it in the chat section. Is it cool?
Yeah, sure. Also, I'll share a link. Shall I just put it under my session in the shared notes? So I have created.
Sure, you can do that.
Yeah, so I have created a list of all the resources and references that I have used while learning about emulators. So I thought I'd share that.
Cool. It will be very helpful, Sriram. So folks, you can also just have an heads up on moving to the emulators by referring this link.
I think Kelvin has asked a question. What are the hardwares compatible with the emulators? So here we are dealing solely with software emulators. So we can also create emulators on hardware, but I'm not particularly sure about that because I haven't studied much about hardware emulators, but it is possible. And I think we can try to emulate the CPUs of such old and less complex gaming systems using FPGAs or something like that. But I'm not sure because I don't have much experience working with those.
Cool. So thank you, Sriram, for your talk, and have a nice day.
Yeah, thank you. I have shared the link in the shared notes.
Hello, good evening, everyone. From Michelle from Bangkok, Thailand, and I will be your MC for the next 2 sessions. So up next today is Fabio Sobral. I'm sorry, did I get your name right?
Sobral.
Sobral. Okay.
Yes.
Yes, I can hear you fine. Okay, sorry, I'm trying to give you admin rights. Hey guys, Mario, if you're hearing me, I cannot give I cannot give presenter rights. You just check. for me? Sorry about that. I'll be right with you. Okay, well, I think you have a presenter rights. Can you please switch on your webcam, Fabio?
Yeah, sure. It's not finding my webcam. It worked on the support channel. Let me try again.
Sure. Now we need someone to write an emulator that will accurately emulate webcams not working before presentations. That would be that'd be fantastic. Okay, so just a quick introduction while Fabio's getting set up. So Fabio Sobral, who's a developer advocate at Total Cross, has over 10 years of experience developing for mobile platforms, working with more than 100 different mobile devices. That sounds impressive. He will be giving a talk on choosing the right programming language for the GUI implementation for Linux embedded. So please give him just a couple minutes. He'll be on shortly. And this talk is 25 minutes long. Just as a reminder for the upcoming session, if you have any questions, please add them to shared notes.
I think I got it to work now. Okay.
Okay, fantastic. See you. Perfect.
So let me share my screen.
Yes, please. Perfect. Over to you.
Okay, on presentation mode, can you see me? Can you see my screen?
I can.
Cool. So, hi everyone. I'm Fabio. I'm from Brazil. I've been working for the last over the last 10 years with mobile devices. I've worked with Palm OS, like Windows CE, Windows Mobile, BlackBerry, Android, iOS, you name it. And over this time, we've had a really big evolution on the mobile market. Not only when we think about hardware and processing capabilities, but also the way we interact and we perceive applications. I think that when the mobile market started, when things started like with Palm OS, Palm Trio, we as users were used to having to learn how to use an application. So the same can be said about embedded applications and such. So we were kind of okay on learning how to understand graphical signs that weren't very clear, or having to resort to documentation and help topics. But nowadays, this is not the same. This is not true for now, because we as users are used to the type of signals, the type of interaction, the higher quality of graphical applications from our desktop and our mobile devices, more specifically from our mobile devices. So even for medical applications, for example, like this one I'm showing, this is, of course, a perfect sample of application. It does the work it's supposed to do, but it may not be clear enough to understand at first sight for someone, even for someone from on the field, and not be easy to read for any type of person. We have to worry nowadays about how clear, how crispy the fonts are, and bigger screens and such. So nowadays we have to worry about a lot more about the graphical interface. And not only it must be easy to understand, essentially the user doesn't have to feel like he has to learn something. He's just using whatever he knows from the mobile market and the desktop market, and use it on this new screen, on this new device. It can be in a smart home device. It can be a medical device. For example, I've been to the dentist last week, and she has a pretty great device that for some laser stuff that she did on my teeth. I don't know exactly, but for me as a patient lying on the chair, I could just look at the right and understand whatever she was doing on that machine. It was really clear for me, even not knowing anything about the medical, but what she was actually doing with that system. So, for example, of course, I don't know why she was setting the potency of the laser higher or lower. She has her reasons for doing that, but I can understand that she's doing that. And for someone that has that knows how to operate that system, it becomes familiar enough to be able to quickly use it. And not only use it, but engage with your interface, because we have to think that users now must be attracted to the system, must engage and be willing, they must want to use your application and not just use it because they have to or because they need, especially because there's a lot of competition right now. And for example, if you're thinking about a media center for your car, you might choose one model over another. You might choose a different car because of a media system, if it makes that much difference for you. Because for the person driving, unless it is a car enthusiast, a car is just a way of getting people from one point to another. And as long as they can drive well and do everything well, most of the times you probably be using the system, all the media and the controls for the device. So if he can figure out quickly how to connect his phone and answer a call, he might not be willing to have that car, for example. And of course, this is an extreme example, but this is becoming a lot more common when you think about embedded devices, especially when you think about home appliances like refrigerators, washing machines, and medical devices, because being able to quickly recognize and operate over a device is just as important as having the best performance and being able to quickly calculate and give feedback over the data being collected. So with this in mind, I'm going to talk about I'm going to focus about in 7 topics that we have to worry about when choosing a programming language to work with our user interface. And it's important to get in perspective that I'm talking specifically about user interface. With any of these options, you may want you are free to use your own language. You can use bare metal or whatever for your backend, for your for the heavy stuff, for the heavyweight stuff. But but usually those languages, those frameworks are not good enough, are not easy enough to handle graphical user interface. So you have to resort for something that might be a little heavier, but delivers what you need in less time and less effort. So we're focusing on time to develop, the availability of developers and the cost, the maintenance costs for fixing bugs and minor improvements, not something like a new complete feature, memory footprint, being able to provide a modern UI, performance, more specifically, not affecting the core of your system, what it must do on the back end, and the complexity to learn and maintain that language, maintain an application, use that language. These are the 4 languages we'll be looking at, and we'll be grading them from 1 to 5 for each topic. some of them might be a little, how can I say, counterintuitive, because I'll be giving 1 for high footprint. That means it's bad, and 5 for low footprint, which is good. So remember to keep in mind that it might be a little counterintuitive for some of these topics. And these are the 4 languages. Okay, first we'll be looking at C++, of course. C++, we have a high language complexity, which means without thinking about how you program your system or how well you develop, the language itself doesn't provide enough the syntax of the language, the constructions, it doesn't provide by itself a way to easily understand and maintain an application. I'm not saying C++ is incredibly hard to understand. I know C++, but I also know that if I get an application made from someone else that doesn't follow specific guidelines, specific architecture, and that I have some kind of documentation, I'll have a hard time to learn and maintain this application later. So first, I'm looking at language complexity, then time to develop. As it used to be a high-level language, but nowadays you can think about it a low-level language. Being a low-level language, a lot of the heavy lifting has to be done by the programmer, like allocating memory and managing memory pointers and accessing the devices. The developers are usually more costly than other developers because they need a lot of experience and background with applications, and are usually harder to find on the market. And all these characteristics end up reflecting on a high maintenance cost, because you need experienced programmers to find difficult bugs, difficult problems in a language that is really complex to understand. But the trade-off, of course, is that you get high performance and really low footprint. And of course, the main topic of this discussion is the capability of making a modern UI easily. And with C++, we could use a lot of frameworks like GTK. I'm focusing here, this grade I'm giving to C++ is with Qt and LVGL in mind. Both are FOSS. Qt, okay, it's sort of FOSS, but okay, it's both are FOSS technologies that may be used for anyone, but they are not high level enough to be really easy to perform, to make modern UI. Okay, you can do it, but it takes a lot of work, a lot of effort, and not everything is done quickly. So next I'm going for JavaScript. JavaScript is kind of almost the opposite of C++. We have a language that is really easy to learn and understand. It's really easy to develop. It has a lot of libraries and stuff. Remember, I'm talking about user interface, so I'm not talking about having a library for handling devices or internal stuff. I'm thinking about libraries for providing widgets or or graphical components. It's really easy to find developers, and that tend to make them cost less. And again, I'm thinking about the whole market of developers. I'm not thinking about embedded developers. The idea is to find developers outside of the usual embedded market. So you can easily get a web developer or something like that that knows JavaScript to make an interface for an embedded application. The maintenance is easier, but some characteristics of JavaScript, some features of JavaScript can make them a lot harder to maintain. Sometimes being not strongly typed may hurt a little. But of course, all these benefits, all these features translate into really bad performance and really huge footprint. So with JavaScript in mind, I'm thinking more specifically on Electron.js, which is a common framework used nowadays for stuff like VS Code and Telegram, and I think GitKraken can also use it. I'm not sure, but a lot of stuff we use nowadays use Electron. But you're basically using a browser and embedded the JavaScript engine, so it's not that easy to get all this stuff to run well on an embedded device. You need a more expensive device, but of course it will be really easy to make a modern UI with JavaScript. Well, next is Python. Python is also a good alternative because, like JavaScript, it's has low complexity. It's easy to develop. It's not as easy to find developers ready, but it's usually easier to maintain. You lose performance and footprint compared to C++. But you'll be able to make the same level of modern UI because usually for this example, I'm thinking about Qt. So using Python with Qt, although it still has some difficulties, it's not like their main tool, their main framework. They are focused on C++. But we will be able to deliver the same type of UI, the kind of the same effort as C++, but of course at the cost of performance footprint. And lastly, Java, which may raise some eyebrows. Well, a disclaimer: I've been working with Java for the last 10 years, over 10 years, and more specifically for Totocross and with the mobile market. And when I speak about Java here, I'm speaking about the language Java, not about the JVM, the OpenJDK, or anything like that. And more specifically, I'm talking about this technology that I've been working on, which is Totocross. Totocross is actually a VM. We have our own VM. It's not a JVM. It's actually, if you want to take a look at the code, it's available on GitHub Totocross, and you can even learn something about emulation there because that's basically what a VM does, like we've seen on the last presentation. But as our own VM, we convert Java bytecodes to our own bytecodes, and we have our own way of doing stuff to improve performance over the usual JVM implementation, and also some concerns like memory management, garbage collector, and give the user full control of the garbage collector. You can disable it and use it only when you want, or stuff like that. So having said that, with Java, Java is a language that it's fairly easy to understand, to maintain. It's really easy to develop, although it's a lot more verbose than JavaScript or Python. This is one of the most common complaints about Java, but it also translates on being easier to understand and to maintain, especially being a strong typed language. And it's really easy to find developers because Java, not only it's very similar to C, a lot of languages are following this kind of the same syntax, but also it was very popular. It might still be, I'm not sure, but it was really popular on colleges and learning facilities. It was the main language for learning for a long time. But also using this specific technology Total Cross, we can deliver performance and footprint. We can have a small footprint and high enough performance that we can compete with C++, and also be easier to make a modern UI than most C++ frameworks. So at the bottom line, these are the languages, the 4 languages that we chose to take a look at. They are all open and free to use. Those technologies used with this language, and the idea is not, of course, I'm from Total Cross, but the idea is not sell the idea that Java is the right language or Total Cross is the best solution. It's more about the importance of having a modern UI and how you can, how the way you choose the technology you use can have a great impact on the way you can provide an engaging and really easy to learn and use application for your users. So if anyone has any questions, thank you, everyone. Okay, so the first question about HTML5 and Rust. Well, first of all, I'm considering the technologies with frameworks that are, how can I say, that are more ready for production, that are more like, for example, Rust is a great language. I really like Rust, but graphical interfaces for Rust and using on embedded devices is not something as consolidated and as easy to make. And also, it's not that easy to find developers. So, of course, there are other options. That we have .NET frameworks, we have Rust, we have other options. We focus on these 4.
Okay, wonderful. Thank you. Thank you very much. That's all we have the time for. Thank you very much, Fabio.
Cool. Thank you
okay.
for for this opportunity,
up-
and I'll be on the discussion channel if anyone wants to chat.
Fantastic. Thank you very much. We will see you there. Okay. Up next, we have, excuse me, 1 second. We have Peggy Silop. Sorry, did I get your name right, Peggy?
Yes, I didn't hear it, but did you say Silop? Silop? I don't care actually so much. Thank you.
Okay. She's a scientific associate, an entrepreneur, an artist, and teacher who will be talking about like to hear self-adjustment of open source mobile hearing aid prototypes. Could you please start your presentation?
Yes, I don't have the option yet.
Okay, sorry. Let me give you that. Maybe a minute. Could you please try now?
Ah, yeah, now. So, hey, thank you very much for the invitation. I'm really happy that I have the chance to speak here about the of an open source mobile hearing aid prototype. Very long name, but I will explain it to you very simple what it is actually. Silop, I'm a computer scientist with Master of Public Policy and also media artist. I was into. So what it is it? It is actually a very simple made hearing aid prototype. That means we have open source hearing aid algorithm implemented available hardware, Raspberry Pi in this type, in this case, and we use it for research in the citizen science project 2017 to 2020 at Fraunhofer IDMT Olden, which is in Germany. If you are interested to see what we did exactly, you can have a look at this website. But I just wanted to mention it actually finished in 2020, but we got this open source prototype out of it, and we want to do something about it. If you want to hear a bit more about the story or read, just go on Twitter or on Instagram and follow it. Okay, so that's just about the background, but now let's address what's the problem. If you look globally, we have 1 point with hearing loss. And this is actually, you think, yeah, this is other people or this is people, but it's actually not like that. When you think, I mean, I'm sure there's a lot of, when you ask this question, do you think many people are mumbling and should put more effort in great pronunciation? So if you have the feeling, actually my hearing, did you think about making a hearing test yet? Actually, why not? So, and would you see a real chance that you get support and a good support that you will be better? So if you look just like a few days ago, there was a World Day at 3rd March. It was about hearing care for all. And there was launched hearing. I mean, persons aged like young people, 12 to 35 years, 50% of them are at risk of hearing loss due to exposure to sound of recreational settings. That going parties kill your ears. And also children, 60% of children have hearing loss.
And I'm so sorry to interrupt, Peggy, but there might be a problem with your microphone cable. Your sound drops out from time to time, but your image is perfect. Could you please see that it's plugged in, your headphones are plugged in properly? That is, there's not loose. Thank you.
And there's problem.
Yeah, could you please test again? Try speaking again.
Yeah. Can I speak again? Is it better now?
Yes, it's better now.
With hearing loss, they don't have use hearing aids.
Sorry. Apologies. Your voice is again.
It's not.
It's okay. It happens. Try pulling it out and plug it in again.
But in Southeast Asia and Western Pacific, you have more than 200, about 250 million people with moderate or high. Worldwide, you have 980 billion dollar value, which costs hearing to the public. And this is like most of this hearing loss is untreated, but even this is one problem. The problem is if you have hearing aid, we are very 45% of the hearing aids are returned after first fit. So what we thought about is that are just the project was like going out, making sound walks, and asking people what they would like to have from a hearing support, and do 2 hackathons. You can prototype for self-fitting, like could adjust their sound by themselves, and then of self-fitting the amplification, just do it, and let the amplification. For example, this Udo Spiegel, who is quite old, elderly man, he has a severe hearing loss, and he's saying there was which was particularly impressive. And so how did we actually make it? So we have this open source.
I'm sorry to interrupt again, Peggy. And your voice is still going. Sorry, Hongfuk, do you have any ideas on how to help Peggy fix her mic? Are you using Firefox,
you know that
Peggy?
I really like this topic. Perhaps do you have another headphone that you could try out, Becky?
Or perhaps try without the headphones?
Or they...
Sorry, cannot hear you right now.
Yeah, unmute, Becky. Please unmute yourself. Becky, do you want to try to log out and reconnect again? Refresh, reload the browser, perhaps. I think the topic is really interesting, and we'd really love to hear you. It's just that there's some issue with the connection. Perhaps refresh your browser and try again.
Apologies for the technical problems, everyone. We will try to sort it out, and we'll get back to this programming shortly. Thank you for your patience. Sorry, still no audio.
I think Becky might try to join again. Yes, Misery.
Yes.
Should probably try to rejoin, yeah.
Mm-hmm.
Hello, can you hear me?
Your voice is still cutting off a little bit. Please repeat. No, I'm afraid not quite working.
It's not working? This is strange.
Have you tried using the microphone directly in your laptop without using your headphones? Sorry, cannot hear you.
Never done. Ah, yeah.
There's a question from our technical team. Are you using Firefox as your browser? Sorry, cannot hear you. Firefox, that's for yes. Yes, no.
Yes.
Okay. Would you like to try switching to Chrome? If you have it.
Yes.
And that's what it comes down to folks. Sign language on through webcams. Technology.
Hello?
Hey.
Maybe you can speak for a while so
Can
that
you hear
we
me
can
now?
hear you. Yes, we can hear you quite clearly.
Yes, actually, I can hear Becky very well now. Perfect. Thank you,
Yeah,
Becky, for trying.
I'm sorry, I know this, I shouldn't use Firefox. I don't know, I was kind of nervous and then... Okay, now it's too late. Should I still continue or?
Please
Yes?
continue. Please continue. Hello. Sorry, Peggy?
Hmm?
Okay. Yeah, I think you're back.
I'm
Please.
again. Yeah, I'm sorry, I just... Oof.
No worries.
Yeah. So I need screen sharing again, please. Okay.
Yep, please share your presentation.
Yeah, I do. So, good. Thank you very much. Sorry very much for this confusion. I should have known.
It's okay.
I know, actually, I just messed it up.
Yeah,
So this is like to hear box. I just continue if it's fine. I try to make it short. This is a like to hear box. Like we developed it, and it is as you see in a screen with a 2D touch as a web app where you can make a sound louder or softer, and you can like make emphasis on the more like lower frequencies and also on the higher frequencies. Very simple to use, and very simple and easy adjustment, and actually everybody was easy with it. So behind this, there is an open source mobile hearing aid prototype by Professor Mark René Schädler, who made it ready for Raspberry Pi, but for the like academic use for his students. And this is based on the open master hearing aids, which are the open hearing aid algorithms. You find everything on GitHub. Just have a look. You can just take over the links. So this is basically what's in the hardware. What's in it's a Raspberry Pi with a sound card, battery, of course, and a preamplifier for the mic, and some headphones with mics on it. So how do you use it? So like you see, we have just like the box to walk around with, and some app which is actually connected to the box. So you have a login. You use the Raspberry Pi as an access point, you log in, and then you have the chance, like you see on the left side, to like adjust your sound. And inside the box, there are the hearing aid algorithms. They will like adjust the amplification in the way like you control it, and then you get the output on the headphones. So this is like the technical side of it. You have the app framework. You have the hearing aid prototypes, which is like the hardware, Raspberry Pi. You have on the right, you have the Open MHA, which are the hearing aid algorithms, and all this is connected by the Jack audio connection kit, which is actually a basic audio connection for Linux. So this is the tech behind. I don't want to go too deep, but actually what it makes is like over the frequencies, you have like a general gain, like a general amplification. Like you see the blue line, if it's on the left, it's like overall frequencies, the same amplification. And if you go with the button to the right, you have like more amplification to the higher frequencies. And here you see when the input is quite low, it will have like a very simple linear amplification until a certain level of loudness, and then you don't have so much amplification like the gray circle is saying here. That is the movement of the surface. We go up and down. So that was basically actually working quite fine for the research when I was going out with people and let them just try out in daily life. And here, for example, George, with moderate hearing loss, he said, yeah, actually it was nice, but a smaller prototype would be really helpful. So this was actually surprising for us because it was a research prototype, but he's saying, hey, well, I can use it in daily life, just make it a bit smaller, a bit more handsome, and that's fine. I said, okay, that's a cool thing. It's open source anyway. Let's do something good about it. And so what we actually want to do now in the next steps is like turn the prototype into a real like maker's product, make it accessible for everyone, affordable for everyone, and make still possible these highly individualized personal settings of sound amplification. Like I want to remember this is the beginning of the talk, what I said, there's many like you say, adjustments done in audio laboratory, but people are not really happy with it, and they give it back. They don't use the hearing aids, even in like richer countries like we have, where you say we have really very high developed healthcare. And what we need for it, the requirements is an easy to use and a robust prototype. Like makes the hardware a bit smaller and more handsome, and makes the software a bit more like usable for everyday use. For this first step, we would like to make 20 prototypes for demonstration purpose. So like everybody here around who is interested, I would like to have such a prototype. I would like to test it and see if I can support it. We would like to make 20 prototypes, and we need about 10,000 euro for it. And I would like ask you to support us by give a donation to this bank of Enactus. Enactus is a student's entrepreneurial action, and you will also have a look at the link. And so we want also to make a bigger crowdfunding, but for the start and to find more people who are like likely to help us, we want to do this 20 prototypes. Yeah, this is our next goal. If you're interested, just get also in contact with us. I give also my contact details later. So if you are interested in the background of the hearing aid research, I propose to read some of these papers, which are not like very high that's like scientific approaches. It's I took that once. I think everybody can read at least the first one, which is sort of benchmark actually, more scientific way. But you can see what are the problems and the chances of personal fit of hearing aids and also hearables. And so under the background of my research group is which is down there. So if you want to get in contact, if you want to know more, if you just want to donate, just let me know or just do it, and I'm happy for any help. Thank you very much.
Thank you very much, Peggy. There are a few questions. Question number 1 by Milind. What is the latency of this device?
The latency is indeed lower than what you would with normal hearing realize. So it's about 1/10 milliseconds.
Okay, thank you.
That's actually the cool thing about it. It's really cool. I wouldn't think about Raspberry Pi, but it's really doing it.
Okay, wonderful. Thank you. So another question is by David. Can we build or replicate the prototype based on the info on GitHub?
Yes, that's possible. Yeah, we also want to make a forum. I will post it also on the social media accounts. Possibly I should also first, and so you can help you, and you can also help each other. This is social media accounts again. Yeah, you can just go on GitHub and see for like to hear and can build it yourself. That's the full instruction.
Okay.
And also hardware is freely available.
That's wonderful.
Hello. Can I ask some questions?
Hi, David.
Hi.
Sure, we have time.
Okay. Yeah.
Go ahead, David.
Hi, Peggy. Yeah, I think this is a very wonderful project. So just wanted to ask, are there any, or maybe which one of the components that's hardest to get to in order to replicate the project?
Which one of the components? So I didn't go too deep into these details, but I can show it to you. So these are the components, and what's really not so very handsome is this preamplifier. So, and we have to solder it yourself, and we definitely need to find another solutions. You can order everything of it. Just look on GitHub. There is also I wrote some tutorial how to do it. But the preamplifier of the microphone is most unhandy because it is SMD modules and it's hard to solder also.
So it's ready-made thing that people can purchase, or is it self-built prototype as well?
If you have to test it, what was the question? So
is it a product available that people can order, or you have to source the individual chips and components?
Yeah, you get actually the kit, and then you have to solder it yourself. And actually, I mean, what we want to find solution for it. So that's why I'm working with the students of Enactus together to find like more handsome solutions for this, and to, for example, see that we can like pre-produce some more simplified and smaller preamplifier for mics, and then we could like hand it out. This is one of the next steps to be done.
I see. And sorry, I have another question. So, given that it's a Raspberry Pi and we can connect Raspberry Pi to the internet, right? I think it would be interesting also to sort of stream audio into Raspberry Pi, right? You ever thought of things like that? Like, maybe stream music or audio book, or some other, maybe even more wilder things like animal observation, recording voices, things like that.
Yeah, also basically, so it can be used for everything. So there's this open master hearing aid, a hearing aid algorithm which are below it, which is based on. They have some modules you can adapt them to any purpose you have. Really. So if you like to use it outside for animal observation and then record your sound, which is actually I was also thinking about this, about work together with ornithologists, how is it in English, with people watching birds. And because it's mostly like people who have time, elderly people, and they don't hear the higher frequencies. So the birds with singing higher frequencies, there's not so much observed. And so I thought it could be a good tool for birds observers to have this to like amplify the higher frequency, and you can even record it. Yeah, that's not that difficult actually to implement.
Okay, well, thank you.
Thank you.
We have run out of time. You guys can continue the discussion in the discussion room, available on the sidebar on the left. I can walk you through it later. Okay, so handing it over now to our next MC. Thank you very much, Peggy. Thank you very much, everyone who has asked the questions.
Thank you very much also for your patience and everything. Bye.
Right.
Okay, so yes, hello. So Michael, I see you already setting things up. But we can't see your presentation yet. Still have to activate it. Can we test the sound quickly in this channel? I know we also just tested in the support room. You need to, okay, one moment, yeah.
Sorry, I'm reading what? Uploading slides. Okay, uploading slides. No problem. But can we test if the sound is working?
Yes, let's do that. Hopefully it does. Ah, good to see you, Mario. Excellent. Sorry about that. I just couldn't escape while I was doing these uploading of things. Perfect. I have a button to press.
Yeah, excellent. So yeah, we weren't sure like if people upload the slides before, if it might interfere with the previous speakers. So sorry for not giving you the rights earlier. So yeah, thank you very much. And actually, we still have 1 minute time before we start. So, but it's good to see you. And I just want to share with the audience that we have shared notes here for anyone who's joining now. So basically, we're always happy people using the chat back and forth, but we have shared notes where we collect questions for the Q&A of every session, and you can go to the left-hand side and just fill in your session. Please also fill in if you your name, if possible, so we can refer to it. And yeah, then we have it. Okay, so then I would like to officially start this session here with Michael Meeks. Michael, welcome very much here to this session at the FOSSASIA Summit. Michael is a Christian and enthusiastic open source developer. He runs Collabora's Office division, leading the Collabra Online and Office products, supporting customers and consulting on development alongside an extremely talented team. Michael serves as a director of the Document Foundation and on the LibreOffice Engineering Steering Committee. He has contributed to both ODF and OOXML standardization. Prior to Collabra, he gained a wide experience as a Novell SUSE distinguished engineer working on various pieces of free software infrastructure across the Linux stack to and from the base system, boot time, MeeGo, GNOME, Corba, Nautilus, Evolution, and open source accessibility, among others. Michael, it's a pleasure to have you here at the event, and I'm handing over to you. Please go ahead with your presentation. Thank you very much for being here.
Thank you, Mario. 51 slides, 20 seconds a slide. Let's see how we cope with it. So thank you for coming. Collabra Online is just an awesome free and open source replacement for proprietary online and actually mobile Office suites. And it's built on the awesome LibreOffice technology. So everything under the hood that you're used to there is there. So brilliant interoperability with Microsoft. And actually that's the place where we can actually excel. So if you look at Microsoft Office Online or Google Docs, you know, there are a lot of drop-offs, there are a lot of missing features and so on that we can actually do significantly better than in many areas. Of course, we can deploy that on-premise, so you can control your CPU, RAM, network, hardware, and of course all your documents inside that, and you can not let them outside your site. To do that, we have to integrate with many of our friends, you know, your OwnCloud, Nextcloud, cFile, Groupware, for enterprise file sync and share, Moodle, Mattermost, and many others. We have a number of proprietary and hosting solutions from Dell to Micro Focus to all sorts of places. We apply freedom. So we give you back your digital sovereignty, and we give you, of course, access to all of the code and the ability to contribute. And we have a pragmatic approach. You know, why rewrite something when you don't have to? Well, let's reuse, let's build upwards and not continually reinvent with a CADT development model. And lots of people are using it, as you can see. So let me find the button. And how does it look like? Well, here it is. Here is Writer, looking very nice. You'll notice, compared with, say, Office 365, that we can do things like redlining. That's kind of useful. And also we have a WYSIWYG editor. So, you know, all of the features you're really expecting and looking for online. Obviously, spreadsheets too. Here's some nice shop. What else? Presentations, so some slides. And looking very slick and crisp, working nicely on tablets for iOS and the Android tablets that exist. And of course, a totally different UI for mobile phones, so for single-handed use, nice big buttons. And actually, we wrap our sidebar here and turn it into all of these palettes of tools here that will be familiar to anyone using mobile phone app. And of course, we do that in the web as well. So if you're using the web version to collaborate on a mobile phone, you get that too. So lots of goodness, really lots of goodness there. But how can you get it embedded into your application? And that's really what I like to look at. So the great news is that this month, just actually I think the first of the month, we released a whole load of new SDK documentation with walkthroughs, setup stuff, all sorts of easy ways to get understand what's there, grab it, integrate with it. We have demo servers you can play with and test your integration with, all sorts of nice ways there for people to do it. So just sdk.collabraonline.com. And in case that's not enough, we have easy-to-use code templates. So you can just take and drop into your project. They're Apache license, so very, very liberal there. If that's a problem, come and talk to me. We have a Hello World skeleton there, and you can just grab it and play with it. For a growing set of languages, so we've got PHP, Node.js, Python, and we're extending that. And of course, it's no use writing documentation. People want to understand. It should be intuitive and easy to use without needing to read the documentation, obviously. There are a few hermeneutical keys that will help you understand. Let me just give you one of them. So lots of people, when they talk to me, are like, where does it store the documents? How do I, where's the state? What happens here? And those are great questions. The best way to understand this is the world's biggest microservice. So Collabra Online should be stateless. Obviously, when you're editing the document, it has a document in it. But that document is then stored, auto-saved, serialized back to, well, whatever you like, through your EFFS chat, whatever you're using at the back end. So we don't store your documents, you store them. And we don't do the authentication either. You give us an authentication token into the iframe that will let us get and save those documents. So we try, the world is a big place, and there are lots of things that you could do, but we want to focus on Office and that productivity suite. It's enough of a problem space. The 10 million lines of code and so on are enough for us to be wrestling with. So we like to let other people do the things that look easy but aren't, like authentication and storage, object databases, goodness knows what. So we hand that all off to someone else, and we have a REST interface that we use to access that. So here's how that works. There's a RESTful, and I'm flicking through slides here. I'm hoping other people see them. I'm on slide 13. So we have basically a very complicated REST interface, as you can see. There is a get method that downloads the file effectively into your iframe and shows you it. And then there's a post method that saves it back. And there's a check file info, which provides a whole load of information about the user. What are their permissions, their real names, so we can show other collaborators what's going on, whether they're allowed to print or download or copy and paste, or so we can lock the data down really firmly, and whether it should be watermarked securely, or there's just a whole load of options there. I'm trying to think of others. Theming, how it should look. Yeah, so lots and lots of interesting things. And so you just embed the iframe in your web app, and you send an authentication token that your REST server will understand and appreciate. And then you send a file identifier to say it's that file that we want you to edit. And that's pretty much it. Anyone else that gets the same file identifier will end up in the same document and collaborate around it transparently. And it's really just extremely easy. But hey, check out the SDK, check out the examples, have a play. It's great fun. So yeah, so give in to peer pressure all your friends have. I think that's the important message here. So other people are out there doing all sorts of good things. So with Alfresco, that's of course written in Java. With Jecky and Arrow and Magenta in the past, we have a great connector for Alfresco, which is great. For eGroupware, it's a PHP thing. With JavaScript, we've done loads of work for them, embedding it into their nice application. Collab, again, PHP is very popular. Look at that. But they have a whole load of things. Nextcloud, obviously, is a great big integration here, and just done loads of work with these people to improve it and make it richer and more integrated. I'll show you some more of those things later. OwnCloud, of course, it's a mix of PHP, JavaScript, Go. Even Python, actually. So CERN, the particle accelerator guys, super cool. And they've created a nice Python bridge between the WAPI protocol we've used and I just talked about, and the Go backend of OSIS, well, actually, I think their own file system. One second, just cough. Good. So some great work going on there. Mattermost, if you like chat applications. Moodle, if you're into learning. Who doesn't like learning? So another PHP. And anyone that has something that stores documents or something that will benefit from spreadsheets or some kind of charting or this kind of thing, we can do some really cool things together and provide people with a very rich user interface to configure and play with document data and make that look really good. So beyond the basics, but say you've done your integration, and you've looked at our style guide and you thought, wow, doesn't it look just beautiful out of the box? And then you think, well, I want to change it. So as you post into the iframe, what you can do is you can configure loads of different things about the look. So there's a whole load of these delimited options. I don't know if you can see the this text ruler equals false, status bar equals false. You just stick this into your input field in your iframe, and then you can select which kind of UI you want. Do you want it to look more like Google Docs or more like Microsoft Office? Oh, there you go. Do you want a status bar at the bottom? Do you want it only for one kind of component? Do you want the sidebar at the side? Do you want rulers by default and so on? So you can configure a number of those sort of very visual settings. But better than that, we have theming. So we could pre-can our theming, but it seemed much better to integrate with your application's theming. So we have so many different integrations. And actually, you can run the same Collabra Online server against your Moodle and your Nextcloud and your PyDO, your C-file, and your, like all of these can share the same one. So much better, instead of theming the thing, to push all of that through with a whole load of CSS variables. So you post into the iframe, and you have all of these variables. And so then it's relatively easy to just make it look different and fit in with, and of course, it seems silly, but often the color scheme and the icons and so on are the icing on the cake that makes people, just happy, disproportionately happy. So let's do that. And so here are some examples. This is, I guess, just embedded in Nextcloud beforehand, and you can see this kind of some of this gray stuff, the sidebar being there, the ruler being around, and so on. And then, with a little bit of tweaking, we have something that, well, it shares blue highlights with the surround. The ruler was, so just looking better, looking more like an integrated part of the product. So I'm sorry, I talk very quickly. Hopefully it's all written on the page as well, so you can read. But how do we secure and scale that? I think these are good questions. And actually, part of the security and scaling is a similar thing. So we pre-initialize loads of stuff. So we load LibreOffice, we load all your dictionaries, your to a degree some of your fonts, and the configuration and all of the things that make starting a single copy of LibreOffice relatively slow. So that is all paid upfront. And then we fork. So we have KDE init has a similar scheme where it it loads of stuff for Qt and KDE, and then it's copy on write shared between lots of applications. So your application is a DLL. Well, of course, we are just one application. So we essentially pre-initialize, and then we fork, and we chroot, and we then lock down this thing pretty viciously. So inside the chroot, we have no shell. We have very few libraries. There's a few things that NSS needs from system. We have fonts. I think we're trying to get rid of those fonts, but yeah, that's pretty much it. Actually, one document, just your document. So each document in a separate chroot. The code, there's no code you can really execute inside that. We have seccomp BPF around that, so all your system calls are going through a Berkeley packet filter to make sure you can't call the dodgy ones, the ones that have had historic problems in the Linux kernel in terms of, well, complexity and managing security. And of course, underneath that, LibreOffice has amazing load crash testing, 100,000 documents we load and save every week or so, and make sure that we're not crashing. We have an industry better K-Verity score than the Linux kernel. So, there's a huge amount of work there. The fuzzing stuff, the OSS fuzz work we do with Google is amazing, and Red Hat have done some fantastic things on LibreOffice there. I want to give a call out to Quaylon's great work there. So there are whole layers and layers and layers of this onion. And so far, we're not aware of any of them being, well, any combination of these causing serious problems. So that's very secure. And so then that lets us share lots of memory. And so then it's just really a CPU problem. So here's a 45,000 real world deployment. Typically, it uses less hardware than their enterprise file sync and share and the giant clustered databases and object stores. Once you start storing lots of data, you really need some serious hardware, but you really don't to host Collabra Online. So that's kind of cool. So what's new? Cool and new stuff, just to kind of wrap up, and then I'll take questions. So we have 6.4.0 recently, and I mentioned your choice of different UIs. So you can have a more, I guess, familiar to Microsoft UI now, or you can just have more familiar to Google users menu and toolbar as you'd expect, and you can choose that at runtime, and actually per user, I think, now. So if you want to provide ridiculous amounts of options to your users, that's all good. So freeze rows, we got in there, which was kind of vital in Calc, really, for more useful stuff. PDF searching, collaboration, commenting on PDF, so you can share your document as a PDF with people who then can't mangle your document, but they can comment on it and collaborate around it. And they can even watermark that, so you can be sure they can't copy paste out of it, but they can comment on it. So we see this used in big enterprises. Give it to your sales team, give your new product ideas to the sales team to get feedback, because you really need feedback from your customers, but you really don't want the customers to be getting those documents. That's kind of really important. And so you can provide a tool then that keeps all of those documents really secure on your premise. And if they leak, they've got someone's name all over it, and it can't be copy and pasted outside. We improved chart functionality, lots of calc things, nicer sheet movement, pivot tables. So we could always calculate them, obviously, but the dialogues to create and customize those are in 6.4. Managing ranges, names, statistical tools. These are some awesome features. You're just not going to see these in any other online Office suite. Certainly built in. For Asia. So this is FOSSASIA. So we have a big request from Taiwan, actually, and we love to work in Taiwan for gutter margins. So you can print things out. It turns out that pagination and printing is still really important. So those binders have got to go into something, and preferably not your text. So isn't it nice to push the margins out as you print pages? What else? Draw. Apologies. So getting draw to online. So font work is a key piece of that, and you can see it there on the with nice gallery and the sidebars for the shapes and working on your mobile phone. I guess this is good for kids' parties. To be fair, I don't use it a lot in business, but it's pretty nice. And then a whole load of stuff you can't see. So faster rendering, more interactive editing of cells. Instead of copying or hard linking CH roots, bind mounting them so that we can do that very much more quickly. Better watermark caching, all sorts of things. Performance improvements across the board, really. Multi-document support on iOS so that we can, instead of just rendering one document, I mentioned it was one document per CH root. Well, we need to tweak that slightly to make this work better for multi-document mobile phone applications. Lots of automated tests, a great way to get involved, actually just using Cypress, so you can drive the UI and make sure that things continue to work more than I can tell you in 30 seconds. So yeah, lots going on there. And what's next? Well, there's another version next week that brings, well, maybe next week. We're still fixing and improving it. We'd love to have your help testing and doing that. Bringing draw to online, so connectors and glue points and shapes, and doing good things there. Crisper rendering. So so previously we wanted to work without the canvas on older browsers, but we're now going for a full canvas rendering experience, and that allows us to just be much crisper and quicker, and just doing nice stuff and rewriting in TypeScript. So it's much easier to maintain and read and understand and actually encapsulate data. I mean, JavaScript is probably the world's most terrible language. So we can improve. We can improve by actually using something slightly more rigorous, which is good. And get lots of more things out of that. Here's a horror. Of course, this is hard disabled by default, but having the ability to run your VBA and star basic macros, there are all sorts of people writing little form filling, tools and database front ends and so on, and Visual Basic, often built on top of spreadsheets or forms. Now, wouldn't it be great if you could bring them into the cloud, bring them to all sorts of different device form factors and so on. Of course, the APIs are completely obsolete for this, but we can at least run those things. Really, probably better to have a single user because they're not really collaborative. Not really ready for collaboration. But so this is coming shortly, and you should be able to play with that, which is kind of nice. We'd love you to join us. So our mission at Collabra is to make open source rock. Well, okay, it's a bit longer than that. Open source methodology is succeeding and so on. But we'd love you to join us, get involved. Oh, this slide has been horribly mangled, but there's basically two sides. There's obviously LibreOffice core features, and that's vital. The technology we build on is something like 98% of our code, and we love LibreOffice. So get involved with that. There are easy hacks and things to do, but also Collabra Online then sits on top of that, and we got something for everyone. There's C++, there's JavaScript, there's CSS, there's all sorts of design bits and artwork to be done. We have weekly meetings. You can get involved, meet the development team, talk to us. We'd love to work with you. I think that's it. So that was my talk. Thank you for your patience and not heckling. And now I've got some questions. Maybe there's some here. Well, look at all this encouragement. That's great. Thank you for interacting. Well, is he a GNOME hacker? Yes. So yes, at heart. And occasionally I consider about how I can fix the the GTK next integration, like GTK4, GTK changes. Well, it seems slow to you maybe every 3 years, but from the perspective of a very large code base, it's quite quick. So we need to do some work there. I don't have as much time as I'd like for GNOME because I have to run a company and try and make it fun for my my hackers and community and build a great product and delight our customers, which takes some doing. So anyway, questions? Any questions? Mario, are you a question?
Yes. So, thank you very much for this. Really active presentation. So I see a lot of good comments here on the chat, and there's already one person saying they really want to see your GitHub profile. They think you're a fantastic developer already, like the way you give.
I heard about that. I have an amazing team. If you look at the people around LibreOffice, there are just some extraordinary people there that have contributed so much, and volunteers doing just exceptional work around the project. And of course, donors too. I mean, we get something like €1 million a year from donations of people who just love the project and want to contribute to it. So that's fantastic. A document foundation. So really, it's not
fantastic. And I have a question here. Is Michael a GNOME hacker? Are you?
Yes, I sort of semi-answered that. And yes, in soul, if not in actuality, so much recently. But yes. No, I think I'm actually quite famous in the GNOME community as someone who was elected to the GNOME board maybe 3 times and actually failed to be there because of the conflict of interest thing. Like I was at Xinian and there were so many Xinian people being elected to the board that I was always the least popular of the, I don't know. So yes, that's my claim to fame, not being elected many times there. So, okay, great. Yeah.
And then there is a user focused question here. Is there a free end user service or do I have to self-host it?
Yeah, so that's a good question. I mean, if we had a, well, I won't speculate as to how these free services are hosted and funded on the other side, but certainly there is a lack of interest in our world in creating somewhere where you surrender your documents to someone else, particularly a large centralized player. And also, there's kind of a business model around that. We don't have a search engine. We don't have other cross-subsidizing opportunities here. And the margins are relatively thin in free software. So we provide a great product at an extraordinary price. So it's difficult to see how we would do that, but some people do. So there are, if you want to get a free hosted version, so One-on-One, which runs mail.com and gmx.de and various things, they host, Collabra Online effectively to the order of millions of users. There are there's telcos around the world that will provide you with a service as part of your support contract. We've gone to with our partners that again have millions of users there. So you can find a service like that if you want to sign up, and we have a whole load of cool hosting partners that you can go and check out on our website, and they love your business, no doubt. But we as Collabra, we're a very clearly focused software services company, and we don't provide that. And there are huge advantages to hosting this yourself, and federating. We've seen, the OwnCloud, NextCloud, Party can federate their servers, so you can talk with other people, and you can collaborate and scale out and control your data, and still not sacrifice usability in that larger user pool. And we think that's really, really important for digital sovereignty. So please do set up your own, or buy a NAS box with it on, or buy there are lots of ways to get Collabra Online.
Mm-hmm. Okay, nice. And so then yeah, because I was also wondering, how is it in regards to the resource usage, if people set it up themselves, and how does it compare technology-wise? Of course, I've tested it, but it would be great if you can share a bit. And I know that, for example, in Nextcloud, there's also the option to use your server from Collabra for test services. So, so if people want to get started and try it out, how would that compare?
Yeah, absolutely. So obviously, you know, if you're going to use our test server, that's cool. You know, we put it for there so people can get excited about it. But there is a big warning. In order to do that, you need to send us your documents. And honestly, we love your document. You know, we prefer you to keep your documents. We don't want any personally identifying information in there. We don't want GDPR problems, whatever. So we're kind of nervous a little bit about that. We don't want to be running and hosting a service. It's just for demos. The other problem is, of course, that your machine has to be routable from the internet for us to connect back to you to get that data. And that's something that's not true of everyone. Lots of people want to just have something at home, you know, on my local LAN or my, you know, or behind the giant firewalls that exist in Asia. You know, it's going to be hard for us to be getting in and getting out to get your, you know, behind 2 levels of NAT or whatever. So I think generally, so that's one option, the public demo server. Second option is to download an app image. So we've packaged Collabra Online as an app image, and we can run that. It's kind of a horrible hack. I mean, so we really wanted a one-click install. It was easy. So you do your one-click, and it downloads this now actually only 200 megabytes app image. It runs that locally on your host, your server, and then we have a piece of PHP that will connect and proxy keyboard requests through to that, and that's what's built into a Nextcloud Hub. It's very easy to set up. There are, of course, some performance issues of proxying every request and sticking them through, you know, Apache and then PHP and then to us and then back again. But it works surprisingly well. So yeah, really it's best to grab some packages for any distro, your Docker image, build it yourself, whatever you like, and deploy it, you know, as a properly hosted instance. And there's documentation on how to do that and how to make that work nicely, again, on the SDK side.
Okay, cool. And then there is another question. How is it with document signing? Can the solution, like, can it do document signing?
So, well, of course, LibreOffice Core has amazing crypto built into it. You know, I occasionally get emails going, "Oh, I forgot my, you know, password. Can we recover the document?" You're like, no, you know, that's exactly what you can't do. You know, that's the whole point. And of course, we have amazing signing built into that. We have an integration, or we had an integration with a company called Farine, which has a blockchain. I forget how they call it, but basically a blockchain signing wonder solution. So we could do it with that at a certain point. I haven't tried that recently. And there's loads of functionality built in. It would be relatively easy to build a document signing UI in there, but so far that's not something our partners, customers have demanded of us. If you want to do it, get involved. Or it would be great to see you, and we'd love to have the feature.
Excellent. So I really like your hint to the weekly meetings that you have. Are these open for newbies? Can people just drop in to learn a bit? Yeah.
Definitely. So we have a community roundup that we publish every week that says all of the cool things and calls out everyone, credits the work that everyone has done, no matter how big or small. We have then a community meeting that's just a Jitsi room. You know, turn up, get involved, say hi. You know, I mean, it's not really for users to ask for features. That's you know, it's for people who want to ask for how can I implement the feature. So it's really for developers or designers or, you know, translators. Anyone that wants to get involved there is more than welcome. And we'd love to talk to you. And yeah, so there's a public details for that, and public minutes of the meetings as well, if you just want to read those. So yeah, do get involved. That'd be cool.
Excellent. So yeah, I think like you left some, actually a lot of pointers in your presentation, and we'll be sharing that. We'll be sharing the video. So thank you very much for this presentation, Michael. It's been a pleasure as always. And yeah,
good to see you again.
Yes.
I'm glad I could come to Asia this year. That's amazing. I could justify the travel. It was fantastic. So, yeah.
Okay, so we stay connected, and I hope like we see a lot of contributors to Collabra Office and to LibreOffice.
Thank you so much. I'll be in the discussion room if you want to chat. I'll head there now. Thanks, everyone.
Thank you very much. Okay, so we are now getting to the next session in a moment. So we have a few minutes before we start that session with Konrad Bechler. Konrad, are you already here in the meeting? Please indicate. I need to give you access here with your camera and so on. Yes, I see you, Konrad. You need to switch on your... to switch on the camera. Cam and maybe. Okay. Excellent.
Hello, everybody. This is Konrad from Diva.
Okay, excellent, Konrad. Great to see how that it's working. And yeah, so we'll be starting in a moment. I think you will be sharing a video. Is that correct?
That's correct. Yeah, I pre-recorded my session because just to, you know, get used to it. And thank you very much to FOSSASIA to give us the chance here to present this rather new project. And I liked very much the presentation of Michael, by the way, a really good and really interesting presentation. Awesome stuff.
Yeah. So, Konrad, where are you at the moment, by the way?
We're based in Switzerland. We're living in Switzerland, so we're in Zug, which is central Switzerland, so mountains around us and stuff. And here we do the development, the software development, and here we are the very small, very small open source team. By the way, we only do open source software, so there is no commercial unit or alike. We're a pure open source team.
Excellent. You're already getting into the topic, but
Right.
I would like you to add the video already. So there's a plus icon, right, where you can add your video, and then I will just like share some quick like some information about you, and we start the session. Yes, excellent. So just pause it.
I did that.
Yeah. Okay, excellent. So yeah. Moment. Okay. So yeah, let us start officially this session with Konrad Bechler, CTO of Diva.exchange. And yeah, about Konrad, around 85, Konrad started as a very young developer using assembler, concentrating on game development. The studies of economics and econometrics at the University of Zurich helped him creating very early high-frequency trading boards back in the 90s already. In 2003, he co-founded a media tech company and created a cloud-based solution to distribute financial news to wire services and investors all over the world. After they reached market leadership, Konrad and his partners sold the company to a larger corporate. Konrad decided to dedicate all his time and knowledge to the development of AGPL version 3 plus software. The project is called DVA.exchange, and its mission is to develop free banking technology for everyone. In a nutshell, Diva is an I2P-based, highly energy efficient and truly distributed solution, enabling everyone to be its very own bank. The non-profit association Diva.exchange is closely cooperating with academia. Next to research projects start in QA 2021, so around now, and all works are licensed under the AGPL version 3 or compatible. So it's a pleasure to welcome you, Konrad, here at the FOSSASIA Virtual Summit, and we are looking forward to the video you're going to share and to the Q&A. Thank you very much. Over to you.
Thank you, Mario. Great stuff. Thank you. So I'm going to start the video now, and I'm going to be quiet. Afterwards, I'm going to be ready for any Q&A. Hello and welcome. My name is Konrad. I'm one of the co-founding members of the non-profit association Diva.exchange. I'm responsible for the technology. Thank you very much to the FOSSASIA 21 team to give us a chance here to talk. This is very kind of you. And in this talk, we're going to take a closer technical look at Diva. Diva is the software package which is licensed under AGPL version 3. And this is what we're producing at the non-profit association Diva.exchange. We already had a chance this year to talk at FOSDEM, but there it was rather an introductory talk. So if you'd like to get an introduction, please take a look at this video. In this talk, according to the feedback of the community we got, we'd like to take rather a technical path. So we're taking a closer look at how to install Diva, how to set up its containers, and to make it run on your local device. This is all about how to become your local I2P based, fully distributed bank, because this is what Diva is all about. It's distributed banking technology for everyone. I suggest that we take a look at the agenda now, and then let's get started. At the association Diva.exchange, we saw that users miss an elegant and secure solution to trade and store their digital values, like cryptocurrencies. They want to enjoy full privacy protection, they want to enjoy independence and self-determination. So we created the free and open source software package called Diva. And as I said, it's open, it's free, and it's fully distributed, and it protects the privacy of the end users. So it's banking technology for everyone. And that's what we're developing at the non-profit organization or association Diva.exchange. The association Diva.exchange, by the way, is open to everyone. So if you want to participate, you can do that. Please just join over our website. We're working on technology solutions, that's what I said. The technology is peer-to-peer, and we also cooperate with universities currently in Switzerland. So we want to be scientific, agnostic, and we're 100% free and open source software. The users of Diva, so of the software, they usually want the following. They want to allocate their digital values in an entirely self-determined manner. They want to have exclusive control over their data and values, and they want to earn digital values as fees by participating in the network or being part of the infrastructure. We're striving to create user and environment-friendly applications at Diva.exchange. Now, the application stack, which consists of I2P, the blockchain layer, which is the distributed storage, the backend and the front end, is our next topic. Let me show you here a few slides so that we get into it. The application stack of Diva consists of several layers. The network layer is based on I2P, and I2P is privacy by design. That's a peer-to-peer network, and the messages travel over multiple nodes, taking different routes inbound to a recipient and outbound back to the sender. It's end-to-end encrypted, and the Gallic messaging protects both the identity of the sender and recipient and also the message content. Faulty remote network nodes cannot put privacy or anonymity of another node at risk. There is no dependency to central infrastructure, and I2P, which is coming in two different flavors, Java or C++, is long-standing and a very proven open source project. At Diva.exchange, we do support the research, currently together with the University of Lucerne, researching I2P, its stability, its scalability, etc. The next layer is the storage layer. It has to be fully distributed, so it's a blockchain. We're using Hyperledger Iroha currently, which is a very lightweight and performance-oriented distributed storage. The consensus is simple and leads to energy efficiency, which is very important to us. But we're very open for a pluggable blockchain storage engine and also a pluggable consensus protocol implementation. Currently, there is also research running on the storage layer by two students, and we're working there together with the Zurich University of Applied Science in Switzerland. Then there is the application itself, so the Diva application, which consists of a backend and a front end. The repository is found at codeberg.org/diva.exchange/diva. It's a Node.js application. We do have minimal dependencies and we're very lightweight. Yes, we're striving for elegant and modern code. That's what we're doing. And now in these weeks and days, we're working on the trading engine implementation for multiple digital values and cryptocurrencies. If you'd like to jump in and help out with the community and with Diva.exchange and with Diva, you're very much welcome. We're an entry-level, friendly project, so just get in touch with me.
As you can see on the agenda, now it's time to get started with the installation. We're going to install Diva on your local environment. We're doing this on Linux. We're using Docker containers, so if you're familiar with Docker, that's Pro, because of the current status of Diva, of the Diva application, enables us or allows us to install it within Docker containers. So we're going to pull up the whole environment which consists of several layers like I2P, the blockchain layer, the backend and the front end, within several independent containers. This is what we're calling Diva Dockerized within our repositories. Now let's get started and I'll guide you through step by step, and at the end we're going to have a running local installation of your own bank on your own device.
And now it's time to install Diva locally. There are two possibilities to do that. A, as a local 7-node network without I2P. By the way, it could also be 11 nodes or 3 nodes, but these 7 nodes are just the example we're going to use here. And B, by joining the existing Diva network using I2P. That's the other possibility. We're going to use here a Linux console, so you're going to also need some Docker skills and some Node.js skills. At the end, a Node.js application will run locally and give you the functionality of Diva. Now, first of all, we need access to the code, which is here located in the code repository. So it's on codeberg.org/diva.exchange/diva. Here we are on the develop branch. Now, if you scroll down, you're going to see the README, and within the README, there you also find the instructions on how to get started, so how to do your local installation. First of all, we will do the 7-node local installation, and as described here in the README, you need to have Docker and Docker Compose available on your system. So that's all described here. And then it's really quite simple. You just, after you have access to the code, which is usually a clone, you just execute the installation script within your shell, and you can do this as a regular user, but the script itself then will need super user access. So it's going to ask you for your super user password because Docker requires a privileged access. All right, we're here now in the Linux terminal in the bash, and we have cloned the source code from codeberg.org/diva.exchange/diva. Let's take a look at the folder structure here. Yes, this is the code from the code repository, and as it said in the README, we're going to start the install script. If necessary, it's going to ask you for the privileged user password, so the root user, because Docker needs access to it. What's happening right now is it's pulling all the necessary images from the Docker Hub, cleaning up your environment to have a proper start, and then it starts the database containers and the iRoha containers and the Explorer and the API, and as soon as this is done, it's installing the Node.js application and the local SQLite database. And as soon as this is done, like right now, it's waiting for the API, so that's one of the Docker containers, to become ready. And as soon as the API is there, it's executing the installer itself, and ta-da! The whole Diva application, including 7 nodes, is now available. Let's take a closer look here quickly, using Docker, whether all containers are running. And yes, we're seeing that here 7 nodes are properly running since about 40 seconds. The API is there and the Explorer is there. So that's a great start. So now back to the Codeberg code repository for a moment. So if we're back here on the Codeberg repository, we see that here within the README it's also shown that these containers should be running, and that's what we just checked in a terminal just before because we executed install. And this install has created local Iroha blockchain nodes. So these 7 nodes, which are now our distributed local storage, it's only local. So we're not connected to the I2P testnet of Diva yet. And I suggest that in the beginning, it's always kind of before we start the Diva application, it's useful to take a look whether the blockchain is properly running. And if you wait a few minutes, then, and I already started it here and on this tab, that the blocks are created because the API is writing blocks from time to time, every minute, more or less. If you're clicking on one of those blocks, you see the detailed data, the JSON data, which is forming this block. All right, back to Codeberg, and as you see here in the README, we should execute bin start, and that's exactly what we're going to do. This bin start is now starting the Diva application. So back to the terminal, back to the bash, let's execute bin start. And what's happening now is, all right, it's pulling those Docker images again, which are needed for the database layer and for the blockchain. And now it's starting the Node.js application. And it tries to fetch from the running API the token to get access to the local web application. And then, as you can see, an HTTP server is listening, a WebSocket server is listening, and an API is and the connection to the API has established. Back to Codeberg, to the README, because the README says that we should have now this here available. So open this in a new tab and let's see whether Diva is here. So yes, Diva is here, and let me switch here the language to English. This is a pure demo application, but it's fully functional, so we can like add here some order book data. Let's buy 10 at 100. This is just, as I said, a local order book. And what's happening now, you're placing an order on the market. In this example here, it's a buy order, and you also can place your own sell orders. Let's sell 20 for 200. And as you can see, by the way, that's what just saw. We have here a bug in the user interface. It's all alpha, but the data is written to the blockchain. So what we're going to see here are now the order book data of BTC XMR on the blockchain. So this is all properly working, and fact is we do have a running Diva application, and yes, we need lots of support and time also to finalize this exchange and this banking application, and you're very welcome to join us. Did I already say that? Yes, I did properly. All right, okay, let's wrap it up. Let's go back to Codeberg. We have running Docker containers which form the blockchain layer, which do contain Iroha. Then we do have started using bin start the Node.js application, and the result is on localhost a Diva application which is based on the local blockchain network.
Okay, that was the installation. Now you have a running own bank on your local device. As you can see back on the agenda, we'd like to talk shortly about the community, so how to get involved as a developer, as a designer, or help us communicate in several languages, or help us to document and to test. As you know, we closely cooperate with universities and schools, currently in Switzerland, and we're an open association to everyone. So if you'd like to do some research based on Diva, wherever you're located as a university or a school, just contact us, get in contact with Carolyn of Diva.exchange and set up a scientific partnership. We're very much interested in having a very scientific and agnostic look at the project Diva. As you know, everything what we're doing is HEPL version 3, licensed or compatible. So all the work is public, all the work is open source. And so is the research work. Additionally, we do have code repositories, which are mainly on codeberg.org/diva.exchange, and they're married to GitLab and to GitHub. And by the way, if you like to get involved as a community manager, we're always looking at some way to manage our issues and to look at our issues on the code repository platform. So just get in touch with me. Please use our Telegram chat or send me an email. Use the website diva.exchange to find our contact details. We believe at the association Diva.exchange we're very entry-level friendly, and we're a very open and diverse community. So you as a developer, as a designer, as a front-end designer, you're very, very welcome to just join in. Join us in the chat, get in touch with us, talk about your vision of Diva and what you like to do with it, and I'm sure we're going to have a very constructive and interesting talk. Now, thank you very much for listening to this presentation, and I'm very curious about all your questions and your open feedback. Everything you tell us we can learn from and we can improve at Diva.exchange. We can make the software better, we can make our communication better. So you're very, very much invited to ask all your questions you have in mind, and therefore we now continue with Q&A. Thank you for your time. Thank you for your support of open source software, especially HEPL version 3 projects, and do not hesitate to donate to Diva.exchange. All right, see you in the Q&A. Thank you.
All right, so thank you for your time. Thank you very much for your time and for your patience to listen to this video. That's great. I saw here some questions in the chat. One of the questions was, hello, Mario.
Yes, and I think, thank you very much, Konrad. That's a really nice explanation, especially with the technology angle. And we have a question here from Roland, and Roland said he can also ask this question directly by voice. Roland, please switch on your microphone and yeah, go ahead with your question.
Hey, Konrad.
Hello, Roland.
My question might be pitched at the wrong level, because I'm interested in understanding the network perhaps more than the software that you're talking about, and perhaps it's so. Please accept that qualifier.
Sure. All good.
I'm interested to understand sort of I2P versus Bitcoin, and in particular whether there are the same risks of capital centralization and political centralization that Bitcoin appears to suffer.
Right. We're not a coin. Diva is not a coin, and we're totally agnostic, whether it's Bitcoin, Monero, Ethereum, whatever. We're just an exchange. So we use the I2P network, and the I2P network is commonly known as Darknet, but that's a very ugly name. At the end, it's a peer-to-peer network which protects every node's privacy.
So you're not replacing the coins, you're replacing the exchanges, the centralized exchanges.
Yes, we're replacing the centralized exchanges. We're a fully distributed exchange. So you, Roland, you can be an exchange, I can be an exchange, and we don't know each other. And what Diva is enabling is the completely trustless swap without any central instance to swap any digital value. And since Bitcoin and Monero, just as an example, are well established and well known, we're going to experiment on an academic level with those two cryptocurrencies, but that's all what we're doing. Could I answer your question, Roland?
You have answered it thoroughly, yes. That's I now get which layer of the stack I2P is as well, so that's really cool. Thank you.
Thank you very much.
Excellent. And yeah, we have another question here from Amit Vikram Pujar. For what kind of proprietary software does Diva try to provide an open source alternative?
A very interesting question, and thank you very much for that, Amit Vikram. We're at Diva, we do not replace anything because we give the software away to the users because we're HGPL version 3 licensed. So we give the software completely away. It's all yours. And those people who will install it, they will become an exchange. But we at Diva, we are no central service or so. We also do not earn any money, so there is no business model. But the best thing to see us is we're producing the software to replace the central exchanges. That's what we're doing. That's our mission.
Like for people who are not so familiar with exchange and so on, like maybe you could explain like what are examples of exchanges that people could use, where people could use Diva instead of other exchanges.
Right. There are very simple exchange. For example, every payment you do for something, like you pay a song from an artist, that's an exchange. You get a digital stream of audio, so a song, and you pay with some currency. And let's assume in the future this will be some digital cash. Now you already do an exchange. And now either you do this exchange of good versus some payment over a central exchange, like any proprietary central exchange, like the Apple Store or whatever. This is already an exchange, but you could also use it to exchange cryptocurrencies or other digital assets. But usually an exchange is already a payment. So that's a very basic function of an exchange. Did this help?
Definitely. Thank you very much. It's a bit of a follow-up question then, but an exchange is could it be regarded or even be expanded with a marketplace? Or could it be integrated in a marketplace? Could it be an alternative, for example, to some features that PayPal is providing these days? What do you say?
The short answer is yes. The long answer is we need a lot of work to get there.
Okay, great. So we heard a lot of projects have regular meetups and where people can get, for example, some more information or where they can just hang out a bit and learn something. You shared code repositories here and some entry points. Do you also have regular meetups where people can join, for example, online?
We do have a Telegram chat. You find it on the Diva website under contacts, and in the Telegram chat we are very active. Currently we do not have any weekly or bi-weekly community meetings yet. We plan that, but we're a bit short of resources because we need to write service code.
Yeah, but we heard from you, you're looking for community managers or community contributors. So it's not just about code, it's about bringing people together. So I think, yeah, we definitely have open ears here in the community, and we'll share this information with you. Maybe there are people here who are listening interested. So thank you very much, Konrad. It's been a pleasure, and hope to stay connected. And thank you very much, especially for all the work with your video. It was really impressive what you've done here. And yeah, we'll definitely share this also on our different channels. So have a good day, and thank you.
Thank you. The video was done all open source. So open source rocks. Thank you.
Awesome. Thank you. Good. And so we're continuing in a moment with a workshop here. Yeah, the name of the workshop is Simple Data Viz with PS Lab. PS Lab standing for Pocket Science Lab, and the workshop continues as Universal Pocket Knife Workshop. So I'm curious to see this workshop, which is run by Daniel Wesolek and Sarah Reichert from Berlin. Daniel and Sarah, are you here already? Could you please indicate that you are here, and then we will give you access. Daniel already has access, and I also see Sarah here. Okay, perfect. I promote you so you have more access rights here, and Daniel, I still have to find you here. Okay, excellent. So you have all the rights, and yeah, we'll be starting in a moment. Yeah, open next and prototypes. We already heard about it here today. You also have the logos there, Daniel. Very nice. And Sarah, like very happy. It's the sun shining there today, yeah? Okay, excellent. So please switch on your microphone so we can test and hear if things are working.
Yes, hello. The sun is shining. Hi.
Okay, awesome. So yeah, I will switch on the recording, and basically then we are good to go. Let me introduce you quickly here in the workshop, Simple Data Viz with PS Lab Universal Pocket Knife Workshop. The workshop is run by two people here from Berlin. Firstly, we have Sarah Reichert. She's a research associate at the Technologiestiftung Berlin. Sarah is an electrical engineer for communication systems, graduated from Technical University Berlin. She is working at the interface of digitization and urban development. Her focus is the transfer of knowledge between science and civil society. Currently, she is head of Werkstatt, a city lab Berlin that is run by Technologiestiftung Berlin. Previously, she led the project Coding Klassenfahrt, Coding Class Trips, and spent 5 years at the Technical University of Berlin, DEIN Laboratory, where she helped motivate young students to start a career in computer science or electrical engineering. She has also worked with various artists in museums and galleries in both Berlin and Sao Paulo on interdisciplinary installations that bridge the worlds of art and science. Welcome, Sarah, and thank you very much for giving this workshop. And then we have here Dr. Daniel Wesolek. Daniel is an open hardware advocate from We Are Open. Dr. Daniel Wesolek is a tangible interaction designer and open source hardware advocate based in Berlin. Previously, he has been a postdoctoral research fellow at Singapore University for Technology and Design, SUTD. And here we have a clear connection between Singapore and Berlin, which makes me very happy personally as well. In 2016, Daniel defended his PhD in art and design on simple displays at Bauhaus University, Weimar, where he also worked as a research associate in interaction design. He holds an MFA in media and art design from Bauhaus University, Weimar, and an MA in art theory from Tongji University, Shanghai, and a BA in digital media from University of the Arts in Bremen. So Daniel, that's a lot of degrees, but I see also a lot of connections between Europe and Asia. So this is perfect here to welcome you at the FOSSASIA event. And of course, it's very nice that you will do this session together with Sarah. So I will hand over you and let you do this workshop. Everyone, please enjoy this workshop and virtually welcome Sarah and Daniel. Thank you very much for joining us.
Thank you, Mario. That's great.
Thank you, Mario.
Yeah, so we switched a little bit from presentation mode to hands-on mode. So this will be 3 hours. So everyone can get into hands-on mode basically. Sarah.
Hi, I just wanted to thank Mario for the nice introduction. It was very kind of him to introduce us. Yeah, hi. Very nice to see you all here. I'm very nervous and very happy to be here. Usually I'm more the hardware type, and today lots of software is involved, so that's why I'm very nervous. And I hope everything will be fine.
I think it will be all fine. Let's switch slides. I don't know, like we're wondering beforehand already, like who might be in this workshop and actually has a physical pocket science lab at hand, because today we want to bring people together to tinker with the pocket science lab, and we want to do it in an unusual way somehow, because as you might know, Pocket Science Lab already, I'm sharing the website here already. There's like lots of good ways to use the Pocket Science Lab, and there's also like ways to have an Android app and have like a desktop app and so on. But today and here we're basically focusing on using the PS Lab to capture sensor input, forward it to PS Lab Python from PS Lab Python through OSC to processing. And there we want to create visuals, basically. There might be some questions occurring, we thought beforehand. What is the PS Lab? Many of you might know, some might not. What is PS Lab Python? The lead developer of PS Lab Python is in this session as well, I think. So maybe if there are special questions, Alexander can jump in. What is open sound control? Like Sarah discovered open sound control through preparation to the session and was stunned by the possibilities. Very common in an art context, but not so common in an engineering context, I think. What's processing? And who are you guys? Sarah and Daniel, that's a question, but maybe this was answered a bit already from the great introduction that Mario did.
Yeah, lots of introduction from Mario. I don't know what to say more, maybe something about my current position at Technologiestiftung Berlin, where I run a little workshop each month, and I really like to work with people that don't know nothing about hardware or software, because the best inventions come out of this kind of workshops, I think. Next.
Yeah, I'm Daniel. I like open hardware. I'm a tangible interaction designer. We are working together with Open Tech in a project that's called Open Next. So EU-funded project, and that's also like a bit of the context for the Pocket Science Lab at the moment for me. But yeah, like through having been in Singapore for quite a bit and so on, I know FOSSASIA from there, and I'm kind of sad actually that that we're not all in Singapore right now, because I would really like to be there and enjoy the good food and so on. Would be really nice. Yeah. What's the Pocket Science Lab? You should check out the website, definitely. And it's a multitude of things. It's basically a lab that you can carry around in your pocket and connect to a phone. That's probably the easiest thing, to connect it to an Android app. And then it can function as an oscilloscope, as a multimeter, as a wave generator, a logic analyzer, a power source for small currents, and all kinds of things. And here are some specs for technical people. You can find them also on the website. So 4 channels, oscilloscope, and the voltmeter is like 12-bit, and the programmable voltage sources also have like plus and minus 3.3 volts, so you can go in both directions. Yeah, current source, not too powerful, but I think this will change with one of the following versions. And there's a lot of like sensors and things that you can connect right away, so you don't have to like flash the firmware like on other boards beforehand and have these different points of problems that can occur, but you have a firmware on the Pocket Science Lab already, and then they're like you can focus on the other part in order to visualize your data if that's your goal. Yeah, logic analyzer, sine wave generator, WN generator. So there's also like questions of how can one use the Pocket Science Lab in unusual ways. So we're also looking into making music with the Pocket Science Lab and so on. So it's like a little bit like, I don't know, taking the PS Lab out of its original context and exploring other ways that one can use it. So yeah, and it's really nice. Like for example, like if you want to connect the resistor, as we will see in a minute, you just plug it in there and no need to build like a, I don't know, some voltage dividing circuit or something. Like just plug it in and you can use it. Yeah, this is like interactive question. Sarah.
Yes, today we need some Python, and so we want to ask who of you already has a running Python environment? If you have a Python environment that is really running and fresh and happy, then please, it would be nice if you could make a little dot in the chat so we can see if there are some people with Python running. Oh, there's one dot. Yes, happy. Great. Some people with Python, great. Installing now, super. Yes, there's time to install it. I just wanted to see how many people need time to install it. Jawohl. Right.
I'm also curious if there are many of you that have the board actually in their hands. I don't know what's a good code for maybe plus or something. If you have a PS Lab that you can use right now, maybe put a plus in the chat. We will be coding locally, not online, basically, in this workshop. But I think it's still fun to stay in the workshop, even if you don't have access to the board right now.
Yes, for people that have never heard of Python or programming, I would like to recommend Anaconda to install because it's, I think, for beginners a very good start and nice environment to start with it. And I think, yeah, I use Visual Studio Code and Jupyter Notebook. That's for me very convenient. And Daniel, what are you using?
I I don't know. I'm kind of I've been doing like, I don't know, art programming stuff since quite a while, and like multimedia stuff and so on. So I'm kind of like just using the terminal and fiddling through the Python thing. I learned Java originally, but yeah, I think it's nicer to have like a proper environment. And I also installed like on Atom, there's like some plugin that what has like some code highlighting and way to run the scripts directly. This seems to work okay for me.
Yeah, nice. Yes, there are lots of opportunities to use Python. I think, yeah, for me, Visual Studio Code is very convenient because I do a lot of Arduino coding too, and I can use a lot of things in there. But I really like to use like Anaconda and Spider a lot. That's very simple too. Yes, and just to use the terminal is, of course, it's convenient and okay, but sometimes a bit hard for your mind to see the little words there. Okay. This is, yeah, Genie and Jupyter Notebooks. Yeah, Jupyter Notebooks, I like them a lot. Yeah, I don't know, it's very convenient. Yes, I think so. Why do we need Python today? Because to talk to our hardware today, it's very convenient to have Python. We will send from Python to processing and visualize our data there. If some of you don't or can't make run the Python environment, sometimes that happens. Sometimes there's like it's complicated with machines, like with people, you know. Then don't worry. I think it's still interesting because yeah, for me it was really nice to see what is possible with processing. In my university, I just learned a lot of MATLAB, and yes, I was very stunned about the opportunities with processing because it's very easy and powerful. Okay, there we have some more things in the chat. Versions, okay. The next step for the people that have Python, they need a package, and it's PSLab Python. Daniel, maybe you can tell something about PSLab Python. What is this actually?
From my understanding, in Noob's words, basically, PSLab Python is like the main component that connects the PSLab with its firmware to the desktop app that's also running on the computer, and you can use that as a graphical user interface to, for example, visualize your oscilloscope data. But you can also use PSLab Python directly, and Alexander made a lot of progress recently and refactored some of the code and like some things in a way that it's even easier to understand. And this is what we'll be using. So if you have used PSLab Python in the past, I recommend you check out the blog with a check mark, because Alexander was like, did a lot of like explanation of what he changed and so on. So this will help you. And there's already like a new version 2.1 now, and you can install it with pip. If you have like both PyPy and Python versions, like then you use like pip3 basically to install that. And I think we have it on the next slide also. No, the next slide is already processing, and then this install thing will come later. See. Yeah, here. Then let's look at this slide first. So here, like pip3 install PSLab, and if you have like an older version, I think I'm correct, but Alexander also can add stuff, and he'll do a live demo only focusing or mainly focusing on PSLab Python tomorrow, so you can learn more about this. So if you have like an older version, you have to use upgrade to replace it. And what we also need is this magic open sound control. So if you're like in the terminal right now installing, you can install Python OSC at the same time already. Hope that I'm not saying anything wrong, and it's like this. I'm checking the chat at the same time. If anyone is like, no, you can't do upgrade in this way or something, like, as I said, I'm not super Python expert, but I like using it. Processing is something that I have a long-standing history with. Processing was the way that programming was introduced in art schools back in the days when I was going to art school, specifically digital media in Bremen at the art school, and their processing was like the new thing. I remember that someone from some Fraunhofer institute was saying, okay, like processing, that will become like the big next thing and so on. And it has been there for quite a while now, and it's has come now in a lot of like different flavors, because like Java is less popular. I think it's still very popular for server-sided programming, but a lot of people use JavaScript. So there's like p5.jas, what's basically similar and the same, but uses a little bit a different language. There's also a Python mode. So if you're into the Python thing already, you can also now use processing to do your Python scripts, or to do your processing scripts. You can use Python. Basically, the graphical user interface is very similar and basically shared with Arduino. If you had the chance to use Arduino, there's C++, but it's kind of like a simplified version of all of these things in general. What's really nice, because I've initially learned Java like the classical way, basically, and before you had like a small window that you could use, you had to write a lot of code. And in processing, you can just write one line of code and say like you want a line from this point to this point, and then it will execute it already. So it takes a lot of like burden that was with Java beforehand and makes it easier, and that's what we'll be using.
Yeah, I see here in the chat there are some questions about the installation of the Python OSC package. This is now the point where I always think, wow, software is so complicated. As for on my computer, all worked fine, and it took 5 minutes. But earlier in the morning, I tried it at my son's computer, and he has a Windows computer, and there it was not that easy. So if it happens to you that there's something going wrong, don't give up. we will put you through, and you can ask your questions here in the chat. And I'm positive that, yeah, we will get the systems running. Oh, there was someone happy.
While you're trying to solve this, you can also start the download for processing if you don't have it on your computer yet. And yeah, just select the right package basically for your operating system.
Yeah,
I think it's really cool to have processing. If you don't know about it and you're more like a engineer type of person, it's really like a nice way also to do visual things and to basically sculpt your output, because I think it's always very fascinating, or that's kind of my way of working a lot, that I jump back and forth. I just write, look what it changes, look at the output, and it's very iterative, and this is probably not a classical planned structured way, but for me this is really a nice way to put things where I actually want them.
Yeah, the processing adventures in the last week are really were very inspiring for me. It's nice sometimes if you have data, not to just see them in a plot, but to just have colors when you are over a certain threshold, and then suddenly your monitor turns red, and there's like a stop, a press stop or something like that. That's very interactive and makes debugging things much more fun. Okay, here.
Also, just as a quick note, if because we're in a workshop, so if anyone wants to turn on their microphone simply while, instead of having everything in the chat, we can also speak to each other. Of course, if you have a question or some comments or something, you can just turn on your mic and join the conversation.
Especially if you have problems. I really like to solve problems. So if there are problems, then please let us know. We collect them, and then if we can't solve them today, I will have the day tomorrow. A lot of fun. There are some the sensors that you can connect with the PS Lab, and when you have the package PS Lab Python installed, you can read out the sensor data, and then you can put the data into the OSC protocol that helps you to transfer the data wherever you want to transfer.
I don't see you anymore, but now I see you again, so.
Hi, yes, my camera decided to, oh.
So these funny paper clips are not Clippy from Microsoft Word. They are just some imagery to say there's a connection between these different elements, basically, and it's some kind of chain. So the sensor is connected to the PS Lab. The PS Lab speaks to PS Lab Python. PS Lab Python, we make something that uses open sound control and then sends it to processing, and then in the end we have some visual output.
Yes, and I'm back here again. I think my camera decided it wanted to sleep a bit, but now I'm here again. Okay, I think we can go to the next slide. Next.
Open next.
Okay.
From open next to open sound.
we have, first I want to talk a little bit about open sound control. Yeah, I was very irritated when Daniel told me, let's use open sound control. I was, okay, sound, yeah, it's always nice with sound, but it's music, but we want to transfer all kind of data. And then I found out, whoa, actually, with open sound control protocol, you can transfer all data you want in a very simple way. And I was very embarrassed because I hadn't heard about it during my whole university time. And I enjoyed it a lot because it's really simple. So thank you, Daniel, to introduce me to open sound control. It's really, you can send all you want in a very nice way. I don't know what's your background with sending data. There's I don't know, lots of possibilities to send data. In the past, I used a lot of, I don't know if you know that LoRaWAN. Have you heard about it? Via the TTN network, or of course Wi-Fi and Bluetooth, all these nice protocols. What I have to say, this is a new thing, open sound control, and I'm very happy to have it now. Yes, please, the next slide. Okay, I want to show you one example that there you can see a sensor. It's like a radar sensor, so it basically measures the movements of the hands, and it's trained that special movements are connected to special sound, and there is a software used that we will learn more about later. Yes, but please, let's just start the video. Oh, someone tries to talk.
Hi, my name is Theo.
I just can hear the sound of the video when I press the play button.
The world's tiniest violin with a soli. The world's tiniest violin with a soli.
And here's your microphone is still muted.
Hi. Okay, Workinator was another discovery because you can do machine learning in a very simple way. Yes, check it out. It's a very, very nice thing to do. We won't use that so much today, but we will talk a little bit more about it. Okay, please, the next slide. Okay, Open sound control is very useful if you want to remote control microcontrollers. For example, I don't know if you know the Node MCU microcontroller. It's a very simple USB-based microcontroller, and it's nice because you can remote control it from your computer with USB. Very simple when you are on the same Wi-Fi in the same network. If you are not in the same network, it's some more steps, but it's possible too, of course. And I really like this example because it helps to show students very simple IoT experiments. And this example, the link here will bring you to a site where it's explained very simple and very nicely. If you next time want to remote control a microcontroller, then think of it. I think it's a really fast approach. Okay, next slide, please. So there
is an extra slide I added.
Nice.
No, but yeah, but you. I'm just because you don't know the slide yet. But continue, please.
Yeah, I didn't know the slides, so I'm curious what's on it. So yes, of course, Daniel knows a lot of more things you can do with open sound control. And I see here some more software things that listen to open sound control protocols. And of course, I don't know them. Maybe you can tell something more about them.
Sure. Pure data is really cool thing if you want to do like visual sound programming. Basically, it's by the inventor of Max MSP, like the proprietary version that was developed at IRCAM back then. That was called Max, and then there's like some extra modules MSP, and it's quite nice. And Miller Puckett was like then afterwards making an open source version, and that's Pure Data. And Pure Data is really cool. You have like little boxes basically that you can connect with. Yeah, like I don't know the terminology, but you have like a signal that you can push a button and it goes visually through all your little modules, and it's very interesting to look at and to use. Tidal cycles is like a generative way of programming algorithmic music in some Haskell way, and it's really nice also. Short presentation on Monday also on titles. Yeah. Processing has been around for a long time, but now there's also open frameworks, and for performance reasons, because it's like based on C++, many media artists use open frameworks, and it's a big development community that's very active. It's great to see, and there also, if you want to check it out, have your OSC code running. It's quite simple to use the examples that are out there already. And there's Vekinator. Harnish, do you want to put something?
There's someone shared his microphone with us. So if you want to ask a question or say something, you are very welcome.
Then I'll mute you. If you have to unmute yourself if it was on purpose, if it was accidentally, because it happened to me earlier. So sometimes one restarts the session and the microphone is on right away. So please unmute yourself if you, or write in the chat if you if you feel, because otherwise there's just some noise on the line. And Vekinator, yeah, check it out. It's from Rebecca Fiebring. I think she's in London right now. And yeah, I never really understood machine learning properly. And on the one hand, I think it's this magic thing that can do everything. And then it's kind of simple tasks that it does in the end and so on. So I'm still figuring out my way through it, but I think it's a very hands-on way to use Vekinator. Yeah, maybe you want to give it a try. So this slide is mainly there to say, okay, like open sound control, you can use it in a variety of contexts, and it's really cool to have it running so you can adapt your code if you want to have sensor data from the PS lab and send it basically anywhere. OSC is a really good tool to do so.
Oh, that's my slide. I just want to add something about machine learning. I did my master's thesis about convolutional neural networks, a lot of machine learning around, but I have to say it's still always a bit magic inside. So the Vekinator thing really is really inspiring and helpful because it's very practical. So very nice to check it out. Okay, we have here a slide that shows us the pipeline for today. So if all works nice, then you will get your PS Lab data with Python. If it doesn't, don't worry, be prepared. In our GitHub repository, a Python file that just gives you a nice sinus signal, and you can pretend that it's from your PS Lab, and we try to help you to get started with PS Lab. But first you can play around with the sinus signal. And we will create an OSC message, which is really very simple. And then we send this OSC message over our local host to processing, and there we just need one function that listens to a special port that we can choose, and voila, everything is ready. So it's basically not a lot of steps, and if it's working, it's a cool tool to have for all kind of things. Okay, please, the next slide. Oh, yes, now we start with creating our first OSC messages. Okay, first I just want to show you how simple the code is that you need to pack a string message into an OSC message. So first, it's always important, this import thing here in the first line, and then you need an IP address, and the IP address that is shown here doesn't go to the big internet, but to your local host. I'm not sure how familiar you are with all this client and web things, so don't worry. The only thing you need to know is this number always stands for your own computer, and it doesn't send the data somewhere else. And then the next thing is the port, and the port, it could be any number, so I just choose this number. It's just important that you use the same number on the receive side. This otherwise would be confusing. And then there's two more lines. The client lines, where you have client.sendMessage, and the next you see some address. This can basically be all. It can be, I don't know, motor or bag or animal, whatever word you want to choose. Just remember it, because it needs to be the same on the receive side. And then I put the string hello here, and it would send a string with hello in it. This is basically all, and this is basically the basic Okay, next slide, please. Okay, now it's time to get hands-on, and of course I don't want you to to copy that in this very inconvenient way here, that you we have the GitHub repository. Just put the link in the
I shared it in the chat already.
Yes. Oh, we shared it already. This is good. I shared again. Okay, you can't share often enough. Yes, and there is one file. It's a Python file, and the name is Sinus2 processing. Maybe put it to the chat. It's the name of the file, and it should be the same as here on the slides, if I haven't changed anything the last things. And when you open this, you have probably another problem if you don't have try to run it if you found the file. This will take a second. It might be that you need to install another package, the matplotlib. If you use Anaconda, it's already installed, but it's no problem to install matplotlib.
We can also have a few minutes where everyone who is struggling to install something at the moment, or like to open something, can like turn on their microphone, and we can try to guide you through it so that everyone is at the same level of preparation, basically. Because each of you should be able to have like Python and processing on your computer, even if you don't have like a PS lab at hand. And then, yeah, we can try the sine wave. So feel free to just turn on your microphone or write in the chat and try to collectively guide you through it. And I think there are also a lot of like people here that know much more than I do. So maybe this can also be like a joint helping effort to get everything running, that we're all in the same situation. Does it matter if it's Linux or Windows? Is it about processing or about Python at the moment, David? In general, it should work on any common operating system. But yeah, I don't know. Sometimes there are weird things and one doesn't know why, but processing should get it running basically. And Python you also should get running, but there are always like weird things that we don't know how to fix or something. Like, what was the thing, Sarah, that you had with the Python OSC this morning? What were you trying on Windows, and did you find any way to do it, or like?
No, I just found kind of an idea how to do it. There was a path problem, that it was something, it was installed, but somehow the directory was wrong, and this was very weird, and I googled it, and it seemed to be a common problem. and there was something about path match that does too much work, and there's somehow a way to do it manually, but I did not follow that line because I was in the Windows world and I was a bit afraid of destroying the computer of my son, and he was looking very worried at me. Okay, nice. So, is there someone who has a problem with this NumPy thing, or with the with matplotlib? I put it chat because this is sometimes a package that you need to install. If there are some problems with this sine wave thing, it might help. Okay, I think there are some people that are very that have a good and nice running system. For them, I would like to go to the next slide, and then we can go back to the problems later, because I want to hear all about it. It's always very interesting what problems appear and to learn about more things. Okay, for the people that wonder how to connect the PS Lab with processing, it's just like this. And the file in the GitHub repository, the name is osctest.py. There you will find this, and what does it do? It takes the measure, it measures the value of a resistor and puts the values into an OSC message. And how you need to connect your resistor to your PS Lab, that you will see on the next slide. So it's, I hope you can, it's big enough. It's on the right side, or of course it depends how you hold it, but for me it's on the right side. There's like a long line of plugs, and it's a very small letters. You can read RES, that means resistor, and if you have a resistor at home, this is my little resistor I always have at home, then it's very simple, because you can plug your resistor in, like you can see it on the slide. If you don't have a resistor button PS Lab, then you might have something like little jumper cables. So of course then you will have the resistance is 0, because there's no resistor between them, but you can check if your PS Lab connects with processing. So this is just the cable to connect these both dots. A little hack for today for everyone who has no resistor at home. There are questions how to connect the resistor to the PS Lab, then now it's the right time to ask them.
Also, if you happen to have like a light-dependent resistor, you can also connect that. That's what I did, where you can see like where my pencil points in my screen image basically And it's really nice, like, because like, yeah, you don't have to make a voltage divider, as I mentioned before and so on. You just plug it in and you're ready to go. And if you turn the PS Lab around, you'll see the things in bigger letters also. And then you can translate, basically. It's sometimes easy, sometimes not. And there you have the buttons, and also like for measuring capacitance and so on, it's right next to it, I believe.
Yes. So what's the next step? I think that, yeah, this slide, we can go back later if there are some more problems, is that I would like to show you some nice examples on processing. So we go away from all our Python things and packages. Oh, there we have someone who wants to ask a question. No. Or maybe it was just a... I hear something, but I'm not sure if it's on purpose, but it's interesting. Okay, I think it was not on purpose. So I hear a lot of children. Okay, now it's time to open processing. And when you open processing, I want to give you, it's very simple to get started with it. That's what I really like about it. I would like actually to share my screen now, and that's, I think I should take the presenter then, isn't it like that? Or okay, I just do it.
Please do. But, yeah, give it a try. And
okay.
Hello.
Hello.
Which file should I open? The one from the PS Lab main folder that I downloaded from the GitHub. Is it pslab2 processing.pde, or is it osctest.pde? Or
I think Sarah knows, but she seems to be disconnected right now because she's trying to pull the thing. No.
I
Sarah,
can
you
see.
back there?
I can't connect my my camera back. That's interesting. Oh. Ah. Okay.
Yeah, there was a question which processing file to open.
To open, the first processing file to open is the it's the, let me see, it's the OSC data dance.
okay, cool. Thank you.
I put it here in the code. Yes, somehow I have problems with sharing my screen. I think I'm.
Hello, Sarah.
I think I'm still presenter.
Sorry to interrupt. for presenting your screen, you need to take the presenter right from Daniel. So if you can see a plus icon on the left hand side, then you need to click on that, and you have to click on take presenter. Then you'll able to present your screen.
Thank you very much.
No
I think
problem.
now I
And-
have the presenter.
Yes,
And,
you are presenter now. Yes.
All running. but so I couldn't publish, but there were a few people with a PS Lab. Was really cool. Yeah, I was just about to press the publish button, but it doesn't matter. But now it's working, huh?
No problem. All the best. All the best.
Thank you.
okay, just plug in my adapter. That helps sometimes too. Okay, I have now presented now I can share my screen and one second. Okay. That gives you more time to open processing when I'm so slowly here. Very good. Okay. Now we should see in some seconds my processing window. Oh no, there's another error. Maybe it's more simple if Daniel shares his monitor and I just tell him where to click. That's probably the better way. And it would be great if you just could open processing and share this on your screen.
Okay, let's try that.
Yes, that's better. I want to
okay. I'm not prepared for this right now, so let me
That's
first
much more fun for
find the file and open it in processing.
I don't want you to open the file and processing, just open processing, because then you can show a bit around in the processing what is possible to do there, just without opening our special file.
Yeah, let me try to open our special file already. Also,
If
then we can
you
use
manage
that
that,
at
that's
the same time. So that data dance, right? OSC data dance?
Is it? Yes, that's it.
Right. So it needs to be in a sketch folder. Okay, please do so. And
Thank you so much.
Let me see.
Welcome.
If this
Hi.
here is some.
Yes. Now we can see the file.
Is this, is it big enough like this, or do you need it? Can you read anything right like this? So basically, I'm sharing through my image. So if you make my image bigger.
Yes, and what you can also do, like take the presenter right from Sarah, and then instead of the PPT, you can share that particular code file, or else your screen, Daniel.
You can try that also. Then we have it on that slide deck instead.
Yeah.
So,
That's a good moment for all the other people that don't have Python installed or running yet to try to solve the problems there, because processing is really very intuitive and we don't there we won't have trouble at all. So the first thing I think that is interesting about the thing now is that we need to install kind of a library package, and it's working a bit like Arduino. I think the whole thing looks very similar to Arduino if someone is familiar with that. And Daniel, now you show your monitor, and could you show us how to get this OSCP5 when you go to I think it's on tools in your yes, that's right. And then okay,
Funny though, it doesn't show the window that opens.
Yes.
So unfortunately, but yeah, are there libraries, or is it import libraries?
It's actually yes, import a library with.
So it's sketch, then import library, and then add library.
Yes.
But it opens in a new window.
Oh la la.
So let me select that other window. Let me see what's here. The contribution manager. Allow.
Yeah, for me actually, when you go to this include a new library, and then it opens another window, it's contribution manager. I think that's the same you just said before. 1 second.
Can you see it right now?
Yes, no, I just did it on my computer, the contribution manager. And then you can search for OSC, and then you it will show you OSCP5, and the author is Andreas Schlegel.
Andreas Schlegel, by the way, is also based, or last time I met him, he was also based in Singapore, so probably he still is based in Singapore. Yet another Singapore connection. And yeah, there's Control P5 and OSC P5. These two things, these two libraries you should install.
Okay, I just give it. I just try to explain it very slowly again. So you have opened processing. Then you go on the top of your window to sketch, and then another little window will open, and then you choose import library. And when you choose that, then there's another thing. I have the German version. It's I think add library. It will appear add library, and when you choose that, then a new window will appear, and this is the contribution manager. And in this contribution manager, there's a field on top.
Can you see it, by the way? Because I'm trying to share it, and like so you could. Do you visually see it?
Oh, I actually can see it, yes. And there you choose OSC, or even when you choose P5, I think you it will give you the right one. It's OSC P5, and then you choose it and install it, and that's all. I think that should work. Oh, there we have someone in the chat, and he wrote sketch 0 library. I'm not that sure. Patrick, maybe you can explain. Is that a question? Yes. You want to just a tap? Okay. Just was wondering. Cool. Okay, now when you have the library imported and opened our OSC data dance, then Daniel, please hit the play button on the upper left side, and we will see what's happening. Woohoo! Earth will explode.
Probably not much yet because I don't have the Python thing running yet.
That's okay. That's okay. I just want to show that it's now listening to the port that we have on the sender side. It's, I think, 12,000, and it's listening there. And now when you start your Python script, the sinus wave, for example, then it will receive the data. Yeah. Okay, now we see the output of processing. You have 3 white dots and the black background, and this would change into red immediately when processing receives data from Python. So it can be all kind of data. It can be the data from PS Lab. It can be the data from the sinus signal. So is it possible for you to start the Sinus to processing Python file from GitHub? I know that's a lot now. It's like James Bond needs to run a program that stops a bomb in 10 seconds. I know.
I don't know, but like somehow there's a lot, like my computer tries a lot at the moment. So, but let me try.
A red colored rectangle. Nice. Wow, Daniel, yes, now it's the sign that it receives the sinus data. Wow, look at this. Every time it receives a new data, it gets the processing file will change the position of the dots and the size of the dots. So that's where the fun starts actually, because now you can all kind of data, you can use them to do fun with processing. But it's, oh, now Daniel is away. I think now his computer is angry at me.
No, I just turned off the camera to so, because your sound on my computer is a little bit stuttering, so I'm not sure if it's on my computer basically. But I can still hear you well.
Okay.
So that's why yeah, now it's better.
It's better. And in the processing file, if you see the code of this sinus thing, then you see the lots of ellipse functions, and that's where the magic happens. The ellipse parameters get changed by the input of your data. And of course, now it's our prepared data, but it of course can be the PS Lab data. And I'm just curious if any one of you here already could make it run the file from processing. Maybe if there are questions or someone who has an output and a red rectangle or something different, then please let me know.
I could also add, maybe just like for people that have never looked at processing, I'm just sharing your code here, and what you can see is like that line 1 and line 2, there are these like 2 inputs. set imports for the OSC, and that's like the main thing also in Arduino and in processing, that you have like one first thing that in processing is called setup. This is like run once, basically, at the startup. I think, I'm not sure what it's in Arduino, but that's the same concept. So everything that you want to define at the beginning of starting your program, you put into this loop. So for example, that the screen size of your window should be 800 by 660, that there's like a black background, start the OSC object that you defined further up as a variable. And then you have this thing called draw in processing, loop in Arduino, for example, and this thing runs over and over and over again. So this is basically like an endless loop. This part runs once in the beginning, and then this part runs again and again and again. And you can create like methods and things. So for example, this is like provided also by the inventor here of the programmer of P5, that you have this event checker that basically does most of the job for you. And I think, Sarah, you edited that it should look for an input in the channel sinus. So that's what you can change. So these methods are basically outside and they do their own functionality, and it's being called, let me check, how do these events actually work?
It just updates the OSC value when it sees a new one.
And then it updates all these elements basically.
Every time it's new, then that will be a new input.
And it only does it if it's bigger than 0.
Yes, yes.
And then it changes the background. And yes, it's very close. Yeah, I think processing was first, and then there was also wiring back then, like Ivrea, the interaction design school that was funded in the same town that Olivetti, I don't know if any of you remember the Italian hardware company Olivetti. I know them because I started my first computer experiences on a Olivetti basically. And so Ivrea was like this interaction institute, and they created wiring, what was like basically the predecessor to Arduino. So like very the same different board, and then there was wiring on the one hand, and then also Arduino, and they all share the same graphical user interface basically. And this has been around for more than a decade now. Some extra info.
Yes, some more extra info. Thank you, Daniel. Is if you need inspiration with processing, they have lots of examples included. On the top of your window, you see File, and when you choose that, there will open another window with examples, and when you choose that, there will be lots of prepared Java code where you can learn how to create rectangles, how you can animate images, how you can, I don't know, set background colors and all things like that. And it's like a nice thing to do in the afternoon when your family watching a boring movie. Then it's perfect to test all those things. I did that like that. Yes, it would be yeah, maybe nice if you try something out, for example, to change some parameters in the ellipse function. For example, that I have their OSC value times 100, and when you change it to, I don't know, 500, and you can see what is happening with your output. That's very nice. And then I want to explain why of course, the sinus signal has negative numbers, and the negative numbers would kind of irritate the processing thing like it is now. That's why I put the square function to the ABS to make it positive. Yeah. I wonder if there are questions.
Me too. And you can also like look at the code, and I don't know if you have it running and if it works, but maybe there are things where you're like, what's that good for? Why is this in there or something?
Yes, for me it was interesting that this address line in the OSC event function could be all I wanted, and that was of course my first mistake. I wrote another address in the Python script than in the processing script, and was wondering what's going on. It's not working. It always needs to be the same. So when here we have sinus, then it needs to be sinus in the Python script too. And I think in one of the code we provided on GitHub, there's still some address is written there and not sinus. So if your code does not run, could be because both of the address names are not the same. And of course the port, it's very nice thing. You can just choose one port and it's listening to it. We have 12,000, don't forget a 0, won't listen to each other. It's very simple, so it's just important that you have the right port and the right address for it. And if you don't want to have red as background color, then you can try to change the background color here. There's written background 255.00, and if you put there 0, 255, 0, then it would be blue, I don't know, or green. I'm not sure, but it would change definitely.
Green.
Green,
I
wow.
think there's RGB, yeah, in this situation. But you can also switch to other color models if you're like,
wow.
Yeah, want to experiment.
Yes, and okay.
No, I was just wondering if, if we shall do a little break at past maybe or something, like within our long session.
Yeah, because the next example is really cool and much more challenging. I think it was very inspiring to see for me what's possible.
I wonder, like the microphone, turning on your microphone and so on, you can all do so, no? Like you don't need any special, you don't need to do anything special for you to be able to turn on your microphone, because we can also like chat a bit simply audio-wise and hear what's working. Maybe you know processing already and you have used it a long time. Maybe it's something new to you.
Or maybe you have a very cool, simple Python environment that you want to recommend to us and other people that work in education and want a very fast way to show it to people. But if you are shy like me, I can understand that very good. And you can just write in the chat. That's a lot of fun too.
Should I try to switch back to the presentation mode?
Yes.
Works.
Wow. Next, James Bond. This is some inspiration to learn processing. You have there lots of examples. You learn how to use coordinates or how to use the drawing function. And there are other Java examples there. You need just to hit the play button and see the output and can change parameters. That's very nice.
And there's a lot of things that one can try out in processing, actually. And it's really nice that there are these examples and you can really just like, I don't know, like change a value here, change a value there and see what it does. As it is Java and not Python, it's very peculiar about like the semicolons in the end, each line. So if you have a command, you always need the semicolon. Whereas Python is very particular about like where you position your code. So it's just different ways of ensuring that you're very precise with what you're doing. Clara, do you want to turn your camera on again also? It doesn't want to work anymore? The camera decided it's enough. Did enough for today. No need for extra camera anymore.
Yes, I think if you do a little break now, then the people will want to try some more processing examples in that break. It's a good opportunity. And then after the break, we will learn something more. What will we learn, Daniel? Tell me, please.
We'll just continue, but we'll use a different sensor and like jump a little bit back to the PS lab and yeah, do another example of visualization in processing of the data that gets forwarded. So that's the plan.
Great. And what kind of sensor do we use?
It's an ultrasonic sensor that's very commonly available, and it's being implemented directly in PS Lab, so it's very easy to use. It's called HCSR04. That's the name.
Okay. So what do you think? 5 minutes break?
Yeah, sounds good. Then I can then I can make myself a coffee. And also, everyone feel free to, I don't know, like chat during that break. Also, you can turn your microphone on and talk about random things if you want, or very precise things. Yeah.
Yes, that's a good idea. I will have a coffee too. And now it started raining here.
Yeah, how's the weather in Singapore, for example? I'm new in Singapore, right? In which other cities? How's the weather in all the different cities that you are in? You're probably in a lot of different cities.
coffee break. I have a big pot of coffee here, and there are some problems with the presenter modus, but it's not a problem, it's another challenge.
My coffee is still boiling, but I'm a circle now. I like circles too, but circles can't present. No. Only change my status to no. Now I am presenter again, and I'm still a circle. That's interesting that this is possible.
So what kind of coffee do you have, Daniel? Do you have like a fancy coffee or just a water and coffee?
Espresso on the stove, but it's not through yet. Now it's boiling. So I go for that 1 second.
Then I can tell you something more. Green tea, that's good. But isn't that very late in Singapore right now? And you drink green tea in the evening and will be awake all night? I just have some very simple coffee, but I really like it when it's very strong, and I just put lots of coffee in and then lots of water on it. That's the magic of coffee. Yeah, always without milk. Lots of coffee.
I have milk. And
You
I
have
have Brezel. Everyone likes different things. What's next on the slides?
Yes, we are very curious what's next. That's again the how do I receive your OSC data. It's just to see that it's important that you have the right name here at address on the receiver side. And actually, what else can you see there? Yeah, that you wait for a float value, then that you look for the address pattern and you can print it in your processing just to see, to make sure you receive the right thing. And of course, the values where you can print them and check that on the receiver side. You all have this function in the GitHub repository and the processing files. Okay, next slide. Yeah, we already did that. OSC test receives data and displays them on your display, and if there are no data coming in, then the display will be black, and if you receive data, it turns red. It's very nice to see if the pipeline is working. And then we have OSC data dance. This processing file will give you the red background and the 3 dots that change position incoming value, and you can connect all kind of data with this both things. Okay, next slide, please.
I would also I would open the. I'm just trying to open the OSC test at the same time, but I'm getting a little bit stuck within all these different windows that are open. Here, yeah, needs to. So let me just share this because I think it makes sense to look at this also just to have like a different patch that's running. So OSC test, share.
On OSC test, there's still problem with negative numbers. It won't display the negative numbers, just the positive ones. It gets a bit crazy with negative numbers. That needs to be a bit better code.
But here you see again, so you have like the import in the beginning to be able to receive the OSC data. It creates a OSC P5 object that's not initialized yet, and there's like a float that's initialized with a value of 0.0. And then you have your setup loop, basically. It's run once. This time it's a little bit a different size of the window. If you leave this away, by the way, if you just leave it as is, and then it's 200 by 200, I remember. So that's what I mentioned earlier, that processing is very forgiving, that you can, you can start with very little code and still get a result, so you don't have to go this like steep learning curve of first learning how to create a window object and so on, how it was in the beginning of Java. Then there's like here background, 0 is like black. So it's like if you just put one number, then you have like gray values basically from 0 black to 255 white and everything in between. But if you add like 3 numbers, then you have like RGB. And here the object that has been initialized up here is actually being created. So this is the code for that. And you see also that there's like an internal port that is listening to. So in this case, 12000. I think in the examples that we'll look at later, there's a different port. So you always, if something is not working, you can check, is the port right? And also, as we had before, here, but here it says some address. Maybe that was the reason why it wasn't working right away. So I'm not sure.
Yes, this is there's still some address, and on the sender side, in the Python script, we have Zinus. So it's better to, you have to change this one line. It's just to keep you awake.
So not only coffee, but also extra things to keep you awake. And it's late in some places now already, no? Like in Singapore, for example, it's past bedtime for some people. I don't know who has like the latest, who's attending at the moment, who has like the latest local clock. So back to the code. So here there's the draw thing, and you always, I don't know, like you have these brackets always from here to here. What's new in processing, but I don't know, like I don't know how new is that if you make mistakes within your code, it shows you right away. So for example, even if you're like, it's kind of like if you're typing, it says, oh, like, I don't know about a class called strings of. So it's very responsive. Earlier days you had to, I don't know, basically test compile and it was showing you error messages, but now it's right away. You can write text very simply, and also change fonts and so on, and put the positioning through these values. So if you want to move things around, it's like X and Y, so you just change. You know in general that you have this overall size of 640 by 360, and you can also use variables, like if you use like height and divided by 2, for example. I know this would be width because it's X and Y. Width divided by 2, it should be like somehow in the center, the X value. So through this, you can also like generalize your code better. So even if you change your window size, it adapts basically to what you're doing. Yeah, and here you have to put the corresponding address, and I think we mainly use float values in our examples at the moment.
Yeah, and could you try the code when you change the address to Xenos, and you can just use the same Python script? Is that possible? Yay! Very good.
Well done. Let me restart the sinus to processing code and see if it shows something. It shows something on my computer.
Shows something. Oh yeah.
Can't see it right now, but I have to switch windows. I'll just do so.
Ooh.
So this is OSC test and not with processing allow. No, it's overwriting.
The negative values, yeah. If we will see positive values, then it's working again. We should have started with and now it's 0. That means no.
So how do we live fix that? So you say where are the here? If I put ABS in front of this,
I can't see your screen now, but it sounds like the right thing. Look at this. That looked good.
so better.
Yeah.
So now it's positive values. And why does it happen that negative values confuse? You know?
I think it has something to do with the data type, probably, that it doesn't show the minus sign with float. But this is something I think it's the first thing you find when you Google it. I was just lazy when I implemented it. Just was thinking, okay, negative, you can't read the numbers. It's enough information. I know it's negative.
So this is very red. Let's try green. So I'm changing something.
Oh, yes.
No, it also overwrites something. Oh, now you don't see anymore. Now it says error message. Stop sharing your green screen.
I think it's probably because all 100 values are already received and Python stopped working. And you don't get the data.
Okay, let's turn the screen sharing off. But you can also now it's green on my thing. It also
yes, that's cool.
And it's a very neon green. If one just says like the standard RGB green. So let's continue to the next. Now we're back to the PS lab. So for those of you that actually have a PS lab at hand, and also have this HCSR04 sensor, we can go through connecting it together. And I can also share from my side how it's working. Let me switch my screen here. So as you can see, the sensor itself, and you see that, 4 different pins, and it's ground, echo, trig, and VCC. And if you connect them, I'll switch back and forth between the 2 slides, I think. But here you see how one connects them ideally. So you need like jumper wires and the sensor and the PS lab. And yeah, like if anyone, Sarah, do you actually have like this sensor at hand also? Can't hear you. So I run my processing connection. Basically, it's take your time in connecting it if you have.
Now I'm back.
Now
Okay.
you're back.
Yes,
Cool.
I could not unmute. I have actually not the same sensor. I have another ultrasonic sensor type, but I will try to make it run with it.
Sure.
1 second.
So if anyone has this set up and needs help connecting it or something, please let us know.
Actually, I found one, but it's in another prototype. I will disconnect it.
I have disassembling.
It's an old people counter, and I just take this away. And here we have this friend. And there's always a lot of cable on my desk. Yeah, it's very useful to have that. Got all the cables. Yeah, lots of different ones.
So I have it running on my terminal already. I can maybe share the screen of that.
Wow, you are super fast. I'm still at the cable point because
I had
there.
prepared already.
That's so good.
I must admit. And
Okay, cable ready.
so here you see values basically, and if I put my hand in front of the sensor, you see that the values get smaller. If I take it away, it gets bigger. And what you see is values, float values of meters. So at the moment, this sensor that you see here is like pointing basically at the bottom of my standing desk. But if I move it, then it should hit the ceiling. And as you can see, it's 2 meters and 12 or something from the position of the sensor to the ceiling at the moment. And this is also like being transmitted through OSC to eventually processing. So if you're in the Zarapedia PS Lab GitHub, the 2 files that you need is like the pslab2processing.pde and my script file actually. I think that's that in there already. No.
I was a bit slowly with connecting the sensor. Would you mind to go back to the slide where I can see how?
Sorry. Only numbers.
Thank you.
So maybe you also should tell me what's better, because there's this view that's made with fritzing, where you see the connections, but then there's also this one where you don't see the connections as wires so well, but you have the written connections. So I'll just switch back and forth, I guess.
I have a question on your table. Why is YCC a square wave and not like 5 volts, or is it a typo? Because you see there's a voltage control and there's square wave 2. And shouldn't that be like 5 volts or something like that?
It is, but because like this, it's easier because the pins are closer together. So we're using square wave 2 in order to turn on, to give power to the sensor basically.
Oh, thank you. And could you go back to the fritzing file again? I want to check if I could do that with fritzing.
Sure.
Thank you.
1 second. And probably your wires will be different. And maybe you can share also.
Okay. Ground connected. Ah.
So here you can see the Python code. I don't know, do you have it also, Sarah? Maybe you can put it on the GitHub. I think it's not there yet, if you have it. So you can see here, like import Science Lab from PS Lab. Then there is like an external that's this specific sensor. the HCSR04. You need to import time, import a UDP client for the connection, and then give it a little bit of time to catch itself. so a small sleep. And here you can see I chose a different port. So I chose 1, 2, 3, 4, 5 as a port for my processing example. Then you initiate a new science lab, initiate the distance sensor. And here's the thing that you were asking about, like where do the 5 volts come from? Why are they coming from square wave 2? And this is from the original example, basically, in the documentation. And I think it makes sense because it's very close together. So it's easier to use it in this way. And then everything is prepared. Here we send 2 inputs and the code to pull the sensor data is like distance sensor dot estimate distance. So this is like this variable you find here, and then there's this function that you can call simply. And this does all the magic already. And then being sent. And additionally, I added like here, like the printout also, so one can follow it in the window as you saw before to check. And there's also some sleep in between so that it doesn't give too many, transmit too much data in too short time. And perfect. Thank you, Sarah. So you can like download this file from GitHub. So this is like the Python side again, and then we can switch to a processing example in a minute.
Yeah, the name of the file is pslab2processing.py. When I tested it first, I had some problems with the first line, with the import line, and if you experience the same problems, then just change the first line of the pslab2processing.py into the same line that you used with sendosc.py. It's just the import from blah blah blah. It's a little bit different. But on Daniel's computer, of course, both work. Some people are just happier than others.
It's funny, no? How like different operating systems somehow Python wants different ways. So you changed. So the difference is in the Python code, right?
Yes, the difference is in the Python code. So I would first just try pslab2processing.py as it is, and if on the processing side it's listening to the port but nothing arrives, that was what happened to me, then it might be helpful to change the first line, this import simple UDP client, and make it look the same as in our first example, the sendosc.py. Just a small difference. I looked for it forever and was happy to find the mistake.
Can you still hear me? Because now Now there's like not much moving anymore in my browser. No.
Can you receive the data? Is it working at your computer now? And then I have a question about Pocket Science Lab. I was very happy that I could borrow one and learn about it. And there are probably different versions, because I found out that the pins are on some images in the are different in the internet than the one I have. So it's always when you use Pocket Science Lab, and for example you see here the fritzing, it's always good to have a second look to your pin connection. You have the same Pocket Science Lab that we have provided here. So mine one looks very new, and Daniel gave it to me 1 month ago, and I was able to try it out. Yes, and it made me very happy, and because it's in my lab, it's we don't have so much budget for like development engineering gadgets, and it's sometimes we like last month we had a workshop where we built lights for bikes, and you know you need there an AC to DC converter, and it's a bit sad if you don't have instruments for all the participants to measure the AC values, and so with PS Lab it's possible to do that. That's what I really liked about this hardware. So yeah, I think the thing with the pins is, yeah, it's the same. I think if you are used to hardware, then you know it's always important to have a second look if it's the same like in the layout you have. And here it kind of yeah, it's just connect your VCC to the here it is the square wave. I think here on the fritzing it's square wave 2, and the trigger, which is the yellow cable, you can connect to square wave 1, and the ground goes to ground, and this is all a bit small on the written here, so it's important to have like more looks on it, that you don't mix it up, so that the code could work. And then you just connect it and use the sinus to processing.py to read your data into processing, and to get the data from processing, you just can use one of our PDEs, like the OCE test, for example. That would work very fine too. I think Daniel has a crash. Oh no, you are back. That's good.
I'm back. Yeah, like somehow like I had these running numbers, and then they were not running anymore, and like the screen sharing, I don't know, maybe Firefox was unhappy with something, and then I restarted the computer, but now I'm back.
That's always a good thing to do. Yep, could you please go back on the slide with the table where we can see what the table with the connections? That would be nice, because I want to recheck something.
Maybe Michelle, you're in presenter mode right now, right? Maybe you can change the slide 1
No,
second.
I'm not.
No? Can I be again? I don't have any. I can't.
But this
I'm
is
not a presenter.
because I was here when I connect my cable. I see that this LA1, which is the green line on the right, which is probably Logic Analyzer 1, that there's a second LA1 here, and right under the FOSSASIA logo. And this probably is the same Logic Analyzer and just another plug for it. Is that true?
Again?
There are just 2 Logic Analyzers on the PS Lab, and one has the name Logic Analyzer 1 written in words on my board, and the other one is just LA1. And is that are they both connected? So I can
I think there are
choose.
more. I think I remember there are more, but if I had access to the slides, I could jump to the specs.
You won't get the presenter right back.
Okay, then I don't need to.
It's the secret of the LA1, but of course it's possible. I just can try it. It's the same. But if it will give me the same values.
But you have like on the small side basically, where the green wire is connected at the moment. There you can see they have like 4 different Logic Analyzer pins. The first ones, if you turn your board around,
yeah, I see them.
On top for 4 of them.
Just try them. That's fun.
Who can upgrade me to be like I want to be a square again, not a circle anymore.
I'm very happy that we have this slide when you are not a presenter anymore, because it's a very helpful slide, I think.
It's true.
Yeah, could be worth sine wave 2.
I also would like to share my processing code, actually.
So it's connected. The Logic Analyzer 1 and Logic Analyzer 1 are the same, just to let you know. Do that. Let's see. Good. Yeah, I think that's a good time for questions, because until you get back your presenter modus.
Maybe no one has questions. But maybe ask some questions, because then we know that you're still can still hear us.
And that would be bad if someone connected the wrong cable and now there are some serious injuries. Don't hope that. No, that of course cannot happen.
Maybe we're in a parallel universe.
I think we are. Just with the numbers of the sensor. Maybe it's not just
but wait, I have a trick because I have my OBS. So let me see. I can.
Now it's hacking the system.
Yeah, that's always good. One should always find ways to do that. But cool. So now, for now, hides the slides. Someone can see my PS Lab board bigger. And then I can here you see my sketch, right? Also, yeah, can you see this?
I can see it.
You can? Cool.
I can. Very, very good.
You cannot?
I can see it.
You can see something?
Yes.
Yes,
Great.
cool.
You hacked it.
Good. We hacked it. That's perfect. Yeah, so yeah, but I would like to also show the output. Wow, that's advanced hacking. Check. But that's I'm really missing like the real workshops with like people. I think it's also really good to be able to do this online, but it's also really nice if one can just sit around in the same space and yeah.
Especially when the weather is good.
Yeah.
Not like here.
So do you see a black circle?
Yes.
Cool. Yeah, this black circle is there if you have it running for a long time. So if I stop it and then start it again. Nice. Wants to. You can see down here that it's receiving the values from the distance sensor. And so now a different window now.
Now I can see a very black background and
Yeah.
yes, and your code.
Presenter mode, please. Back to presenter mode.
Maybe when your system crashed, you crashed the whole system of the whole conference, and now
Yeah, maybe everyone is crashed, and we're just in this loophole.
Yes,
And
it's very quiet in the chat. I write here, so let me see. Because you see, there when it crashed. Yay! Someone can see us. Hi.
Cool. Hi, Econ. Very cool. Let me try my hack thing then. Maybe I can. It'd be easier if I hack to share like a whole my whole window.
I could use some whiskey too. This is a great idea. I think I have some somewhere, but it's too early.
Different time zones.
Yeah. But I really like your hack with the presenter mode. It's very nice. I think I can see the code better than before, actually.
Cool.
I can enlarge it more.
And I'm trying also, let's see. Wow, disco. Here.
I can see that. Show me.
Let me see. Oh wow, I have disco on my screen. You too?
Yes. No, I just can't see the code. Still
because there's OBS is running twice now. Oh. Oh. Stop one. I like the hack, actually. So
yeah, no one needs presenter mode. That's
no.
Cool.
Yeah. Let me window capture again. Then create new window capture. No, not window capture.
I'm very curious about your disco.
Wow, now it's pretty disco.
I want to see it. You're just pretending there's no disco.
There is no disco.
Show me.
So, what do you see now?
I see the sketch. I still see the sketch.
And do you see it? Do you see another sketch next to it?
Oh, I have to scroll, make it small. No. Now I just see the slides.
Oh, the slides are cool.
That's the slides. But I really would love to see the disco.
Yeah.
I would love to see the disco. Please.
Now, do you see something now?
Now I see your name. And now, yes. I see a red dot.
A red dot?
And a black.
Okay, black dot. Black dot is what we want.
Oh, I promise I had no whiskey. It's just the coffee. I see a black dot. I repeat, black dot.
Yeah. So this is how it starts, and then if you change, like now I'm on my hand, and sometimes you see that it's getting out of bounds basically. Up here was getting out of bounds. And I think in certain situations when the ultrasonic sensor sends a signal but doesn't get it back, then it provides like a strange number basically. And these are like the big lines that expand further than than the circle is.
That's very useful to see in a graphic like this, because then you see if it is a pattern, and if you use this sensor and this hardware and you know the pattern, then it's no problem. You can just calculate it out, and it's a very nice way to look at it. It's much nicer than just look at numbers.
And for example, like now the sensor is like pointed at my desk. So you see it's a very small dot. It's only 20 centimeter dot, basically. And if I move the sensor a bit, it's still catching the camera. Yeah, now it's at the ceiling. So this is like 2.12 meters, basically, that one sees there now. Yeah, and we can have a look at the code for that. And I think then we also, yeah, maybe then it's enough, or we just play a little bit together and try to hack a new example. Oh, magic screen capture. Oh yeah, oh yeah, oh yeah. What did I want? I wanted to have different window actually. But maybe it works like this, but you can't see anything like this because it's not big enough.
I can see it when I enlarge it to full screen. It's perfect. I see it really good now.
Oh, cool.
Yeah. So.
But can you read the code actually? Or is it
Of
small?
course. That is seeing. I just see red dots.
Here now. Here, yes, no, yes. So if we go back to check. Here. Now it's bigger again.
Yes, now it's perfect.
Cool. So let's look through this code, basically. So it's again the same story. I'm still confused because mine is if I mark things yellow, it doesn't show. What happens if I write something into a comment? No.
Don't write something, then you will finish the system again.
But it would be nice to have presenter mode again.
Simple. That's too simple. This is just a test. And it's very nice actually that you found a way to share the code again, and it's really good to see it. Oh, now I see your desktop.
Messy desktop. My messy desktop,
Right.
but now it's
And
gone again.
I'm very disappointed then that it's not a picture of me, so you should improve that.
Yeah.
Lots of.
How do these Twitch people do this, actually?
They're just younger.
They have it all running at the same time, and they know exactly how to do it. No, actually, I also think I know how to do it, but it's just not updating code. So presenter mode, please. Presenter mode.
No. Now something's happening. I see a black screen.
Yeah, that's good.
And now I see a picture of you as a little child.
Okay, now again. This.
Yes.
Now I can pull this big
Wow.
fake presenter mode and good, I think. Yeah, so let's go through this. It's nice. So like, I'm glad that there's still people watching and participating. So again, the same thing. So these libraries that we looked at earlier, import OSC P5 by Andreas Schlegel and the net P5, then initiate the object, create the float for the OSC value that you also can not see, but it's like running through in the bottom line basically. Then I added like a R value for the radius, and then I found this nice code by Daniel Schiffman, who's like one of the main contributors to processing, and it's about polar to Cartesian. So the example is polar to Cartesian, and that's where I got most of this code from and then just manipulated around. So basically an angle, a velocity that we're not using, and acceleration that also stays the same, but I thought it would be nice to have like basically like a clock situation, like a watch that's just running and displays the data. So there's again the setup loop. I'm not sure why I chose 640 by 360, but something. Background is white. Here's the OSC P5 up again with this 1, 2, 3, 4, 5 input address. There's this initialization just probably to have the circle really fit onto the screen. So it's 0.45, the height times 0.45. Then there's some velocity that I set in the beginning just to have it moving, the circle, or the lines that are being drawn in the circle, because otherwise it stands still. Here I did this trick with width and height. Well, maybe it was in the code already, but so it's like perfectly centered within the window, regardless of if you change the numbers that are there. And here I define the radius, and I say it should be the OSC value times 50. And this is pretty much trial and error, because I knew, okay, like the maximum that I can reach in my room is probably something like 3 meters or something. So this was basically my way to determine the boundaries. And here's the conversion from polar to Cartesian. Probably you know more about this, Sarah. I think you did a lot of math also during your studies.
Yeah, it's basically in one sentence, just that you don't use x, y in a space that is like a rectangular. You're just using the space of a circle. It's just a transformation in one sentence. There's much more fun about it, but complicated.
Not giving up with the presenter mode. Then there's like ellipse mode. So if you make a circle, oh, Schnapps would be nice. There is, you can say, okay, like what's the reference point basically. So if you draw an ellipse or a circle, also a square, you can either say, okay, the orientation point should be the left upper corner, or it should be in the center, and so on. So there are these different modes. And here this just defines that it should think from the center of the circle, basically, or the center of the ellipse. And no stroke is, I'm not sure exactly why. You have like no fill mode because, because it's a line, and that this determines the color of the fill. Maybe stroke is only for rectangles and ellipses and so on that have a filling, and then and for line you also use stroke. No, you also use fill. It doesn't really make too much sense to me, but maybe because the line is the fill then already, or I'm misunderstanding something. But basically what it does, it's like it starts from like a certain value that's calculated up here, and then it draws a line to the center. So if you want to try like the most simple processing code, I think if you just write something like, just open a new file and then just say line, and then from 5.5 to 15.15, for example, then it should already make a small line in your 200 by 200 image. Yeah, here's like this acceleration thing, but basically I just wrote that it's 0.02, so that's just sticking with that value. And here our OSC event again, as in all the other patches and sketches that we had. Here it's inputs, and it's looking for this float value. And if I use my ACT screen capture tool again, you should see the values down there that are still running. And if I put my hand in front of it, you can also see, okay, like there's like 12, 13 centimeter between the sensor and my hand right now. There is like a if you go for smaller values. Cool, I'm moderator again. Perfect.
Well.
Yeah, so you can see these values change, and it's also really nice for just playing around, also maybe for generating music and so on, because similar to the light dependent resistor that you can just plug in there, it's very easy to have changes, whereas if you plug in, for example, a temperature sensor, so like a resistor that changes according to temperature changes are much slower, basically. Yeah, and we still have 18 minutes on our clock if we want. And I grabbed the presenter mode. And I am going to stop. Oh no, that's there.
That's very good that now your code is working on my computer too with their import line without changing it.
So did you change anything?
No, I didn't. It worked just like this. Now I didn't need to change anything. It worked. That's very nice. Yeah.
Yeah.
So
And
both are working.
very cool. Yeah, strange that had a change there without changing anything.
Just 3 days before I needed to change this from the Python OSC import line did not work.
Yeah, I wonder what this sometimes is. Now I have another thing. Now I am quite big. I can just drag and drop in between my shared image and the slides basically, but now it's like the circle again to get it bigger. I learned that. Here's like the code again, but we looked at it already. And I don't know, there's already the thank you note. because I'm very happy about that we are still so many people, and we can still do more and chat a bit, and if there are any questions and so on, also happy to chat about it. But in some places it's pretty late already, and some people might have started drinking whiskey already in some places, so we can
start that too. I think now it's 4 p.m. here. It's okay to have the first whiskey. What I really like about your example here is that it's a very good way to teach this transformation from the coordinates, because polar coordinates are very important when it comes to engineering, and it's a very intuitive way to see how you get from an XY value into polar coordinates. I really like to use that because of helping people with math.
Mm-hmm. Yeah, and it's also really fascinating to see, like I recall that there are also these like old images that are basically these distortions of images. So if you look at them through like a lens, or you look at them through the reflection of some object. Cool, now your camera is working again. There are very cool ways to, also with like, I don't know, like GIMP filters and so on, to just translate an image into something that then if you reflect it, it will show the proper thing again. So if, for example, like DALL-E did these things with bottles that are like fully mirrors, basically. So just like imagine a wine bottle that's made from mirror material, and you put it on top of like this translated image, basically. And I imagine it's a little bit like these polar coordinate translations. And then you put this thing on there, and then you can look at it, and then it's a skull, for example, that you can like look at from all perspectives. And I think it's really nice. There are great examples in art that use this.
There's
Maybe we can do
file. It's about perspective transformation, I think, in the processing file examples. And this is a lot of fun too.
Cool. Maybe we can do a final feedback round or something, now that we still have 13 minutes left. Whoever is there and wants to turn their audio and or video on and test the system, it would be nice to see some of you.
That would be very nice indeed. And you can recommend us a whiskey if you want to, if you're already drinking. I'm a bit high on coffee because it was very strong.
Cool. Hi, Mario.
Hi.
I can see you. Can't hear you though.
Yeah. So guys, unfortunately, I had to drop out a moment because there was something to take care of elsewhere. But I think this was a really nice way to share about the topics and also the examples, and people really loved it. What you can do, and
and things like multiple destinations is Ember.js specific, so I want to keep it as.
Hang on a second, where does that come from? From HP Day. Okay. Yeah.
Oh.
So we have.
Hi, Sarah.
Hi.
Yeah. So I think the challenge is we are all not in the same room, and not everyone is a visual person or a listening person. People are haptic, or they want to have different influences. And you really achieved to do this, to give us a kind of sensual feeling. Yeah, like some sensual thing. Like, yeah, so I liked it. Yeah.
Thank you.
Thank you, Sarah, very much for your time and for the workshop. Yes, I saw a lot of activities on the chat. Thank you very much. And Daniel, are you there, Daniel?
Yeah, very cool. I'm curious to also see maybe more of the faces that are still there. I just saw Alvin.
Yeah.
Yes,
Alvin,
very curious, especially in the countries with better weather than here.
Yeah.
Yes, I think this is. I think this is the last workshop of the day, and we can actually invite the audience to join us if they want to have conversation with Sarah or Daniel, or they want to say hello.
Yeah. And I know, for example, Alexander is in Sweden. He's here. Actually, know a few people here personally. Mishari, are you? Do you have to take care of your kids going to bed at the same time, or you're still around? Yeah, Mishari probably has to take care of his kids right now. So, but like, what is your own impression, Daniel? Like, because like that was also the first time you did this workshop, right?
Yeah. I think like 3 hours are longer when one is like in a virtual environment somehow. Like, goes quicker when you're just hanging out in the same room. But I think it's nice to see, and I think I really like the ways that one can connect the PS Lab to all these different platforms, and it's probably like different use cases or something, but I think it's really fun because if you want to, for example, do like machine learning with Vacinator and want to try it out, I think you have like a tool now to do this, and then you can like have a playful way of interacting and trying and so on. And I hope that there was some input that you can use and reuse, and I'm curious to hear about things that you built from that, basically.
Yeah, nice. And so I also would like to know about the tool. Should we like encourage people more to switch on their image right at the beginning of a workshop? Should we, like, for example, rather use Jitsi, that is more like a homogenic way, like people are more like have the similar rights, or like, do you have feedback on that?
I think it depends a little bit on the size of the workshop also, like, because we were quite a few people now in the group, but I think if it's smaller sessions, then Jitsi is quite nice. But I don't know, I think it's both really good tools to do so. And yeah, sometimes it's simply nice to also like see the images of the other people and so on, and see who's where, and I don't know. So it's probably a nice thing to yeah, we did a little intro round of ourselves, but maybe next time one can also do like a little intro round of everyone who's participating and who wants to share a little bit something. I think it's very nice to see. But as Sarah said, we're also a lot of people are shy and don't want to. Someone has to take this into consideration as well.
Yeah. So, and I want to know, like, in regards to the technologies, because like it's also not every day that you like, you know, fiddle around in one thing 3 hours. Sorry, was it? Don't know. So what's your impression? Is it working out? Like where are improvements needed? What do we need to change on the Pocket Science Lab side?
I think there's like a lot in there, and I think if people think it's useful to use like open sound control, for example, maybe one could add this to the desktop app, for example. Like maybe it's a good way to have an easy interface without having to go to the Python backend or something. But I'm also not sure. I think we're still curious also to find out about, yeah, who's like using it as coming more from like a programming background, who's using it coming more from like a pure science and biology background, and like, so I think depending on these user groups, that's probably why the PS Lab has all these different ways also to access, like through this Android app and all these other pathways. And it would be nice for me to get a better picture of who's actually feeling comfortable with which ways of interacting, so one can add these functionalities. And yeah, and I think a bridge like this is already a nice start to try out and send the data to any other location in the network, basically.
Alvin, opportunity, but you didn't switch on your microphone. You basically need to click on the headset and then click again on the headset until it shows a microphone. It sometimes takes a few seconds. Yeah.
Now it might be working. There's at least no microphone crossed out on your screen, Alvin.
No, but like you can see it on the left-hand side. If there's a white button, it means he didn't activate his microphone somehow. So it's a challenge to do that, but at the same time, like we also have, yeah, I mean, that's a different topic. Let's not discuss this here, the challenges of running a video event. So Homfolk, but you dropped out a moment. I think I shared my point, and maybe like others want to share their points.
Yes, I just want us to ask what happened today and then show the schedule of tomorrow. So today, I think the first day we learned a lot. It's a little bit bumpy at the beginning. We try to get the team going, and we learn also to do that 5% seem to work so well with big blue button that we need to inform the speakers in advance so that we can avoid like wasting time in the beginning. I think the in my opinion, I think that the channels is quite good with for questions and answers. So I see it's more structured so that we don't have to overlook so much. Hey, Sarah, you are back.
But I can't hear you. No.
You cannot see us?
Oh.
Oh, so I don't know what to change. Yeah, so we can see you now, Sarah. I also see Alvin, Mario, and Daniel sharing his screen. Yeah, so is there something else that we learned from today that we can improve tomorrow?
But I'm also like thinking specifically about the workshop of Daniel and Sarah, right? Because that's still what we're talking about. Yeah, I see a lot of interaction, and I see that quite a few people attend, and potentially I think we can reach out to more people next time. Yeah. So I hope you want to give this workshop again, Daniel. I hope you enjoyed it.
Yeah, like I think it's really good. Also, Sarah has so much experience with like running things like this, so I think it's really nice to do another version. And yeah, thanks a lot for the opportunity, and I think it was really cool.
Nice. Okay, so I see like that nobody else is putting on their camera or running their image. I see Alvin is still trying to figure it out, and I think we have other ways to connect with him. So I would give back to Will and Sarah for their words before we close this session, I guess. I'm dropping out.
Yeah, thanks a lot for joining. And if you make anything cool and like use it and continue and so on, like keep us in the loop. And yeah, there's also more sessions on PS Lab and on the PS Lab Python and so on. So just check the schedule in order to see more. And on Monday, I'm also giving a short presentation on musical interfaces with PS Lab and tidal cycles, this algorithmic sound generation tool that I mentioned in the beginning. Thank you all for participating. Thank you, Sarah. Thank you, Hong Fook, Mario, Alvin. Thanks a lot. Bye-bye.
Bye-bye. Yes, so if you have any feedback for anything we can improve, please feel free to on the chat. I share the schedule for tomorrow. We are studying at 10 in the morning. So I hope that my internet connection is more stable now. Yes, so again, thank you very much everyone for today, for the speakers, the trainers, and for all of you who join us here today. If you have any feedback for us, please feel free to type it on the chat. We will try to minimize the technical issues for tomorrow. And just a quick look on the schedule of tomorrow, Sunday. So I put it now in Singapore time zone, and we will start at 10:30 in the morning with the workshop, continued workshop of Open Robotics with Marco. Introduction to ROS and Gazebo. He did a talk today during the morning, and got a lot of interest from the group. So tomorrow there will be an in-depth workshop. And around the world. And then we have the keynote of the day. So Bunny Huang will join us tomorrow for the keynote, and right before that we have the firmware and hardware panel. Yeah, and then we also have more topic on hardware, OpenTab. Mario introduced a little bit earlier today. And after that, there will be a talk from Eric Pang, the founder of SecureDrop. We have in the toward late afternoon, we have a tutorial from OpenTab project, and our guest from Brazil talking about the ventilator, an open hardware device that they developed during the pandemic. And we have more Pocket Science Lab tomorrow in the evening. Yeah, tomorrow also a series of lightning talks. Yeah, and similar to today, the Web and Python workshop. Okay, so once again, thank you very much, everyone, for your time. Please feel free to hang around. We have the chat. You can either use the chat here or you can join the chat room. Is the other workshop still going on, Mario? The other workshop, I think they finished already as well. Yeah.
Yeah, so this is the end of the day, and I think
we cannot hear you, Mario. Are you speaking?
No. Okay, so give me a moment. Basically, yeah, people can join us in the room, in the discussion room, or just like continue talking to others in the chat. So have a good evening and see you tomorrow. Bye.